attending today's RxJS live conference. So we have one of our sponsors here with us. So I'm just going to quickly ask him to introduce himself. Hi, Matt.
Hi, Jen. How are you?
Good. How are you doing today?
I'm very well, thank you. It's great to be here. So I'm from Adaptive. I'm the CEO and co-founder. We are a financial services technology provider. We build front office trading platforms for banks and hedge funds, exchanges, firms like that in Europe and in North America, as well as in Asia. And we've been
attending today's RxJS live conference. So we have one of our sponsors here with us. So I'm just going to quickly ask him to introduce himself. Hi, Matt.
Hi, Jen. How are you?
Good. How are you doing today?
I'm very well, thank you. It's great to be here. So I'm from Adaptive. I'm the CEO and co-founder. We are a financial services technology provider. We build front office trading platforms for banks and hedge funds, exchanges, firms like that in Europe and in North America, as well as in Asia. We've been around for about 8 years, and it is fantastic to be able to support RxJS, Rx, and the approach it takes to enables to building applications is something that is right in the sweet spot of the sort of systems and platforms we build for our clients. I myself was using Rx back in 2010, 2011. I was just looking through my emails to try and find when I got my job that got me into Rx, which not the conversation for now, but is really the job that changed my life. So I hold Rx very, Rx means a lot to me, and it's fantastic that RxJS is going as strongly as it is with this fantastic conference.
Oh, okay, very interesting. So yeah, talking about Adaptive, I understand that you co-founded this with colleagues of yours. Where were you all before you formed Adaptive?
We were working for another consultancy, working for a bank, a French bank in London, and that project is actually the project that we used Rx on. So we picked up the first libraries of Rx that came from Microsoft back in 2010, 2011, I think it was. We were writing a Silverlight app that then migrated with Silverlight app on the front end with .NET on the back end, that is now being rewritten in HTML5, and we were big users of Rx at the time.
Okay, so it's a longer history of Rx than with the team. So this is great. So can you tell us about why the mission, vision, and values of the companies speak to you personally?
Absolutely. So when I met the people that I started the company with, and indeed that team that worked on the project I just mentioned, we managed to put together a group of individuals who were fantastically great at collaboration and innovation and sharing of knowledge with each other. When we started the company a few years after that, we really wanted to have the same culture, an engineering-led culture where developers and other people involved in the software development lifecycle are collaborative, innovative, open about what they don't know as well as what they do. Because we found that when we were in that environment and delivering fairly complicated, large-scale projects using cutting-edge technology, that approach of being able to say, I don't know, meant you learnt 10 times faster than if you pretended you knew. And also meant that the team itself delivered a better job, which was a really, really enjoyable environment to be working in. And so that we've encoded in our mission and values about being a great place to work that enables innovation and collaboration, exactly that feeling that we had. And I think the fact that we've got Josep speaking at the conference, he has picked up that innovation and collaboration spirit, and is a great example of it.
Yeah, I'm really glad that he reached out, to me with regards to speaking at this event, because obviously RxJS is closely tied with the Angular community, and I'm glad to actually have someone speaking about React, because obviously it's used with other frameworks as well. So yeah, it's really wonderful that we have this talk today.
Absolutely.
Yeah. Okay. So do you want to talk about like the products that Adaptive has at the moment, and like who are your like target customers?
Absolutely. So we like, as I mentioned, we build custom platforms for large investment banks, exchanges, and firms that work on what we call the buy side. So investment managers, asset managers, hedge, and we're involved in a part of their world that is they call office, which is around liquidity discovery and liquidity distribution. So that is electronic trading. So those are the screens that you see when a journalist is standing in a trading floor and they've got a computer screen behind them and there's lots of numbers flashing, sending prices, and people entering deals and buying and selling large amounts of FX or equities or corporate bonds, all on screen. So those are the systems we build for our clients. And those things are characterized by streams of information. So a price stream with a price changing every 4 or 5 times a second is just a stream of information. To us, it's an Rx stream, and we model it as exactly that. And we use Rx on the front end in HTML5 applications through RxJS, be it with React or an Angular, as you mentioned, as well as on the back end. So we use Rx libraries like RxJava or Rx Scala on the back end to implement the same sort of composition and control of the streams of information that are flowing around the systems we build. We differentiate ourselves in the market by building platforms for our clients that they then own. So we're a technology provider to some of these very large firms, and we compete with other technology providers, so product firms that you might have heard of, like NASDAQ Technology is a good example of a product firm that sells into the space. What we do is bring technology that accelerates the delivery of projects for our clients, and then we build bespoke on top exactly what our clients need. So the developers and the engineers that work for us are involved in project work, building very complex, fast-moving, great-looking platforms for our clients that are very, very high profile, that mean a lot to their business. It's really, really critical for their business that this stuff works. So we put a lot of effort into quality of engineering, quality of testing, quality of design, and quality of requirement specification, because we understand that our clients are spending a significant amount of money with us to build their platforms, and that they run their businesses, which deal with quite a lot of money on a daily basis, and that we need to give them some of the best engineering that they can have, really.
Yeah, I can relate to that because I used to work for Citigroup.
Okay, there we go.
Yes, I'm very familiar with like financial systems and all that. And yeah, definitely, like we I think used to subcontract a lot of the projects, especially with like that project I was involved with, which is currently rolled out in 100 countries. Citigroup has a presence. It's a big project, and like internal folks, there's not enough really to build, this massive thing. So we have, a lot of other companies, and independent contractors working for us. And of course, there's always, that focus on making sure that we get quality, products and results from people that being paid, to deliver and do the job.
Exactly that. Yeah.
This is good. So speaking of innovation, what are you most excited about in terms of technology? Are there other things? Obviously, you're heavily in RX. Are there other things that you folks are like exploring in terms of like innovation?
In some ways, financial services is very innovative from an engineering perspective, in that it is really focused on very high performance, low latency systems, and demands a lot from engineering teams like ourselves. And in other ways, they can be quite slow moving. So we moved to Rx in 2010 and have been using it in all of our projects since then, which I think is quite fast moving, given Rx is still being talked about and picked up in the mainstream at the moment. But then in other areas like the cloud, financial services is quite slow moving. So one of the areas we see great amount of innovation and excitement is in the ability to bring cloud native application architectures to front office trading platforms. We have built in the last couple of years quite a few platforms are running on the public cloud. We won an award for that work earlier this year, actually, which was fantastic. And I think that the ability to reduce the amount of money needed to be spent on capital infrastructure, like hardware to put into a data center, and instead all the benefits that everyone at this conference understands from dealing with the cloud, right? The fact that you can just spin up infrastructure very cheaply and deploy and configure really high quality production grade infrastructure that would otherwise cost you significant amount of money and time to deploy physically. You can just click buttons and deploy configuration to get exactly what you need. That is where I see a huge amount of innovation coming from. Anywhere that lowers the cost of anything I should say that lowers the cost of experimentation and the cost to get going is fantastic. And I think we're going to see a lot of innovation in that space, particularly with the more broader adoption of things like Rx, where streaming and the concept of streaming data streams all the way through the UI and from the back end becomes more prevalent, will enable a lot of innovation as well.
Yeah, it's very interesting. This move to cloud, because I remember back when I started a long time ago in Citigroup, like I was deploying like changes to production, and I have to like physically like go to a
copy things up, right? Yeah, like, exactly.
Like with all this like big machines and so it's totally different now, which is really great. I should said it's lower cost and it's much easier to deploy things. Definitely, like I'm used to like the usual SDLC model, but now it's all agile and you can deploy like daily if you want to, right? So it's totally a different environment, and obviously it's a welcome change for everyone. So are there new projects that Adaptive is looking into at the moment, or you're just continually building things for clients?
We're very busy with client work at the moment. On our internal workbench, we have an application called React-RxJS, which for those that are going to attend Josep's talk during the conference, we'll see him show. That is where we do all of our sort of research and development, I guess you could say. It's an open source application, so people can take a look at it and understand the how we put together these sort of highly available streaming applications for our clients. As you would know, having worked at Citigroup, most of the things we build are pretty tied up behind NDAs and confidentiality agreements, and they're not particularly retail or consumer facing. These are enterprise applications used by other businesses, which means they're not that visible, unfortunately. And indeed, it's sort of a joke, but really the best time you do see the sort of applications we build is when a journalist shows up in a trading floor and you see it on the screen of someone behind the journalist, right? But the research and development we're doing into React-RxJS at the moment is fantastic. We've just rewritten the whole app, or Josep has rewritten the whole app to take advantage of RxJS, and we're now rolling out that architectural pattern and style into our projects, hugely improving the performance of the applications we're building for our clients. And after that, there's always change in the ecosystem. So front-end applications in financial services are supported and run within web containers. They don't just run in a normal web browser. So platforms like OpenFin, like Mosaic, like Glue42 are all systems that our clients use to host and run their applications. And that system, that world is always innovative, and we're spending a lot of time keeping up with those features. And the other thing that we're seeing quite a lot of at the moment actually is around something called interoperability. So this is trying to bring the workflow style and feature you have of data interoperability on your mobile phone. So for example, the ability to share an address from one app into Google Maps, for example, and do something with that address onto the desktop. Web applications are fantastic for being able to mash up different data sources on the back end, so having APIs that you can call to bring in applications from different service providers. But there has been relatively less innovation on the client side, enabling me as a user to stitch together different workflows from this web app to another web app running on my desktop. To do this sort of integration myself in real time in response to things that I want to perform. We're seeing a lot of innovation there, and there's an open source consortium called Finos that specializes in financial services, and they have a group called FTC3, which I think is really going to bring a lot of innovation to the space, and we're big believers in that.
Okay. Yeah, I knew Joseph's talk will be very interesting. And initially, we allocated half an hour for his talk, and I was saying to myself, okay, this is probably the first time we're having someone from the, working, and using React with RxJS. So I said to him, do you need more time? Initially,
and I'm sure he said yes.
Minutes, it's fine. And then we went to 45 minutes, and then eventually we ended up, I think we ended with an hour. So I'm really looking forward to that talk. And we've been highlighting that as well in some of the communication, that we're sending out, because as I said, I'd like other people who are using other frameworks to, check out RxJS and anything Rx really. And we also have Matt Podwysocki, who actually started, RxJS a long time ago. Obviously, then Lesh is now, the person who's been working in it in the last few years and have put in definitely a lot of, personal hours, getting it to where it is. And RxJS 7 obviously is getting released, around now.
Yeah.
So yeah, it's
the buzz is great. I remember Matt from the conference circuit a few years ago when I was going to different conferences and talking about the work we did and showing how we used RxJS and the applications we built. It's fantastic, the effort and the energy that he's putting into it. It's really great.
Yeah, definitely, and same with Ben. I think both of them have contributed a lot. So yes, so yeah, we appreciate all the work that people have been putting in. I mean, these are all obviously open source projects, and no one's getting paid to work on this. So yeah, it's we're really appreciative and thankful of people from any open source project really who are giving their personal time to come up with with better products, and obviously this are being used by a lot of companies. RxJS in particular, I believe, has got, if I'm not mistaken, around 18 million downloads a week. So it's it's pretty massive. So imagine that big project being maintained by a small group of people who are not being paid to do this. So
absolutely, it's fantastic.
I really encourage people from the community to contribute to these projects. And also one thing I'd like to stress is that they have to be patient as well, because there are people who can be demanding even with projects like this, which are like maintained by people who are volunteering their own time. So I think we need to have a bit of patience with regards to people not responding to things, recognizing that this is really not their main job. So have a little bit of patience there and contribute where you can. Basically, I think it's for open source folks out there. So anything else that you want to highlight, Matt, with regards to adaptive, or are you like hiring at the moment?
We are indeed hiring. If anyone would like to come and work for us, please get in touch with myself. I'm sure my details will be available by the conference. Absolutely, get in touch with me. Have a look at Josep's talk, the style of application that he's building. Then that is exactly what we work on at Adaptive. It's not pretend. That is the style of work we do in the language and the tooling that we build our applications with. If that sounds exciting and cool to people, we are definitely hiring all over the world. So please get in touch from wherever you are.
Yeah, so where are you present at the moment? I know you're in Canada and the US, am I right?
That's right, Canada, the US, Barcelona, and also Spain and England and the United Kingdom as well. So offices particularly in London, Barcelona, New York, and Montreal. But we have people working from us pretty globally. We've got clients in Asia as well as North America and Europe. So just get in touch if you like the style of work.
I was surprised that you're calling in from London, because when I looked at your bio before this call, I saw Auckland. So I said, oh, he's going to be coming in from New Zealand. It's a bit late, or over there.
Very late. Yeah, no. I've been in London 15 years now. So London's my home.
Yeah. Good. Okay. So thank you for that, Matt. And we'll obviously encourage more people to watch Joseph's talk. I definitely am, looking forward to that. And yeah, thanks for joining us today. And yeah, we'll share more information about Adaptive in in a newsletter that's coming out around the conference. And yeah, so check that out, folks, and check out Adaptive. Thank
Wonderful.
you very much.
Thanks, Jen. Enjoy the conference, everyone.
Hi, Ben.
Hey, I just heard a Mac boot up.
Sorry?
I just heard a Mac boot.
I know. Yeah, having problems with the other laptop, but that's fine. That will be fixed. Sure. Okay, how are you?
Not too bad. I've had a very busy day.
Yeah, I'm sure. Yeah, well, RxJS went live today, so yeah, you must have been very involved in that.
yeah, I was. Yeah, I was. It's the first major release in 3 years, something like that. So
okay. When did the previous one go live?
Early mid 2018, something like that. So
okay.
I have to look it up, but it's been a while.
Okay. And didn't you say in one of your tweets earlier that was it Alpha 0 went live on September 18, 2019?
Yeah. So the 7 Alpha 0 was September 18th of 2019. So it's been a while since that. I joked that RxJS 7 was older than the pandemic at this point. So it's been around a while.
Definitely is, yeah.
Yeah.
But there's one other funny thing about that that date. Remember when we met up in Austin to discuss?
Was it the same day?
It's the same day. Yeah.
Oh wow. Okay.
That's so funny. And then remember we had to postpone the March 2020 RxJS Live, the in-person one.
Yeah, that's
and
right.
we did it in September. September 18th as well.
Yeah. Well, I'm looking forward to this. I'm looking forward to this, and this is. I want all my future stuff to be in person though, because I miss seeing the people. It's a bit of a shame that once in 3 years we release a major version and I don't get to tell an actual audience of people about it.
Yeah, I know.
I have to tell my desk and listen to its lack of interest.
Well, at least you're going live, when there's an RxJS live conference, although it's virtual.
Right.
It's still at an RxJS event, so I think that's still pretty good.
Right.
Rather than announcing it somewhere else, or not even announcing it, just going live with it without any
Right.
audience at all.
Just to fizzle. That's what that's what we did last time. I think like it was mentioned maybe at NGConf, but it wasn't like announced, or there wasn't any. And in all honesty, too, this was not conference-driven development. The conference kind of gave us a spot to aim for, but we were in beta for more than a year, and it was time. We probably could have done it a week earlier, or a week later, or whatever. But it was time to get it out. So
okay, right, interesting. So are there a lot of big changes that came in with this release? Obviously, you're going to talk about it.
That's what I'm going to talk about. If I could give the whole thing away right now, and then people
would
just tune out.
No, don't do that. Yeah.
No, there were no big changes. Just we just published the same thing.
Oh yeah, there was a tweet, right? There's that bot that was picking up some of the changes and highlighting one or two.
So this bot, and it only picked up the changes that showed up in the changelog directly underneath the 7.0 release, which is just the changes since the last RC. And so it looked like we released a major version. All we did was fix 2 bugs and release it. So that's pretty good.
That's very interesting. Okay, I'm just trying to think. I think we're early, and hopefully Deborah, will be able to join us. I can see the tweets right away about her cat.
That's a shame. That's a real shame.
Yeah, but I'm really hoping she'll be able to join us.
It sounded like she was planning on joining us. It sounded like she needs the distraction. So. For those of you who are watching, Deborah Kurata had a very old cat that passed away today, and she's having a very bad day. So we'll have to be extra nice to her online. Yeah,
I know. I'm sure a lot of people are looking forward to her talk as well.
Yeah, I am.
Yeah, and the funny thing is, originally we were going to record her talk, and then we both decided, we'll do it live. And this happened. So okay, but anyway, I think we should just get started with your talk, because I'm sure you have a lot.
Yeah, I do. And it's a shame that we didn't pre-record mine, because then we would be able to edit out of all of my fumbling. But I think that maybe it'll enhance the live experience to see me stammer over my words a few times during the talk. That'll be good.
Yeah, but so everybody is aware. Ben and I have been discussing, obviously like conferences and all that, and the plan still is to have an in-person event for London and Asia, and who knows, where else. We obviously don't have a date yet, but as soon as we can do in-person events in the UK, we'll schedule one for London. And we'll see how it goes. Hopefully, people from overseas can travel to the UK by that time, because most of our speakers, I think, are outside the UK. So definitely, hopefully, travel bans are are lesser, at the time.
So hopefully, COVID is over by very soon. Very soon. There's still some parts of the world that are having a really hard time, and my heart goes out to those folks.
Right? Yeah, it doesn't feel like it's going to be over soon. Even though some countries, like we're lucky, I'm in the UK or in the US, and it's getting a little bit better. But given that other parts of the world, are still having really war situation. At the moment, it's not going to be over for everyone, until everyone's safe. So yeah, hopefully it gets addressed very soon. And I just want to mention Sunil, for example, Sunil Pai, he's doing, I think you and I both donated, and a lot of people from the tech industry donated as well. So Sunil's doing this massive effort of fundraising. So folks are watching, hopefully you can contribute something to help India and other other countries as well who are struggling to deal with the situation. All right, so
sure. Do what you can. I actually donated to Sunil's cause myself. So There are some people in dire need in India and Brazil and other places that are being very hard hit by this pandemic right now. So contribute if you can. I know I could, so I did. And it's important. It's a big deal.
Definitely. All right. So I think we better get started with your talk. When do you want to start sharing your
yeah, absolutely.
Okay.
Get the right window. All right.
Okay. All right. That looks good. We finally managed to figure out, how to share because you've got a very wide screen, right?
I have a very wide screen, so
you were struggling to make it work. All right, okay, that looks good. So I'm gonna love you and leave you, sort of, and I'll let you get on with your talk, and I'll be back at the end of it. Hopefully, we'll have some time for Q&A. So folks who are watching, just get ready with your questions if you've got any. Post it on the YouTube live chat, and we'll pick them up, after Ben's talk if there are any. All right. So Ben, good luck on your talk.
All right. Thank you. All right, everybody. So this is a big deal. Today is the day that RxJS 7 was released. It's not really a coincidence that it's today. We targeted today specifically because of the conference, but it could have been any day around here. It was time to be released. This RxJS 7 has been in beta for more than a year, and in alpha even longer than that. So as I stated earlier when I was talking to Jen, it's been out in alpha for people to play with since September 18th of 2019. So quite some time. My name is Ben Lesh. For those of you who don't know exactly who I am the RxJS team lead. I've been working on RxJS since version 5. I'm currently working at Citadel Securities as a software engineer, and I was formerly on the Angular team at Google. Prior to that, some people might know that I worked at Netflix and many other places before that. I've been doing this for about 20 years. So here's the thing. The big topic today that I'm going to be talking about is RxJS 7, because it was released today, and I want to tell you about all the wonderful things that come with this. And the high level is the number one thing that you should know is it's smaller. It's actually smaller and a bit faster in some spots. And I'm going to tell you about how much smaller it is. There are a lot of fixes to TypeScript typings. This whole major version was the primary goal of it. The getting smaller was great, but the primary goal was to get our TypeScript typings right, because the typings were very much suffering. Originally, RxJS 5 was written around TypeScript 1.8. We tried to evolve over time, and unfortunately, having typings and generics adds an extra layer to your interface that you can introduce breaking changes with. So it's like just another part of your API that we have to maintain, and we really wanted to get updated and get type inference correct. We also made an attempt to make some of the APIs more consistent and fix some of the bugs that were reported about inconsistencies that we couldn't really fix in the last version or without a major release, because people might have been depending on some of those strange behaviors. And we wanted to do another thing, which is move towards consolidating multicasting operators. So this has been an area of a lot of pain for people, is dealing with share replay, that sort of thing. And so we have a plan laid out and some new operators to use with regards to that in RxJS 7. And we have some other new features that I'll talk about as well. So the big story in RxJS, well, aside from the typing stuff, which I think is very important, is that it is a lot smaller. And this was done via a refactor, a 100-point improvement of just going around and individually moving around code, keeping the same tests, keeping the same code, and just kind of moving things around slowly but surely until we got to a place where we could see daylight, and then we were able to refactor larger portions of the code. But it was very much just pushing things around, and it was to make the entire library a lot smaller. It is currently, RxJS 7 is 53% of the size of RxJS 6. So that is, it's 47% smaller, or however you want to put that. It's about half the size of what it was before. And just like for a visual size comparison, you see here on the right, this is if you include all exported features of RxJS, including the new features that landed in RxJS 7. RxJS 7 is, you can see here, about half the size of RxJS 6. So this is a visualization of what would happen if you were to bundle, and this is actually done with an Angular build. So I took an Angular build, I gutted everything else out of it and just said, okay, use every single operator. And then I focused in on Source Map Explorer to what RxJS output. So you can see in RxJS 6.6, we've got about 93 kilobytes of bundle size here, and this is minified. Now, I took the exact same code and swapped it to RxJS 7, and you can see we've got 53, 51 kilobytes of actual code shipped for RxJS in the bundle. So it's much, much, much smaller. And the thing I want you to notice about this is that if you include every operator, the operators come at like a much, much smaller cost. Now, if you include every single operator in RxJS, it's 52 kilobytes in RxJS 6 and 19 kilobytes in RxJS 7. And that in RxJS 7 actually has more operators. And I'll talk about that in a little bit. Even though we're trying to reduce our surface area temporarily, we did have to increase it a little bit while we deprecated some things. And if you, at the bottom there, you see if you just include some common operators, this is just something I went through one of my projects and was like, okay, here's all the ones I'm using in a production project, and kind of took those out and looked. And in RxJS 6, it was like 10 kilobytes. And this is just for the operators, not for the other supporting things like observable and subject, that sort of thing. And in RxJS 7, it's only 4.1 kilobytes. So much, much smaller and cheaper to use operators. And again, like, you know, how did it get smaller? People might ask. I actually have some other talks about this. I'll try to link after, but it was not a big bang rewrite. So this wasn't like, you know, like Angular redoing Ivy or something like that. This was, there were several attempted rewrites that I did experimentally over the years that a lot of people know about, things like T-Rex and these other things, but those weren't really meant to learn from. And this was really done by, again, just kind of slowly moving code around in our code base and finding smarter ways to do the exact same thing that the current code was doing. And eventually we got to a point where everything was a lot smaller. All right, so the next thing I want to talk about in RxJS 7 is we have better TypeScript typings. RxJS 7 requires TypeScript 4.2. So if you are using an older version of TypeScript, you will need to stick with RxJS 6. That's fine. We're still supporting that. We'll be supporting that for as long as we need to. But we're targeting TypeScript 4.2 because it has some features that enabled better TypeScript typings. One thing that we did fix, and this is funny, is in older versions in RxJS 6 and under, you can create a subject of like a specific type, like number, and then not pass anything to next. And there's a reason behind this. The reason behind this was in TypeScript 1.8, it was deemed to be kind of gross that if you had a subject of void or a subject of undefined, you couldn't call next without passing undefined to it. Like it did not know what to do there. So they fixed that in TypeScript 2.3 or something like that. I don't exactly remember when they fixed it. But we were unable to catch up because it's a breaking change. And like so we had to wait for a major version to fix this. And now in RxJS 7, it's typed correctly. So if you have a subject of number, you can't call next without passing something to it. So if you do want to call next without passing something to it, you need to make sure that your subject accepts void as it's part of its generic. So then you can call it just as you see here and everything's fine. Another thing that came up, toPromise was actually incorrect. So a long time ago, when there was a lot of debate about how toPromise should behave, and it was decided, and this is specifically, I mean, there was some debate about how it should behave if your observable did not emit any value, like, so it just completed without emitting a value, what's supposed to happen to promise? Because a promise is a guarantee that you're going to get one value. And if not, it should reject. And it was determined, and it was very split, but it was determined at the time that toPromise should resolve the promise as undefined if it doesn't actually get a value. So here you can see an example where there's this observable that has a 50-50 chance to emit the word Schrodinger, which is like the Schrodinger's cat reference, and then complete. So sometimes it just completes, and sometimes it emits a value and completes. And if you use toPromise with it, like I did in this async function right below, you'll see that my value, it's saying it's always a string, but that's not true because you can see that it's actually emitting undefined in some cases. So this is in version 6. And in version 7, we fixed that to where now toPromise will always return a promise of T or undefined, because we have no way of knowing if your observable is going to emit a value or not. And this could cause some pain when you're upgrading, because now you're going to have to deal with the fact that toPromise is potentially returning undefined, which means if we're calling dot something on it or whatever right afterwards, it's going to complain. TypeScript's going to complain at you. It's very, very easy to fix for the most part, but it's a little bit painful. Another thing that we're doing in version 7 is we're deprecating toPromise. And this is because of this weird behavior. We don't think it's correct, but we don't want to break people any further than we already have. We just want to make sure that it's typed correctly. And we've introduced 2 new helper methods, which are last value from and first value from, which are not methods on observable. So they're more tree shakeable. You only pay for them if you use them. And you can use these to do the same thing. So last value from and first value from will actually, they always return a promise of exactly what it is that is a promise of T, not T or undefined. And they will reject if with an empty error, if the observable does not emit at least one value. And so you can handle this now in a try catch or whatever, which I'm showing here. The other thing is they're configurable. So you can pass a configuration object right after it that says default value empty or default value 123 or default value whatever you want. And if for some reason you do not get a value from your observable, it will return this default value. So it's a lot more powerful than the other one was. And you'll remember too that toPromise was the last value. So you had to wait not only to get the last value, but then you had to wait even longer for it to complete before you'd actually get the value. Now we have first value from, which I think is probably a more common use case. People just want, as soon as they get the value, they just want it to resolve and be done, right? So that's what first value from will do. And last value from is more like what toPromise did. All right, another typings improvement, functions that take n arguments will behave better. And so when I say this, I mean things like of here, for example. So in RxJS 6, if you had something like of, it would take at most like somewhere between 6 and 9 arguments before it would just be like, I have no idea what to do with this anymore. You're going to get like an observable of undefined at this point, because I have no idea what this should be, or I'm sorry, observable of unknown, or observable of like empty brackets in some cases, which is even nuttier. This now in RxJS 7, it will handle any number of arguments very neatly. Even if some of your arguments are union types or whatever, it'll figure it out. And it does a very, very good job, thanks to some very hard work from core team members like Nicholas Jamieson, who I believe is speaking later, which I'm looking forward to. So one of the problems, though, is like people would do these typings, right, where they would do something like they'd explicitly pass generic arguments to get around the fact that RxJS 6 couldn't really handle the typings. And generally speaking, going forward and just in your life, no matter what you're developing, I recommend against doing this. Like if you must, you should it's probably better to cast with as after the fact than it is to explicitly pass things to generics. And the reason for that is if you infer something like without those explicit generics, then you aren't going to be prone to breaking like what you're about to experience when you try to update with RxJS 7 if you're explicitly passing generics. The fix for when you run into problems here is to just remove the explicit generic that you have there. So if you have this source code or something like this and you're updating to RxJS 7 and suddenly you're seeing errors, literally just delete the explicit generic and it's probably going to work right after that. All right, updates to API consistency. So we had just these weird behaviors and there's still some things I think that are a little inconsistent in RxJS 7, but it's so much better than it was. But in particular, here's one that bothered me and it bothered a lot of other people because it was very confusing. So if I'm concatenating these three observables together, and you can see that it's emitting a value synchronously. So that first tap should synchronously fire as soon as you subscribe to that observable. So right here, and then delay is saying, okay, wait 100 milliseconds, and then it's going to send tap 1 out right after that. And then it's going to complete because this is complete. And then it's going to finalize. And what you'll see happening here in RxJS 6 is the finalization actually happens after we subscribe to the next one in the chain. So you get this whole tap 1, 1, tap 2, wait, finalize 1, then 2, tap 3. So we subscribe to 3 now, wait, finalize 2, and so on. So there's this really weird nonsensical behavior. And in RxJS 7, that's fixed. So now you get the tap 1, it emits 1, and then we get the finalize. And we get tap 2, it emits 2, and then we get the finalize, and so on. So much better behavior for this. And we've kind of cleaned this up. Anywhere that you might have to deal with this with concat map or finalize on error resume next, all of those things that concatenate things together, make sure that finalize happens in the proper order. Another thing, so speaking of finalize, this is another thing that bothered me fairly consistently about RxJS 6. So if you have two finalize operators, one after the other, they actually end up finalizing in reverse order in RxJS 5 and 6. And that was a bug that we really wanted to fix, but we were concerned that people were relying on the behavior because it's just such a weird, like, systematic thing. So now they actually are, they happen in the proper order. Now, honestly, this code here, you could probably get by with just one finalize and do both console logs in that. But regardless, this is just a finite example so you can kind of see what the problem was that we fixed. So another thing is throughout the library, we fixed how we were dealing with notifications as signals to do things. So for example, audit or sample or delay when, or maybe like take until is one that people are very familiar with, where it takes an observable, and when that observable emits, that's when the operator knows to do something. So in take until's case, it says, oh, when I get a value, I'm going to unsubscribe from this or complete my resulting observable, right? That's take until. The problem was that we had a whole bunch of operators that didn't behave the same as the other operators. Some of them would say, okay, only a value signal, a nexted event matters as a notification, and completion is just completion. And the other ones would say either completion or next count. And that second group there is wrong. We should have always had this working the proper way. And that is that an observable completion is not a value or event. It's basically the closed bracket on your array. Like, it has no meaning to the content of your array, the closed bracket, right? So it's just to tell you when the array is done. So observable complete is just to tell you when the observable is done sending you values. It is not a notification. It is not a value. So from now on, all notifiers that exist in RxJS are only notified by a next event, not by completion or next, because that just doesn't make any sense. So it's all consistent now. And here's another big one that I wanted to fix. So the story behind this is a long time ago, removing when you added a child subscription to another subscription, it did not remove itself when it unsubscribed. So what it would actually do in like version 5.1 is it would return a different subscription instance. And that's what you had to use to cause it to unsubscribe. If you had a child added to a parent, you had to use the return value of add and unsubscribe that in order to remove the child from the parent and unsubscribe the child. We fixed that in like version 5.2 or something like that. And all of a sudden, subscription, when you said subscription.add subscription, the return value was the same subscription that you added. So if you had parent.add child, the return value was the child. So you can see down there in the bottom right that like this was true. But people would end up using it like this, and it never did what they thought it did. People thought that they're adding each one of these subscriptions to this fella right here, and that's just not the case. What they were doing is they were adding subscription 3 to subscription 2. They were adding subscription 2 to subscription 1, and they're adding subscription 1 to this subscription, right? They'd this never did what you thought it did. So it was the source of a lot of weird bugs, and that's fixed now because in the other thing is, okay, so subscription return, like again, this is to go over what I was talking about before, that return value was really just to remove either you could remove yourself if you're a child subscription, or you could remove, if you passed a handler into add, you would get a subscription back that allowed you to remove the handler. So either way, the whole thing was kind of wacky, and now it's fixed. So if you have a chain like this in version 7, you're going to see red squigglies because you can no longer make the dumb move. Like this is not going to happen anymore. You can instead, like with the handlers also, you can add and remove them by reference, just like add event listener, remove event listener. Like this is no longer something where you have to hold on to a subscription and send it in. So both of these things are fixed. You don't have to do anything weird with them anymore in version 7. All right, so this is just a few little highlights. And by the way, that this, I don't think I explained this totally. The reason that this is no longer possible is, again, add returns voids. You're not going to get anything back from add. It doesn't make any sense to return anything from add. Maybe someday in the future, we will enable this behavior, but that's not going to be for a long time because we want to get this out of people's heads if RxJS 6 and 5 are still popularly used. So if those fade out of style, maybe we'll talk about something like this, or multiple arguments to add or something, but that's not on the plate right now. What is on the plate right now is you have to call add individually on the subscription the way you're supposed to, and you can't make the mistake this has in it. All right. So, these are just a few of the major highlights. There were very minor consistency issues that we went through and fixed. There were some things around like, delay wasn't always waiting for the last value in there in some cases. Just a bunch of little weird quirks that were filed as bugs that we were worried people were relying on, and we finally fixed. Now, let's get to this. Consolidating multicasting. Multicasting is easily the most confusing area of RxJS, to the point where I would say 80% of the time someone comes and they report a memory leak in RxJS in our comments. No, not even 80. I would bet 95% of the time people report a memory leak in RxJS. They're using share replay almost every single time. And they'll just show like the code that doesn't have share replay. And I'll be like, by any chance, do you have a share replay above it? And they're always like, oh yeah, I do. And then that was the problem. So right now we have lots of multicasting operators in RxJS 6. We've got multicast, publish replay, publish last. We're missing one in there, publish behavior. See, I forgot one. That's how many we have. There's share replay, ref count. There's just tons and tons. So actually, I'm missing one there. And then share replay has this crazy cause of confusion. So the original design for share replay, it was actually called cache back in the day. And the design for it was, what if I have this really expensive operation that I do not want to do more than once? And so the design was that once something, so it's cold until something subscribes to it, then it starts subscribing to the source. And when even if everything else unsubscribes from it, it keeps that subscription to the source until the source completes. So it can consume this expensive thing and keep it in there for you. So then the next person that subscribes doesn't subscribe to the source again. It just gets the values replayed back to them. And that was the design. That was its original intent. But then people will do things like this, where they have a never-ending observable like interval, and they will slap a share replay on it. They'll do like a take 3, and they're thinking after it takes the 3, it'll unsubscribe from that shared observable, and they're absolutely right. But then they're baffled to see the that interval still going, and it's still going because it never completes in order to complete the share replay caching behavior. And this is a source of memory leaks for people. People are like, I don't understand what's going on. They really don't get it. Or they even have share replay 1 or share replay 2. Doesn't matter what it is. That's the behavior. And this is something that was originally asked for in the original design. And now we actually have a better way to do this. So I don't know if I covered this in here. I must have skipped it. But share replay actually has an option in it called ref count true. So you can pass an options object to it, and the options object, you can say share replay ref count true, and then it does reference counting to the point where if all like child or client subscribers unsubscribe from it, it will go cold again, and it'll kill the subscription to the source. So it can support that behavior, and we had to add that after the fact. And there was a whole lot of debate on whether or not it should just always do that. And it was the whole community was split 50-50. So we have this kind of dual behavior of share replay, and it's magic, and it's hard for people to understand. It's a bit of nonsense. So we've added to the share operator configuration. So now share, the share that you know and love that doesn't have weird memory leak problems and is kind of simple when you just call it by itself, can have this optional configuration attached to it. And it allows you to do things like change what subject you're connecting through, or define the reset behaviors. Should I reset on ref count 0? Should I reset on complete? Should I reset on error true? And you can set all of these things. So you can actually define, so this is a replay. This is the same as share replay with ref count true. So you can totally define this behavior, the exact behavior that you want, and actually be able to read in your code what the behavior is supposed to be when the ref count has hit 0 or the reset is complete or whatever. Like, so you can build it. This is now share, it's share replay, it's share behavior, if you like, share through my crazy subject, share that only resets on complete. You can configure it however you want, and it's a single operator. And actually the new share replay is literally based off of this. It's the same operator, it's just a wrapper around it. Another thing that we have with multicasting was we have publish variants and multicast, and they returned a connectable observable. And with pipe, that didn't make a whole ton of sense, right? Because pipe returns an observable. So you'd end up having to cast it as a connectable observable, so you could call connect on it later on to actually connect the source to whatever is listening to it. And now we actually have a creation function called connectable, where you can pass any observable to it, and it makes it a connectable observable. So you don't have to do, anything special with this. And it's configurable, right? You can say what sort of subject you'd like to connect through. And notice it has exactly the same sort of configuration object as share does. So it says connector, you give it a factory function, you can return a brand new subject, or you can return a subject that you've closed over, or whatever you want inside there, and kind of define that behavior. And then you get back a connectable observable that you can connect. And you're no longer trying to chain things like publish or multicast through pipe, where it doesn't really understand what to do with the connectable observable. So we are keeping all of these for now, including publish behavior, which I omitted from this. I'm sorry. We're keeping them from now, but we've improved share, and we've added connectable. And we're going to we've deprecated everything that you see with the line through it here. So including publish behaviors also deprecated because we want to remove them in version 8. share replay, we're not deprecating only because it's so popular, but it is full of foot guns. We want to discourage people from using it and tell people to use share instead. And as we see the popularity of share replay wane, we will probably end up deprecating it as well, but it's going to be around for the foreseeable future. And we really just recommend that people stick with share and connectable for most of their use cases. Probably share in almost all cases. Connectable is kind of an edge casey thing where you actually want to have to call connect on something or whatever. So kind of like one multicast to rule them all, you have share. Now, another thing about multicasting is there actually is a little known publish. It's a thing about all the published variants that a lot of people don't know about or don't use. And it's been there since version 5 was released. And it's that you can pass a selector to it to do all your multicasting within the selector. And that looks like this. So generally speaking, you have the selector and you're expected to return an observable that somehow uses your shared observable, usually in more than one way. Usually you do it with a merge or whatever. But what it does is it executes this callback and sets up the share and then subscribes to whatever comes back inside here and then calls connect under the hood. That's what this does. So then you end up getting back an observable of whatever this flattens to. And it's just not something that people really use widely. So that's why I didn't include it in the other part of this talk. And I actually didn't even mention this in my last talk about ArcGIS 7. But it exists on every single one of the published variants. Oh, wait, no, it doesn't. We forgot to put it on publish last and publish behavior. And no one ever said anything about it. That's how I know nobody's really using these. But so it only exists on share replay, multicast, and publish. And as I stated before, we're deprecating all of these anyways. Because, yeah, we could add these, but we're already going to deprecate it. And this is how many variants that we have right now with like how you can use things and the different ways that they can be used and kind of slightly different behaviors. And it's really ugly. And instead, we're trying to get to where we're just using these two in green here, share and connectable. So we're going to have to add one more to accommodate this publish selector behavior that most people don't know about, but we still need to make sure that we're still covering that base and we're not leaving people hanging out to dry that are using it. In Connect, it looks very much the same. And just, I've got some arrows here to kind of run it down. We've got our source up here at the top. Here's our new connect operator. And like, it's going to call this whole callback before the connection. It also has configuration down here where, again, you've got this connector argument where you can specify the type of subject you want to connect through. And then inside of here, you take your shared observable and you do something with it and return a new observable that gets subscribed to, and it calls connect for you after the fact, and everything that's is flattened that comes out of the results. So something to play with. It covers some weird corner cases. Again, most of the time you're just going to want to use share, especially now that it's so configurable. So that's the long run plan is you're just going to have share and connectable and connect, which, you know, just fewer, more flexible APIs. You're down to these right here, and that's the stark difference. So we'll have 3 multicasting operators or functions as opposed to all of these different variations. Some of them are the same operator, but they behave differently depending on how they're called, whether they're called with a selector or not. So we're narrowing it down to make it a lot smarter, a lot cleaner, a lot easier, and actually a lot smaller. All right, another thing to talk about, new conversions are supported. So you can now convert async iterable and readable streams to observables, just like you can with promises or arrays or iterables. So what is an async iterable? A lot of people don't know what this is. An async iterable has an interface that looks kind of like this. It is an object with a next on it, and the next will give you back a promise to an iteration result. So that's a promise to an object that has a done Boolean on it to tell you whether or not it's done, and or a value on it. So very much like an iterator, only it's asynchronous. It's delayed by this promise. It also has a symbol on it for us to know that it's an async iterable. And these actually come most commonly these days from async generator functions, which come from async function star. Now, async generators are a different animal. I'm not going to get into all of that is with like coroutines and, you know, asynchronous coroutines and that sort of stuff. But you can do things like this, where you can actually have an async function star, and you can have like a little, you can await like a sleep in here or something like that, and then yield over and over again. And this yield causes a promise to come out of your async iterable, and, you know, with this value in it. So like this is going to return an async iterable of numbers, right? That has like some sort of delay depending on how long you pass in here in between the numbers coming out of it. And where do we have async iterable support? Pretty much anywhere that we accept an observable. So from, obviously, and then places like defer, merge map, concat map. And it's just an interesting new thing that comes, it came very, very cheap for us to add this to the library. And async function star is, of course, native in JavaScript. And so it's very cool. It's not without its foot guns because it's promise-based, and I could go into a whole diatribe about that, but we support it now, and it enables you to do some pretty interesting, cool stuff. So you can have interesting patterns like this, where I can literally switch map, and instead of returning an observable in there, I can actually just give switch map an async function star, like an async generator. So you can see here, this is me running the code over here in this video, and you hit start, the button click starts, and then every time you hit start again, it interrupts this, and like you've got this sleep in between, and it's just yielding different numbers every time. But it's just an interesting thing. This yield is actually pushing values out of the observable. So kind of cool. All right, readable stream. This is mostly for fetch. There are some other ways you can create readable streams, but primarily it's for fetch. And this was just a really easy win after we added async iterator, because readable streams API, especially the reader API that comes off the readable stream, is so very similar to an async iterator that it was just a few lines of code to really get this to work. So it was an easy win, and we put it in there. So if you're using from fetch now in the selector, or even in, you know, switch map or whatever you have after that, you can return the response body there. I think various media APIs for the DOM also use readable stream, or you can create a readable stream from scratch if you so choose. I don't know why you do that, but you could. And those will just work with RxJS, and it was very, very cheap and easy for us to add. All right, a lot of people are excited about this one, animation frames. So animation frames is just, it's a new way to create an observable of animation frames that give you something useful, as opposed to before, people had to know like these secret recipes where they would do like timer or interval, or using the animation frame scheduler and this and that. That was a smell. Like that was basically people like knowing about the internal inner workings of RxJS, the library, or the inner workings of range, or the inner workings of say like interval, and then leveraging it with this recipe with an animation. That's silly. Instead, now we have an animation frames function that returns an observable of animation frames that give you something useful. And it looks like this. So you can call animation frames, and it returns an observable that when you subscribe to it, gives you the time elapsed in a high resolution timestamp since you subscribe. So the timestamp is the same timestamp you would get from animation frames. So that's kind of since your page started, if you will. But the elapsed time is the high resolution time since the subscription happened. So that's a very, very useful thing when making animations. And here's like a small example. So in this example, I made like a clock, and I'm sorry if it's flickering a little bit over the video here, but it's very smooth in real life. And I've got a link here that you can click on when you want to try it again. But you can see in here, I can do things like be like, oh, take the elapsed time and do a take while. Elapsed is less than duration. So I know when I want to stop my animation. And then in here, I just have a tab that says, okay, well, I want to have this side effect in here of setting the rotation on my hand, right? So I'm taking the elapsed divided by the duration to give me some sort of variant that I'm using on like how much I want to rotate it. So as long as you get the math in, you can do some pretty cool stuff. So again, this link will be there for you to kind of play with and check out. It's really, really fun to play with the animation stuff. I made this while I was playing around with it, and I thought maybe I'll walk through this code, and no. So I've got the stacklets here, but you can see like this is all using the animation things. I've kind of coordinated it together to where as the mouse is moving or as touch moves happen, it generates these, and this is all DOM. And then when I click, they fade out. So it plays a different animation when I click the page. So it's just really, really fun to play with RxJS in this. And this was only, I don't know, maybe I think 100 lines of code or something like that. It wasn't too bad to write all that. So lots of fun. I'll watch that one more time just because I like it so much. But yeah, tons of fun to play with that. So when you get the slides, do click on this link and fork it and fiddle around. So other new features, just to round up. So I already talked about async iterable support and readable stream support, animation frames, lots of fun. A whole bunch of improvements to Ajax. There's a couple of breaking changes, but our Ajax that we're exporting now, honestly, is on par with things like Axios. We still don't really support Node out of the box. Like in order to get our Ajax implementation to work with Node, you would have to use like XHR implementation that was written for Node and just kind of inject it. But this is so small to add. So if you're already JS, using our Ajax library that's very, very full featured now, only costs you about 4 kilobytes. So it's definitely worth checking out. It's definitely worth using. I've used it in a variety of applications now already. We also added switch scan, which is a bit of fun. We'll go over what that does. There was an outcry about use cases for that after we had merge scan, which I've personally never used merge scan in any app that I've worked on, but I know people who have. But just kind of round things out, and it was switch scan came at no real cost because we could use the same internals that we used for switch map in order to make it. Combine latest object. So this is a new one in RxJS 7. So similar to what we did with fork join, where fork join can take an array or an object, combine latest can now also take an array or an object. And that's so it will output like the same shaped object with the values in it, right? We've got first value from, last value from, which I talked about before. Those are promise conversion functions. There's 2 new configuration options. One's called on stopped notification, and the other one's on unhandled error. And these are both kind of the same vein. The main use cases for these would be to log random things you didn't expect to happen in your RxJS. So on stopped notification, that gets called if for some reason, let's just say you are calling complete on a subject and the act of completing the subject causes something to next into it. In that moment, the subject is stopped but not closed, and it's going to be like, oh, like I don't know what to do with this. And there's a whole bunch of spots where this could happen in RxJS, and it's just kind of a weird fluke sort of thing that can happen. But previous versions of RxJS would not let you know that this thing happened, and you want to know that it happened because that means code is probably executing you didn't mean to execute. And now there's actually a place for us to handle that and to look at it. There's also on unhandled error, which is a configuration point for exactly what it sounds like. If you don't add an error handler to your subscription, then it's going to be rethrown in another call stack currently. If you want to handle that before it's rethrown, in all cases, you can do that in this configuration point. And it's global configuration, but it's primarily used for things like logging. We also have changed around throw error. Something a lot of people don't know, and I actually tweeted about this a while ago because it surprised me, is the moment you create an error, if you say new error in JavaScript, whether it's in Rx or wherever, just in any JavaScript code, it's going to capture all of the closed over state in whatever function context that you happen to be in and store it in memory until you read the stack of your error. So you do not want to keep it, you don't want to create a new error and just keep it around forever. And the previous version of throw error required you to pass an error to it. And what that means is that you would create an error, you'd capture all of everything that was in memory at that point and keep it in memory until throw error actually did something with that error, and then somebody read it, like read in particular the stack property off of it. And this is just a quirk of V8 in particular. Now, what you want to do is only create errors right before you're going to throw them and use them, or throw them and get rid of them, because otherwise you're going to end up, with these memory leaks like that. So throw error now takes a factory function, and that's how we recommend using it. So you give it a factory function, and when it's subscribed to, it calls that factory function, creates the error, and then passes it out, as opposed to you creating the error way in advance and giving it to the observable. We also have the configurable share and connectable, and what's not on this list is, I've already talked about, which is connect. So that's the other operator that did the same thing as that publish selector variant. All right, so that's pretty much everything in RxJS 7. There's a lot more to kind of figure out, as far as like, there's nothing to figure out. There's a lot more for you to explore, as far as, very minor breaking changes and stuff. It's all highly documented on the website now and easy to find. I want to talk a little bit about what's going to happen after RxJS 7. So this is something we haven't talked about at all. And the biggest thing that's going to happen in RxJS 8 is we're going to remove deprecated APIs. We want to, during this time period, focus on trying to improve API readability. We've got things right now like group by. It takes 4 arguments, and no one can really tell what they all are when they're in your code, right? So making these things named arguments and doing things to try to help make RxJS code more readable is something that we want to do. We want to continue to think about bundle sizes and trying to make things smaller. Documentation is going to be a big focus. I've actually started last year in the fall on creating really comprehensive documentation. There's still a PR out for it. I had to stop to focus on RxJS 7 some more, but getting out some really solid documentation on the do's and don'ts, gotchas, good patterns, when you should use Rx and when you shouldn't, and like some honest advice around that sort of thing. That's all going to land in our docs. And, just kind of focusing, again, I already mentioned this, so just trying to improve readability, or give people advice on how to improve readability around RxJS. A lot of people that hate RxJS only hate the readability of the operator chains for the most part. They don't hate observable. They hate like big, huge wads of gobbledygook. So we want to help people figure out how to make those things better. We also want to keep an eye out for modernization things. So if for some reason the pipeline operator looks like it's making some traction, I don't know if that'll be the case, but trying to make sure that we're aiming towards wherever JavaScript's going in the future, we want to try to steer the ship that way, because so many people use this, 25 million downloads a week right now, that we have to steer the ship very slowly so we don't break a whole ton of people in the process. Another thing we're talking about is a single import site, or abort signal support. So just some things like RxJS 8 size speculation. So I went through and I removed all the deprecated APIs just to see what it looked like and built with everything in it. And it removed about 10 kilobytes. That's just removing the deprecated APIs. It's no other changes than that. It removed about 10 kilobytes from the library. So it made it much smaller, like right out of the gate, maybe somewhere between 8 and 10. We'll just say 10, but it was a good amount. And it would only get smaller in between now and then, because there's other stuff we can do to make things smaller. So it'll be really cool. Not to mention the surface area is so much better. And then what if we only had one import site? So right now we have deep imports. It causes some weird headaches in different IDEs. It causes some weird headaches in our package that we put out. And it causes some weird headaches in like people not knowing where certain things are. And now we finally have names and everything, where we don't have 2 versions of things called race. We have race and race width and whatever, that we're able to target, potentially moving everything to where you just only import things from RxJS, no RxJS/operators or whatever. So that's something we're going to have to come up with a strategy to get people to move that direction. And we're talking about doing that very seriously right now. And then abort signal support. Abort signal shipped with fetch and now exists in Node and all major browsers except for IE, which I would not call a major browser anymore. So we have this cancellation thing that's very similar to subscriptions, and it can be used as a token. And as this cancellation thing becomes more popular, what if we leveraged it? Then we wouldn't have to ship subscriptions anymore. And there would be kind of one cancellation mechanism to rule them all. And we could use them in a variety of places, like on subscribe or on for each, or in first and last value from, that sort of thing. So it's a really cool thing. We're really hot on it. We're kind of watching what the ecosystem does with abort signal, and this really strongly looks like a direction we might want to go, but we have to figure out how to transition there slowly over time without breaking people. So there might be some dual mode for a while where there's both subscriptions and abort signal support or whatever, but we'll figure that out. It's not a real rush to get there, but it is something we're looking at. So again, version 8 is a ways off. So you don't have to worry about anything I just said there, but it's just so you have an idea of what the timeline looks like. Version 7, again, was in beta for more than a year, actually much more than a year. So I think it was like April 4th of last year was when the first beta 0 of version 7 was released. I really, really want to thank so many amazing people that helped make version 7 possible. It was not just me doing this. Jan-Niklas, Jameson did a ton of work on the types. Lots of work for this list you see here was kind of an order of total commits, but there was a lot of interactions and stuff. This is not a comprehensive list. There are people who interacted and gave us feedback and things on GitHub that are not in this commit list. And of course, there's all the people that committed before them. This is just kind of a slice from the last a little bit more than a year. Just so very thankful for all the help that we had to ship this version. It's a far cry from a long time ago when it was, just Paul Taylor and I working on it, and there was like 10 downloads, and then Paul left Netflix, and it was kind of me on my own for a little while, and then OJ joined, and it's so much better. It's so much more lively in the issues and stuff, and it's great to see some new faces contributing, and hopefully we'll see the core team grow and stuff over these next few years as we move towards version 8. So thank you very much. ArxJS 7 is out right now. If you go and you npm install ArxJS at latest or npm install ArxJS, you are going to get version 7. Please keep in mind, though, that it requires TypeScript 4.2. Without TypeScript 4.2, you will get some funky errors. Like right now, I know that if you go play with StackBlitz, I think StackBlitz is still in TypeScript 4.0 or something like that, and they're rushing to update 4.2. It should be StackBlitz should be updated in the next day or two, I've heard. So really, really cool stuff. The docs are all updated. Please feel free to go out there and check things out. If you play with the StackBlitzes there, they might not work for a day or two because of that whole TypeScript issue, but start a local project, play with it. It's so much cleaner, so much nicer. I've been using it, of course, in my projects since it's been in beta. And this also, so is what Google has been using ArxJS 7 in production for months and months and months and months now, because they actually, just like Angular, they sync that off of our master branch. So they've been ahead of the curve for quite a while, but if you get this out now, you will actually be ahead of them. So it's very stable, very small, very clean. And I'm super, super pleased with all the work that everybody's done to get us there. So thank you very much. Stop sharing.
Great.
And a little bit of feedback.
Sorry about that. Okay. Ben, before we take some of the questions, I'm just gonna thank some of our sponsors. Hang on a second. Give me a chance to share this screen. Okay. So we have a few sponsors who helped us with the event. We have Adaptive, and you heard from their co-founder and CEO earlier. We will play that video again around lunchtime. And thank you also to the Narwhal folks, NX Dev Tools. You can check them out at nx.dev. Hero Devs as well. And Outsmartly. So Jay Phelps, who was one of the speakers at the last London event, is a co-founder of Outsmartly. and Ben and Jay are best friends, as far as I know. Okay, we're gonna take some questions. I don't think there's a lot though, but yeah, we'll see what we have. And let me just go to YouTube and pick some of the questions. Give me a second. Okay. I think this one here about TC39. Let me just pull that up.
Oh boy.
Actually, before that, Ben, so there is a comment here from Angular Rocks. They're from Australia, actually. So what is the actual number? Is this the current number, or is it higher?
I checked earlier today. Let's see if I got an npm. Look at the package. It said something like there was. Right now, it's saying that there is $20 million. Right now, it's saying 20 million downloads for the last week. And then but as of yesterday, it was 25 million downloads. So it kind of depends on what day you're on. So,
right. Okay.
So but somewhere I'd say 22 million downloads a week is probably what we're averaging, I guess.
Okay, well, that's pretty good, isn't it?
yeah, it's good. It's a little intimidating to see that. So.
Yeah. I was just when I was having a chat with Adaptive earlier, we were chatting about that, and I was saying to him that this is incredible because it's obviously used by a lot of people, and it's maintained by a small team who are all volunteers, right? No one's paid to do this.
Yeah. 100% volunteer. I wished I could get paid for it many times, and I've taken a few jobs where I thought I was going to get paid for it, but I've not going to happen.
Who knows? Maybe the next one.
maybe.
Well, it's probably difficult to leave the current one, right?
yeah. We're not. It's.
Sure.
I'm not super worried about it. We're clearly able to ship this. Yeah. But the number of downloads, so the size, the number of people that depend on this library means that, and it's hard for some people to understand. It means that we have to be very slow and measured in what we do and consider everything. Because if we push out a patch, right, that has a fix in it that is in any way breaking, then overnight we break like 1 million builds or something like that, and then in the morning there's an actual tangible cost of paying engineers all over the world to sit and figure out why their build's broken. So their build's broken because they're not using lock files, by the way, if their build's broken because of that. But there's we have to be a little bit more slow and measured than you could be with, your own private open source project that you might be publishing that's only used by a couple hundred people or whatever.
Exactly.
So.
You don't want to be, having production issues here and there because the team has been careless. Definitely. It's the same like any private company, right? Small or big, you always have to be careful. Okay, let me see what questions. So this one here. I think I saw you tweeting about this several times. Right over there.
We're gonna real talk about the TC39. The TC39 is an organization with paid membership, and I don't recall exactly what it costs. I think it's like $20,000 or something like that. A company has to pay. So in order to get a vote in the TC39, you have to be a member of a paying company. And if none of those paying companies wish to prioritize any given proposal because it doesn't benefit them or because they don't have time to deal with it or for any number of reasons, there's no one to champion the proposal. So the proposal itself is not dead. It lacks a champion. I've been approached about it, but I'm not a member of the TC39, and therefore, it would just kind of be like yelling into the wind, in my opinion. I don't know. I don't know that for a fact, but I've got a strong inkling that that's exactly what it'd be, and it's a lot of work to get one of these proposals through. So it's not dead. There are other proposals that I think are probably more beneficial for the RxJS community, one of which is the pipeline operator, which is, again, it's another one that's kind of stalled. The only company that wants to push forward is kind of pushing forward a version that I don't think would benefit the community very much. But that one is the most promising right now, and it's got some traction, but not a lot. And again, it has to do with how the TC39 is structured. It's a paid membership sort of thing. They do listen to feedback on GitHub. If you really want these things, get active on GitHub, comment a lot, like thumbs up a lot, like talk about how this could benefit you at your company. And they do pay attention, and it will help. Now, again, it's a paid membership thing. So it's a bit of an ivory tower. So you have to convince people in the ivory tower to do your bidding. It's not exactly democracy, but hopefully these things turn around. So it's not dead, but it is stagnant right now until someone picks it up. It was not shot down. It just lost its champion, and therefore is now stopped for the time being.
Isn't there a way for the community to be I don't know, a member somehow collectively?
Yeah, you just have to pay the.
That would be nice, right?
You just have to pay the ECMA or whatever, and then you can, if you have a company and you can pay the ECMA, you can be a member of the TC39. So I don't know. Maybe I should do. I mean, I should start a fundraiser and join the TC39. I don't think people really want me on the TC39 though. Because of this issue and because of the pipeline operator, I say snarky things sometimes about the chances of certain things getting through, and I would be like a fly in their ointment, I'm sure. But the individuals on the TC39, by the way, are all kind, lovely, brilliant people. It has nothing to do with the individuals on that team why these things are stalled. It's really it's more of an organizational issue, and who has the money and the time to push these things through, because you have to, it takes time. It takes a lot of time to get these proposals in. You have to have a lot of free time. And let me tell you something, as an open source contributor right now, volunteering your free time for tech work is not super lucrative for your life or anything. It has to be. It has to be your passion. It has to be.
Related to that, let me show it on the screen.
All right. So how do you balance work? So what I do is I work really hard until I burn out, and then I don't work at all for a long time. And no, it's a good question. So full time. I'd say early on when I was at Netflix, they gave me a lot of leeway, probably too much leeway, and I worked on RxJS probably more than they wanted me to, and I never got in trouble for it or anything like that. But I'm sure that I probably should have focused more on Netflix work and less on RxJS. Although part of what I was doing at Netflix was for RxJS, so it was a very flexible position. At Google, I'm mostly focused on Google's work, and I had to kind of do RxJS stuff on the side, and that sort of became the MO. So at Citadel, I don't even talk about it really at work. I did this last couple of days because the last couple of days were a big couple of days, the first major release in the last 3 years for RxJS. But otherwise, I never bring it up. I try not to mention too much about how I work on it unless someone needs help with RxJS related stuff, and I see them in Slack or whatever. But I put a strong dividing line between the two. The real thing that I have to balance isn't necessarily work in RxJS. It's balancing being a dad and a normal human being in RxJS. That's a lot harder. And especially when I get really excited about something in RxJS, and then I realize I can easily get hyper focused on it and burn out. So I have to be careful and make sure that I'm taking breaks and making sure I'm spending time with my kids, or maybe don't work on it until after they go to bed or whatever. That's more of the balance problem than the work. I just try to focus solely on work and not worry too much about the open source stuff, other than occasionally I have to have meetings during the workday about it, which, I just make sure is scheduled, and I don't really have any problems with that, because if you hire an open source maintainer for a major open source project, it's like hiring someone with pre-existing conditions, right? Like, that they're going to have things that come up because of their open source. It's not, if you want somebody to be 100% there all the time, don't hire an open source maintainer. But for the most part, I would say 98% of the time I'm worried about work during work. So.
Okay. Yeah, sometimes I see you working late, really late nights, right?
Yeah.
That's RxJS then.
I got the bags under my eyes.
Okay. There's another question here. I think he's got two questions. So this is the first one. Is this right? If you want to multicast, okay, you read that, right? And then I'm gonna show the other question.
All right, so these are related questions for sure. So you can what Pedro is showing here is, this is basically, you're doing share with like the normal behavior of share, but share usually has a subject underneath there. This is now using share with a behavior subject underneath there. So you get the exact same behavior that share has had for a long time. Only instead of having a subject under the hood, you have a behavior subject, which means as new subscribers subscribe, they get the previous value and so on and so forth. The previous question, I think, was about, what should you use? Honestly, what Pedro is showing you here, 99% of the time, that's what you're going to want, is to use share. Where share falls on its face is when you're dealing with completely synchronous observables. If you're dealing with something completely synchronous, then you want to use connectable or connect or one of these other things. But like, honestly, if you're doing completely synchronous observables, and I'm saying this not as the author of RxJS, but just as like a tech lead sort that has to review PRs, like, what are you doing? Like, you probably should not be using RxJS on totally synchronous stuff. There are use cases for doing that. Like, say you have to do something very memory intense that, you don't want to create a bunch of intermediary arrays or something. So you're trying to use it as like a processing pipeline. But those use cases are kind of thin and far between. Like, really, RxJS is meant for asynchrony. And so in all asynchronous cases, share is your friend. Like, it's totally configurable. You can make it do exactly what you want. In fact, there's even PRs and discussions right now about making it so the reset on ref count not only can take a Boolean of like true or false, but can take like a function that returns an observable. So you can say, hey, like, wait this long before you actually reset or something like that. So there's proposals to do some interesting stuff.
Okay, right. So there are a few comments. One, for example, this one from Manila. We've got a lot of people from like different places in Asia, Australia, India, Malaysia, Japan. I think Thailand, I believe, Vietnam. Yeah, so awesome talks. There's a lot of thank yous here for you, Ben, for all the work that you do. So
that's great.
Good. Okay.
I'm always shocked and amazed when I see people from all over the world using this stuff. Like, it's, from a small town kid from Michigan, it's kind of wild to even think that I've made something that somebody is using that far away from home. It's very, very interesting.
Great. Okay, we've got another question here. We probably have like around 8 minutes. So yeah, we still have a bit of time.
All right. So the question here is, the async generator pattern is interesting. What type of applications do you see taking advantage of this in the future? So it really depends. Like, here's the thing. It's promise based. So if you have an async generator function, anywhere that you've got an await in there, it could pause an indefinite amount of time and there's no cancellation. So, it really just kind of depends. I think one of the more interesting applications of it is situations where you don't necessarily care about cancellation, but you want to use some promised APIs that you already have. And like, maybe you want to be like, okay, so call this thing and then yield a value, and then call this other thing and then yield a value. So I think that it'll be an interesting point for like solving problems where you're like, oh, I want to run this function once and only once per, like make sure that everything is executing this function is only executing once at a time. So just in order. So I'm going to use concat-map, but then I want to control what it's emitting while still using these other promise APIs. So then I'm going to use an async generator function on the inside of it. I think that's a really, really interesting application. The problem tends to become like the lack of cancellation, which RxJS kind of makes up for because it can ignore everything that comes out of it, but that doesn't mean that the code inside the generator function isn't still executing. So it's an interesting thing. I have used it in the past in a couple times for small use cases, exactly like where I described, where I had some promise-based API and I had to call it a couple times in a loop or whatever and emit something right after, and it just ended up being like kind of a small, clean way to solve the problem as opposed to what I would do with operators to get it done. But it certainly is it is a super interesting thing, and I recommend people use it. One thing I don't see people use even beyond the async generator is just using async functions inside of like concat-map or defer or something like that. Like people don't often think about, well, you know, I could make an observable out of this async function by just passing it to defer, and all of a sudden now I've got an observable that executes this async function and gives me the result when it's done. So the async generator is more of the same vein, where you can do, it's just another kind of interesting way to create an observable, probably more at the head, and just but you do have to pay attention to the cancellation side of things because it doesn't exist in generator because it's promise based.
So we also have Matt Podwysocki as one of our speakers, and he's got one I think comment here. I'm just gonna, don't know if you wanna comment on it.
Totally. I'm doing Matt a disservice here. RxJS is like a sister library to RxJS. So RxJS is based off of async intervals and always has been. And RxJS does have deep cancellation with abort signals. Async generator functions, specifically what I was talking about, async generator functions are what don't have cancellation. So if you want to use async intervals, RxJS is your thing. Like it's really great if you want to deal with things like back pressure on like a node service or something like that. Or like even in a worker thread where you don't care about you don't care about maximizing out that thread as much as you would say the UI thread or something like that. RxJS is a really, really strong solution for if you're interested in async iterators. Check that out for sure.
Okay. There's a question here. Actually, I can answer this question because our next speaker actually has, a lot of interesting courses. I believe in Udemy, right? But are there other tutorials that you might want to mention, Ben? Or I know.
I tend to steer clear from doing that. And the main reason is I know so many people that work very hard on these things, and I don't want to be like, oh yeah, do this one, and then forget to mention somebody else's, right? So I always kind of balk at that. Of course, because I know Deborah's right after me. You can always check out Deborah's materials. I've personally interacted with her on some of the things that she's worked on, and I know it's pretty good stuff. So I'll plug her because she's right after. But there's so many great stuff. There's so many great companies, and most of the major companies that you have out there, the plural sites and the eggheads and whatever of the world, have some really good RxJS material. I don't want to totally forget anybody's stuff. So.
But plugging, there is we've arranged a training with Ben on May 27 to 28, and we're actually giving 2 places away, for attendees of this conference. So I posted a form on the chat, and we'll post it, throughout the day as well, so that people can add their details if if you're interested in being part
So,
of it.
To my workshop, right? Yeah. So you can always come to the workshop. And so people know my workshops for years. Any workshop I've ever done, I don't take a profit. I donate my profits to charity. So
yes, exactly. So this is your second, training that you're doing for us, workshops that they're doing for us, and so basically, Ben's donating his profit to some of the women in tech and girls in tech projects that we have. So thanks a lot for that, Ben. One of them actually is called Tech Girls Summit. We haven't launched that yet. We were supposed to launch that not last year, the year before, but we were so close to like the start of 2020, and then pandemic happened, so we have postponed that. But as soon as we're back into in person, we'll definitely look into launching that. And thanks again, Ben, for that. The one last question here about migration. Okay.
All right. So the question is, what's your take on the difficulty of upgrading RxJS from version 6 to version 7? Can other library maintainers upgrade RxJS without breaking a sweat? So one of the things I take part in is I help Google, even though they're not paying me and I don't work for Google anymore, update their version of RxJS inside of Google. So Google has thousands and thousands and thousands of build targets, like thousands of projects that are using RxJS internally. So I have personally seen everything break that could break. And, we've made fixes in our RxJS along the way to try to make that easier. So they're kind of the guinea pigs for everybody else. And I can say, if you're updating one project, as long as you have TypeScript updated, that's step one. If you can update TypeScript, then once you're there, updating RxJS, generally speaking, within a single project is pretty easy. You're looking at, a few problems here and there, probably just a half hour of work at most. It just depends on your project, of course, and how much RxJS you use. If you're updating like an entire company's worth of projects, then you might have some work on your hands. Like it might be like if you've got a big mono repository like Google does, obviously no one has anything quite like Google, but if you've got, dozens and dozens of projects that are all using RxJS and you want to try to update them all at once, you're probably going to have a bad day. But overall, I mean, most of what I see are things like things that I mentioned in this talk, where people are calling subject next without a value, but the subject was a subject of number, and they had generally speaking, they just have to go and they have to fix their types. So there's no, the majority of the changes we deprecated stuff, but we didn't really remove anything this time. So there shouldn't be anything like that. So it should be fairly smooth. A lot of the fixes are just going in where you've explicitly had generics before to get the types right. You just delete the explicit generic and things just work after that. So all in all, it's not too bad, other than some mind-bending TypeScript stuff, which happens from time to time, which anyone who uses TypeScript enough has probably had to deal with at one point or another, but not too bad.
So it doesn't sound like it's too painful then.
No.
Okay. Right. So I think that's the last question we can take. There are other questions.
Watch that guy send me a nasty email. I tried to update RxJS the other day, and it took me like 4 hours. To see. I tried this. It took me a week. I can already see the mean emails coming, but no, it shouldn't be that bad. It really, really shouldn't.
As I always say, to people, you are not paid. A lot of maintainers are not paid to do this, so people have to be patient. Yeah. They're getting this for free, so they have to be patient. Unfortunately,
yeah, they still have my sympathy though. Like if something is really bad, you can try messaging me. I do recommend going on Stack Overflow because you're going to get an answer a lot faster. But if it's that awful, you can try messaging me. It takes me a while to respond because I get a lot of messages from people. But I do actually try to answer everybody's questions. Anybody that sends me something about RxJS. So
Incredible. You're awesome. All right, Ben, we're gonna have to wrap up. But there are questions on the chat. I don't know if I think you're planning to stay for a bit.
Yeah.
So if you have time, if you can respond to some of the questions on YouTube live chat, that'll be great.
Okay,
and
great.
Thanks a lot again. I'm gonna bring in Deborah. Hi, Deborah.
Hey.
How are you?
Deborah.
I'm doing okay. How are you?
Good.
I'm not going to bring up. I know why you're sad, and I'm not going to bring it up.
I brought it up just now, but anyway.
I sort of meta brought it up. I was trying not to, and it came out anyway. I'm sorry.
It's okay.
In trying not to, I brought it up anyway.
Okay, great. Thanks, Ben, and we'll see you on the chat. Yeah.
Yep.
Okay. Thank you. I'm gonna add Deborah's slides now. In a second. Right. That looks good. Let me just turn up that question. Okay, so Deborah, I'm gonna remove myself from the stream, and thanks again for for joining us despite what can happen today. We appreciate your time, and as I've said earlier, Deborah has a lot of courses on Udemy. And I've been to some of the forums, also on Facebook, on like JavaScript forums and Angular forums, and I see your name there. And people have been recommending your courses to other people who's been asking about courses. So that's that's great. And we're lucky and thankful to have you here today. All right,
Thank you so much for having me.
I'm gonna let you get on with your talk now, and I'll be back after your talk.
All right, thanks. Okay, hey. We're going to talk about RxJS and Angular, specifically some pipeline patterns. As they mentioned, my name is Deborah Kurata. My courses are actually on Pluralsight, and Pluralsight is doing a free April, and there are one more day. There's one more day of April, so you can watch any of my courses for free. Someone was asking about an RxJS course. I have one called RxJS and Angular Reactive Development. I also have an NGRX course. So I'm a Pluralsight author and a software developer. And there you see me at one of my favorite places on the planet. It's really sad that we can't be together in Singapore this year. So I just thought I'd post a few happy memories and hope that we are able to get together for this conference next year. Okay, so what are we going to talk about? We're going to talk about the retrieve related data pipeline, lookup reference property, grouping, and autocomplete. So those are the four we're going to cover during my time here. So first of all, sometimes people ask me, how do you even think about these pipelines? How do you think about how you actually apply RxJS to a problem? And so I have a tip here. Start with what is it that you have? What do you want? And when do you want it? And by answering these questions, it helps you kind of think about what you need your pipelines to do. So we're going to go through these questions with our 4 pipeline examples. So we're going to start with this one, retrieve related data pipeline. So in this particular UI, the user types in a username and clicks the button, and then they get the list of posts that that user has written. So our questions, what do we have? Well, we have the username. So the user is going to type in the username and then click that little search button. And we then, so the answer is, what do we want? When they click on it, we want to get the posts for that user. Now, our problem is that our post has a user ID, not the username. So what we're going to need to do is do a related data lookup. So our user ID here, we're going to take that and find it in our user API and call the backend to look up that username. Then we're going to pull off the ID and use it to find all of the posts for that user. So we've got a related data issue here. Well, when do we want it? Well, we want it anytime the user modifies the username and clicks this search to search for their posts. Whenever you hear that we want to do something with our pipeline based on an action, and in this case, it's a user action, then there's always something that you want to think about. And that leads us to our next tip. To respond to an action, we need to create a subject or behavior subject. Especially if you do a lot of Angular work, frequently our observables are given to us, right? We do an HTTP GET, and it comes back with an observable for us. We didn't have to create it, we just get it back. Same thing if we use routing or if we use value changes observable with our forms. But if we want to react to an action that's going on in our UI, we want to use a behavior subject or a subject. So what does that look like? So here's a common pattern for when you use a subject. First, we define a private property and use that to use new and create the subject. The generic argument here defines what is going to be injected into that stream. So in this case, we have a string because we want the username. We're making it private here because we don't want any of the other bits of our code to be able to access this subject directly. We don't want any other code to directly emit stuff or potentially replace the observable or generate an error or complete it. But we do want other parts of the application to be able to subscribe to it. So to do that, we expose the observable, the read-only part of that. So we're going to create a second property that is the observable read-only part that's going to get emissions. And that emission, again, is the username string that the user typed in. So our user interface will call a method in our service, which will emit that into our stream. Now, the primary difference between a subject and a behavior subject is when you subscribe to a subject, you don't get anything. Then it will emit and you'll get that first emission. With the behavior subject, you always get something. You either get the default, which you specify here in the constructor, or you get its last emitted value if you subscribe after it's already started emitting. Okay. So that's subject and behavior subject. So what does that have to do with our pattern? Well, we are going to use our subject, our entered user, and we're going to pipe it through. So the first thing we're going to do is use a switch map. Why a switch map and not a merge map or a concat map? Because anytime the user switches what they've selected, they type in a different username and click the find button. We want to cancel that and switch over to the new one. So we're going to take that username and we're going to use it to get our user. Now, notice that this is actually an array and not a single user. That's because in my particular case, my API, when I use a query, it has no idea how many there's supposed to be. Now, there should only be one user in there with that username, but our API doesn't know that. So here it's using regular expressions, the hat and the dollar here, to ensure that there's an exact match. But the API thinks it could be returning multiple entries, and so therefore it's a user array here. Once we have that, so it uses regular expressions and returns an array. Once we have that set of users, then we pull off the 0th one, the first one in the array, and we use that to get all of the posts for that user ID. Okay, so that doesn't look too horrible, but there's a couple of issues. First of all, we have to get this first user, which could be problematic if it didn't find that user. So some questions that might come up in looking at this code. First of all, where's our exception handling? You know, anytime you're hitting an HTTP kind of scenario, there's a huge possibility for all sorts of different kinds of errors. So you need to be thinking about that. And second of all, what if that username isn't found? This accessing of user 0 is going to throw a runtime exception, which is never a good thing. So how are we going to deal with these issues? That leads us to our next tip: refactor code into manageable and reusable pieces. Sometimes you see RxJS pipelines that are just these huge things. And my tip here is if you refactor them into smaller bits, they're not only better able to be understood, but they're also better able to be tested and to be reused. So let's see how we could do that in this example. So we're going to create a get user ID method. It's going to take in the username and emit and have an observable that emits this number, the ID, because then we can take that HTTP GET and we can actually add our error handling, and we can add some intelligence here that if it didn't find that user, that we just return an ID of 0, and then we can have our code smart enough to recognize 0 as a ID. That means it wasn't found. We could even add code in here that looked for it finding more than one, and do some logging or whatever, because there should only be one entry for a particular user. Then for get posts for user, we would then take an user ID and we would use that. And again, we can have some error handling. We could also even add code in here that checks for that user ID being 0. And if so, it would actually be above the return. And if so, it doesn't bother even issuing an HTTP GET because the user ID was 0 and there shouldn't be any posts for a user ID of 0. So let's kind of push those down and look at what our pipeline now looks like. So here our entered user is going to emit each time the user clicks the button and pipe it through. And we are going to call our user service get user ID. So this is another benefit of breaking it into pieces. We can then actually put this hunk, this get user ID, into a user service where it makes more sense, and not junk up our post service with all these things that don't really belong there, that they don't abstract really into the post. They really belong in a user service. And then when you actually look at your main code, you're reading this code, this user service get user ID, passing in the username. So it makes the main code that you have to look at and work with a lot easier to understand and to grok. And that it makes more sense. Okay, so that was our retrieve-related data pipeline. Now, one of the things you might have noticed on here is I've got this weird category thing over here. Now, category 169, well, that might mean something to somebody, but your normal user isn't going to know what category 6 was or category 1 was. And so that leads us directly into our next pattern, which is the lookup reference property pattern. So we're going to have a lookup table with category IDs and category names, and we want to use that lookup in order to display the correct category name with our post instead of showing that ID. So how do we do that? Again, we're going to go to our questions. What do we have? Well, we're going to have all of our posts, and we can get all of our categories. So we've got our posts and our categories. What do we want? Well, we're going to want to change our post so that it actually has a category string in addition to a category ID. Then we're going to want to take the category ID, look it up in our lookup reference table, and then use the name and populate that category. So then when our UI binds to this post, we can display that category instead of the category ID. And when do we want this to happen? We want it to happen whenever we get any posts. So now we are going to be working with 2 streams. We've got, or 2 observables. We've got this post category observable, and we've got our post observable. So how do we work with the 2 of them? That leads into our next tip. To work with multiple streams, we want to use a combination operator. And in this particular case, we're going to use combine latest. So we're going to create a new observable posts with category, and we're going to combine our list of posts and our list of post categories so that we can work with the 2 of them together to do this lookup. And you're going to look at this and you're immediately going to think of some questions again, right? Like, where the heck now is our error handling? And also, how do we reuse these retrieved categories? Now, our posts are going to change pretty often, right? The user can be adding more posts real time. And so you're going to want to get that data on a regular basis and ensure that data is fresh. But how often do those post categories change? Maybe once a month, maybe once a quarter, maybe once you set them, maybe they never change. So there's no reason those couldn't be cached. And when you're calling this and getting this data like this, it's not very easy to cache that without caching this whole thing. And you don't want to cache the posts because they're going to be changing. So how do we deal with this? Well, again, it goes back to our prior tip about breaking it into smaller pieces. And this time we're going to use properties instead of methods because we don't need to pass anything in. So here we're going to get all posts this time, and we're going to add our error handling. And we're going to get all categories and add our error handling here as well. And notice we add a share replay. And of course, when RxJS 7, now that it's out, we can change this to a share. But we're going to use a share replay here, which means that the next time something accesses this all categories stream, it's going to replay the data it's already received, and it's not going to go back out to the backend server and go get it again. So it minimizes your hits on the backend server. So what does that do to our pipeline? Well, our combine latest can now just access all posts and all categories. And again, since we've now broken this up, we can move the category part into a category service. So we've appropriately abstracted our logic into appropriate services and then encapsulated that in those services. Okay, but that's not really our pipeline. What's our pipeline doing once we've got our two streams combined? And that's what this is doing. So what combine latest does, one of the coolest things about what combine latest does, is it will wait for both of these to emit at least once before it emits anything. So if you've ever in your code wished that you could get this and get that and wait till you have both of them to do something else, combine latest is your friend. So what you can do, what this will do is wait until all the posts are retrieved, all the categories are retrieved, and then it will execute the code. It will emit and execute the code in the pipeline. What it emits is an array. So that's this array here. The first element of the array is the item emitted from this first as observable up here. And the second element is the next one. And if you had a third one, it would be a third array element. And then I'm using array destructuring to actually name these elements. That way I don't have to be referencing posts as array 0 and categories as array index 1. I can just give them names. So then I'm using the post array map to loop through every one of the posts. And what I'm doing is I am creating a new strongly typed post, taking the original post content here, using the spread operator to copy all of the data from the existing post, and then adding a category and using find on this second array to find the actual ID. And if it's found, I'm adding the name. Okay, so again, we're going to get back then an observable that emits a post array because we strongly typed it here as a post, and that's what we want to bind to. And again, our questions, what if the ID is not found? Well, it's not going to blow up because I have this nice question mark, but it could leave the category to be undefined, and we wouldn't necessarily want that. So what we could do is something like this with an or, and then specify what we want as our default. So we could just have an empty string or no category or undefined or not specified, whatever we'd want to say there. What if there are multiple lookups? So we want to look up the category ID and get the category name, and maybe there's a user type and we want to look up that, and maybe there's a preferred type of contact, or whatever we would want. We can just keep adding on to here. We can have 3, 4, however many streams we want to combine. We just add them here into our map and then define whatever fields we need to store them. Lastly, how do we reuse this logic? Because now we're getting all posts. So what if we wanted to use this again for our post for a given user? Well, now we'd have to write all of this code again. So we're going to go back to that other tip and break this into smaller pieces. So we can write a method, map categories, that will take posts, and it could be all posts, it could be the post for a user, it could be the post for a date, it doesn't matter. Some array of posts and our categories, and it's going to do our mapping for us. Then our pipeline looks like this. It's a very simple this.map category passing in the two values that were passed to it. And it might be nice if this is able to do objects at some point, that I could just pass in an object with that. But we'll see what we can do with ArxJS 7. So this is the lookup reference property pipeline. So I'm able to then display that category. Okay. So the next one is grouping. And I struggled with this one just a little bit. One, because it takes a little bit of digging in to really grok what the grouping pipeline or the grouping pipeable operator is doing. And also because there are a heck of easier ways to do it without using the ArxJS group operator in my particular example, but I wanted to be able to show it just to give you an idea of how to get the grouping operator to work. So in this case, I want to group by the category, and here's my no category, and I want to do this grouping. So again, start with our questions. What do we have? Well, we have our posts. What do we want? We want them grouped by category ID. When do we want it? We want it when the page is displayed. So how are we going to go ahead and do that? This is our grouping pipeline. So here is my group by operator. Now I want to be able to group it, but the problem is that group by expects an item and another item and another emitted item and another emitted item. And what posts with category emits is one array of items. Here, group by, here's an array of stuff. And group by goes, okay, I have this one thing, this one array. What am I grouping this array with? And you're like, that's not what I wanted. I didn't want to group the array. I want to group all the items in the array. And that's the purpose of the concat all in this case. What this concat all is doing is it's going to take each item out of this array that the post with category is emitting, and it's going to emit each item out of the array. So the group by gets post 1, post 2, post 3, so it can then group them. The group by syntax then, it takes two arrow functions. The first one is a key selector, which is telling me what I want to group on, and I want to group on the category ID. The second is the element selector. So what is it that I want to group? You know, maybe I only care about the post name or the post string, but in this case, I wanted the entire post so that I could bind to all of the different elements on it. So my element selector is the post itself. So the next thing is that the group by actually emits this group. So it will emit every time that the category ID changes. So if it sees one for category ID 1, it will emit this group. And then if it sees one for category 2, it'll emit that group. If it sees one for category 1 again, it does not emit again. It rather emits into that first group. And that was a little bit difficult to picture at first. So what you end up with then is something that looks like this once you've zipped all of them together. So what this is going to zip together then is the group key. And I'm using of here because zip wants to work with an observable, not the number. So I'm taking that number and making it an observable. And then I want to array. I want all of the posts that match that key in an array. So the category ID of 8 has 2 elements in the array. Category of 9 has 2 elements. Category 2 has 1 element in the array, and so on. And by using a array, it's going to wait for all the group bys to finish and ensure all of that process is done before it emits. And then what the merge map will emit is each one of these. each one of these little tuples, however you say that word. So it's going to emit each one of these. And what that would do in our UI then is would display one and then make it disappear when it displays the next one. And that's not what we want. We want all of them. And that's the purpose of the toArray here. So the zip for each group emits one tuple, the ID and the array of posts. And then the toArray emits one array with all of them in. So there's an array around all of these guys. Here I just dumped the console. So here is my 0th element, 1, 2, 3, and so on. And you can then loop through this. So you can go through each of these groups, or each one of these I called a group. And then for each group, we can go through its array of posts. So it's group element 0 is the ID, group array 1 is this array. So then I can loop through all of those and display them. And that is our pipeline for grouping. Okay, last one is autocomplete. So here is an autocomplete, and it's a standard kind of autocomplete. You type something in, and it's going to filter the list down. Okay, so start with the questions. What do we have? Well, we have our categories already, right? So we've got our categories. What do we want and when do we want it? Well, something like this, that becomes a little bit more complicated. And what's nice about this example is real life code is also gets complicated. So I wanted to cover an example that was more like what you might run into for more complex kind of UI. So we're going to answer the what do we want and when do we want it on a separate slide here. So what do we want? When do we want it? Well, when the user types, we want to filter the list. Straightforward enough, right? But also, if they click on here, we want to open the list. So when they first come to the page, the list isn't showing, they click in there and it'll open the list. But what if they don't have a mouse? We also want to open the list on focus. So if the user's tabbing around, when they get to that field, it'll open the list. And then there's this little X over here. When the user clicks on the X, we want to clear the list, clear the entry rather, and open the list for a selection of a new one. So we've got 4 different user actions. Does that mean we need 4 different action streams, 4 different subjects or behavior subjects? Quite possibly, the answer might be yes. So let's take a look. All right, so we've got focus, that's a subject. Click, that's a subject. Clear, that's a subject. Okay, notice we don't have the text one here. So in our template, we've got an input element. What we're doing is we're binding to focus, and focus is nexting in and emitting the target information on focus. On click, it's doing the same thing. It's emitting into that click stream. Now, a lot of developers, or some developers anyway, don't like having all that logic in their template. And if that's you, you can instead do something like I did here with the click on the button. So this is that times symbol, that little X. And instead of actually nexting right here in the template, I'm calling a method. And you could do the same thing for those two. So here is my onClear method. Now in this particular example, I'm using the Bootstrap type ahead. And the reason I don't have a text stream is because it will give me a text stream. And it expects a search function. So we're going to build that search function and its pipeline. So here are our 3 streams that we created. Here's the text that we're getting. And here is the search we're defining. And again, we're going to break these into little pieces. So our debounce text, we're going to debounce it so that if the user is typing really quickly, ABC, it doesn't look up A and then AB and then ABC. It waits until the user stops typing and then gets it. And we also have distinct until changed on there. For the click to open, we're going to pipe it through a filter because if it's already open, we don't want to tell it to open. So that's what that's checking for. Then we merge this debounce text, the click to open, the focus, and the clear. We merge them all together. then we combine latest on the operations and our list of categories. Now, why not just combine latest this whole set? Combine latest, debounce text, click to open, this focus, this clear, and then we don't have to have this extra merge. Well, if you recall, what I said earlier is combine latest will wait for each of its streams to emit at least once before it emits into its pipeline. So if we put all of them here in the combine latest, what would happen is the user would have to type text, click to open, set focus, and clear in order for it to actually do anything. And that would probably not be a good user experience. The merge is more like an or. So if any of these things happen, if you type in text or click to open or focus or clear, then operations will emit. So if any of these things emit, it will emit here and it will combine it with our categories. Then our pipeline becomes relatively straightforward. Here again, we're getting an array. I'm again using array destructuring. So here's the text coming from the operation. And here are my categories. So if the text is empty, I'm going to display all categories. And frequently that is what you want to do. Unless your list is too long, then maybe you don't want to display anything until they put in something. But you can deal with that logic here. If the text has a value, then it's going to filter. And here I'm using a regular expression, excuse me, but with only a hat, because I want to do a starts with kind of search. Now, if you wanted to pick anything that matched within, then you just take off the hat and it can match within. This I here is specifying a case insensitive check, which we'd want to do. And this test then is testing the name of the category against this regular expression. And that then filters our list. And we get our filtered list. So that was those were our 4 pipelines. This is my Twitter. So if you have any questions after this, feel free to reach out to me on Twitter. And the sample code for this is in my GitHub repo under Angular-posts because it's managing posts. So I hope that was helpful. Thank you.
Thank you very much, Deborah. That was a great talk. And there are some comments on the chat as well that you might want to look into. And thanks again very much for joining us today. And yes, enjoy the rest of your day.
Thank you so much.
Okay, I'm going to bring in our next speaker, who is Zack. In a second. Okay. Hi, Zack. How are you?
Hey, doing well. How are you?
Good. I noticed that you changed your surname for the past few days.
You mean on Twitter?
Yeah.
Yes. Yes, I'm now officially Zack RxJS.
Yeah, that was funny actually when I saw it the other day.
Yeah.
That's good. Okay, let me you have your slides queued up, so let me bring that up.
Yeah.
And all right, I'm not gonna take too much of your time. So I'm gonna leave you to give your talk, and I'll be back at the end.
Sounds great. We'll jump right into it. Hey everyone, I'm Zack DeRose. I am a senior engineer at Narwhal. We make NX. And I'm also very interested in RxJS. So that's what we'll be talking about in this talk, talking about visualizing the timeline. So this talk is really all about setting a mental model, exploring that mental model with some examples, and building tests around that, and building things off from there. So before we get into RxJS, though, I want to talk about the Ford Model T, which is maybe a weird departure for what you might expect to see. But there's something I found out recently that that I thought was super interesting, which was for the Model Ts, one thing Henry Ford was particularly proud of is the fact that if any 2 Model Fords anywhere in the country happened to cross each other, the drivers could get out, they could switch crankshafts, and they could get back in their cars, and they could just go. which I think is interesting for kind of the way I think of RxJS, and the way I think a lot of the power of RxJS comes from, is being able to have these pieces, these modular pieces that you could switch in and out of different use cases, scenarios, even applications, and things just work. I think there's a lot of power there. And it kind of goes into this idea of knitted versus Lego castles, where if you think of like a knitted castle, like I've got on the screen here, if you can imagine, like maybe we wanted to add some windows to this bigger castle in the middle, or change the color of the tops here, it would actually take quite a bit of doing to like unknit all that stuff and find some new stuff and knit that on top. It would be a mess. In contrast, if you had a Lego castle, if you wanted to change the roof, as long as you had a different roof, you could pretty much just pop that off and put something new on. If you wanted new windows, you kind of just do the same thing. It's pretty easy to piece everything back together after you make alterations. And I think RxJS really leads into this kind of Lego approach as opposed to a knitted approach. And we'll get into that in a little bit. But let's start off by setting our mental model. So I often talk about observables as timelines. And what I often say actually is observables are like two-dimensional arrays. But they're not two-dimensional arrays the way we normally think of, where it's like nested arrays. So both dimensions being spatial. Observables, I think, are actually more like two-dimensional arrays where one dimension is spatial and the other dimension is temporal or time-based. So a timeline is pretty much this. There's some amount of time passes, and along that passage of time, certain events get emitted. I think that's the best way to think about observables as we dive into RxJS. And the other big concept I want to talk about is operators. And this is where things get really interesting, I think. At the end of the day, and this is actually what operators are, is functions that take an observable and then return a new observable. Or if you want to just think of it as a arrow function using the timeline analogy, it's this timeline returns a timeline, right? So this is a good mental model to keep in the back of our heads. It's the mental model I'm going to be trying to drive home with a lot of these examples as we go on. So let's start by getting into something solid. So creating an observable or a timeline. So if we talk about creating an observable or timeline from clicks, we can see here, click, click, click. That's kind of a timeline here, and the timeline we see on screen is actually like a visual representation of what that observable would be. And here we have the code that would take for us to create this observable using RxJS and the from events utility function. So let's jump into the code and type this out real quick. This is a stack blitz that if you see the code up here, you can go ahead and jump in if you want to follow along. But yeah, we're pretty much getting an element. So that's just the button we see right here. And we're creating an observable from that button's click event. And we're subscribing to it to console log. And you can see as I click the button here, we're console logging out those events. So like mission accomplished at this point. We've created the observable. We've done piece one. And as we can see, the callback we pass inside of our subscribe, this is super powerful because based off that event, we can subscribe to this and we can do any kinds of things we want in here. Console log is just one Lego block we're kind of putting into the callback. But you could put any number of Lego blocks in here and you could make some really powerful applications with just this. But I think a lot of the power can come from taking some of the operator concepts we have, packaging it up to create larger Lego blocks, larger operators from smaller operators. So thinking of like the operators we get out of RxJS is kind of like our primitive operator types, and building larger operators from that and then using those larger operators to build really powerful Lego blocks that we can use across our application and do a lot of cool stuff. So yeah, so the observable is pretty cool, but can we take it further? So we're going to build a count operator. So if we think about the mouse clicks that we saw before, what we have is kind of this timeline. This kind of goes back to Deborah's talk. That was not intentional. I didn't mean to steal from you, Deborah. But we have this kind of observable, or this timeline at the top that shows us, this is just the same click observable we were just looking at. But what we want is actually a timeline that will tell us as we go over time, how many times has that button been clicked. So you can see we have this like observable of clicks that we don't really care what's in them. We actually want just an observable of a number that just tells us how many times the dang thing's been clicked. And we can see at the bottom here, we've written out some marble tests that pretty much mirror this, what we have and what we want. You can see what we have. We see represented in ASCII art here. Each A is kind of one of these circles up top. And what we want is expressed by this ASCII art over here, where what we actually want is numbers 0 and then a 1 and then some time and then a 2 and then a 3. So marble tests are a great way of solidifying this mental model, I think, and giving you like a really accurate hold on what observables are actually doing. I think it's very easy sometimes to just like see pipes and think about operators and just be like, man, it's all flows, it's all a stream, it all works together. And things get really wishy-washy on the edges of that. And so I think marble diagrams in particular are really good ways of getting really solid and really pin down what's actually happening here. So anyways, we have sort of our tests. We'll come back to this and see this pass in a little bit. But we want to get from what we have to what we want. And so we're going to start using some of our primitives we get out of RxJS for this. So the first one we're going to use is scan. So scan takes it follows the reducer pattern. It takes this sort of reducer signature that we take in. It's going to take, and we're going to pass it this callback that will take whatever the previous value we had and add 1 to it. We're going to start with a 0. So you'll notice we don't actually have a 0 at the start, but we are starting from 0 in the sense that when we get our first emission, we don't have a previous thing yet in our accumulator. So we're going to throw a 0 into that and we'll get 1 the first time. Then we'll go on in 1 and 2. And we do want the 0 at the beginning. So we're going to add a start with 0 operator on top of that. Now, if you visualize this, you can visualize maybe here's a pipe that the scan and then the start with are being loaded into. And that's exactly what's happening. That's the mental model we're building, is with each one of those operators, you're actually taking the operator that came before it and creating a new operator. Taking the operator that came before it and creating a new operator. So yeah, we can actually take those down. And we can see here, there's the count function that takes an observable and returns the new observable as a number. And we actually, the best way of building new operators is just by piping together old operators or piping together our primitive operators. And we can see by doing exactly what we saw in the previous slides, we can actually make our own count operator right here. And that's what we did. So let's go ahead and code this out real quick. So we're going to make our count function here. It takes an observable of some type, doesn't matter really, and returns an observable of a number. We can see we're scanning and see we start with. And now when we create our second observable here for our stacklets, we're going to take our second button and take its click, and we're just going to pipe on that count operator we made right here. And now we can see by subscribing to our second observable and setting the text context to that X, we are actually creating we're actually taking the span that exists right here and updating it so that it's staying in sync with this observable we created. And as you saw, I went pretty fast in the video here. I promise I don't type that fast in real life. But as we saw, we just copied this code here, just using the count operator again. But we attach this now to a third button instead, which allows us to, like Lego blocks, just throw in the new count for a new button. And yeah, that makes for some pretty cool stuff and some pretty cool possibilities. I think counting is like one of the more simpler things we can do. And we'll get to a more complicated example later. But first, let's take a look at the marble tests real quick. So as you can see, we kind of have the tests we had laid out before. We got some other random tests here, just thinking of random scenarios we might be running. And by hitting that run, we can pretty much instantly see, okay, these things are all going exactly as we expected. If there was ever an omission that was even slightly out of place, we would instantly know just by being able to watch or run our test suite, which is very helpful for getting these things pinned down, making sure we're building what we actually want to build with RxJS, which can be very tricky, especially when we get into more complicated things. So we want to take these same principles and bring it to a more complex example. In this one, we're going to create a operator for clicks, really emissions, as we'll see in the coming slides, for emissions in the last X seconds. So if we think about how we want to do this, we're going to call it window count. What we have is kind of at the top here, same clicks, same click observable. And the result that we want is kind of this observable that as soon as we get an emission, as we can see, let's just run that again. As soon as we get that emission, we want a 1. But after that time has elapsed, we want that to go back down to 0. And here we see there's 2 clicks right in a row. So those actually fall within the window. So we want to see that go from 1 and then to 2. But then once the time has elapsed on that first click, we want to go back down to 1 and then back down to 0. So yeah, this is what we have. This is what we want. And we can write a marble test here that gives us precisely that. So before we even starting to implement this, we can write a test that will make sure once we're there and we've kind of arrived. It doesn't really matter in some ways what the implementation is as long as this passes, which is an interesting way of thinking about these things and an interesting way of thinking about building things in general. But yeah, with RxJS, I feel like this is a really solid approach. And you'll notice too, this is a test in essentially 2 statements, which is I think very powerful for all the different edge cases like this test is actually running right now. Anyways, let's break this down to the windowed count and let's see how we could actually implement it. We're actually going to start by breaking it down to this one piece where we just want to get sort of an observable of a 1 and a -1. So we'll break things out to do that first. So we'll start with the timer utility function provided by RxJS. The way this works, as we can see here, is we pass in some amount of time. And as you listen to this observable, each time that amount of time elapses, we progress from one number to the next. So that's a very helpful jumping point for what we're trying to do specifically. So the first thing we'll want to do on this is just take 2, because we really only care about the first 2 ones, and anything past that is not of use to us for what we're trying to do right now. And then following that take 2, we're going to want to map the emissions, and we're going to ignore the first parameter of our map callback and instead just look at the I, because even though the numbers may actually be useful here, what we really care about is which count of map are we actually on. So we're going to say if we're on the first count, we'll put a 1, we'll emit a 1, otherwise we'll emit a -1. And what we'll get here is a +1 and a -1 every time we call this new function that we're going to call window. So here we can see window is a function. Here is implemented as an arrow function that takes some window length and returns us to an observable of 1 or -1. We can see exactly like we saw in the previous slide. We're just taking a timer, piping on a take 2, and then a map. And that's it. So now we have this window of +1 and -1. You may be asking, why is this useful? And well, it's useful because we can merge map our initial click observable to these window observables we created down here. So what merge map will do, kind of in this box, you can see this is just an imaginary box. You can kind of think of it as on each emission we're spawning a new observable. It starts immediately by emitting a +1. Then after this duration has elapsed, we emit a -1. And so we can see with that emission, we see this new one spawning. That emission, we see this new one spawning. And this one emission, we see this one spawning. And then if you recall from Deborah's talk, we used merge in her one of her examples. We're actually just going to take that and merge that down via the merge map into this one observable. And if you recall, like our initial example, this is pretty close. Like it should be, hopefully it's pretty obvious what we're going to do next, which is pretty much the same thing we did in count, because we've got most of the way there now. So this is great. So once we've got our merge map, we're going to put another scan on there, and this time we care about the previous value that was emitted from the scan, and the new value coming in from our merge map. So as we can see, top one again is the button clicks. That gets merged back down to these +1s and -1s. And then we're scanning those down into these numbers, these emissions as we go. And so if you're paying attention, we're still missing one thing, and that's start with. Just like before, we need to start with 0 here to make sure we start with an initial 0 as we subscribe to this observable. So again, mental map, mental model coming out. You can think of some observable at the top, and then pipe, and then merge map, and then scan, and then start with. This is the mental model we're going for. This is the thing we're trying to reinforce. So there we go. We have our windowed count operator that does exactly what we wanted it to, theoretically. We'll code this up next, don't worry. But it's a function we can see that takes a window length and it returns a new function this time. So it's kind of like currying to create our actual operator, because this inner function, I think, is maybe actually our operator. It kind of depends on how you think about it. But given an incoming observable, we want to create an observable of a number. We're going to take the incoming thing. We want to merge map it, scan it to start with. Same as the previous slide. So let's go ahead and code this up. So we'll start with our window function. Remember, just taking a length and returning a observable of 1 or -1. I actually have a bug here. So if you can see it, kudos to you. But we'll see me fix it later in just a second. But now that we've got that window, we can create our windowed count operator here. We'll pass in the window length as a parameter, and then we'll return a function that takes an incoming observable and returns an observable of a number. And then given that incoming observable, we'll just take that return, but we'll pipe on the merge map, the scan, and the start with. And once we have that, we're able to just kind of pipe that onto the observables we already had available. So this fourth button clicks observable. We can just pipe on a windowed count there. And we can see as I click it, it should be going up, but as I mentioned, I had a bug. So just fix it real quick, get that thing turned around. But as we can see at this point, we are, I've paused it, but we are clicking the button, and our values here, because we're subscribing to it and setting the text context of our span, we're keeping that in sync with how many clicks we've had in the last second. So you see it go up and then come down. And then Lego blocks again. We want to do this for the next 5 seconds or 10 seconds. We take the same thing, we just adjust the window length, and as we click, we can see I'm continuously clicking here, so you can see like the clicks in the last second going up and down, but then 5 seconds starts to trail off, and then what's 5 seconds trails off, the last 10 seconds trails off. So this can be a super helpful operator in general, and it doesn't really have anything to do with clicks. This could be super helpful if we want to know, for example, a backend, for example, how many requests we've received in the last 10 seconds, something like that. If we can have the number of requests as an observable source, we can just kind of pipe on this windowed count, and we could have an observable that tells us accurately how many requests have we received in the last X seconds? Or we could apply this to any observable, which makes this, in my opinion, a very powerful tool, something that that could definitely help us build better, more modular, more Lego block-ish applications as we go forward. So yeah, taking this too, we have our unit test set up for this as well. So as we can see, this is the kind of example that maps, but we also have this example, and this one's kind of cool. Let me pause here. Because using the test scheduler, we're actually like scheduling on virtual time, which means that if you see this observable, we're actually taking creating an observable and saying, well, wait 1 second and then emit an A, then wait 7 seconds and then emit another A, and then wait 2 more seconds and then emit a final A. And then we kind of have our expected observable, and we got to do weird stuff around like milliseconds to get this to match up, but we're kind of making it match. The takeaway though is this should take at least 10 seconds. I think with this one, probably more like 15 seconds if you add that all up. Maybe, not sure. But if we can see, once we hit run, oops, I went the wrong way there. There we go. Yeah, so as we hit run in just a second, there we go. It does take a little bit, but it definitely doesn't take 15 seconds. We can see the actual tests themselves take a few milliseconds to run. The full time is 4.3 seconds. I think most of that time is the TypeScript program getting set up. But yeah, it's we can potentially test some very long-running and complicated logic here with these marble tests. Still make sure everything's really nailed in place exactly as we want it to be, and yeah, and it won't, if you have stuff that's you want to test a scenario where after 5 minutes things time out and you get sent back somewhere, you don't have to wait 5 minutes for that text to actually run using the test scheduler, which can be very cool. So yeah, taking these all of these ideas and kind of going back to the examples we had talked about with Henry Ford, with the knitted castle, and with the Lego castle. I think RxJS is this really, really cool tool for being able to push these ideas forward and to bring this kind of modularization to your applications. I think, though, on a macro level, the company I work for, Narwhal, has this really great tool called NX that I think can take these same principles and turn that into, you know, more modular code, in my opinion, better code that you can bring into your projects or your workspaces on a macro level and kind of get the same thing out of it. So if you recall how we went about picturing these things in RxJS, it was establish a mental model, visualize it, and then implement it, and then and then test it, and have your tools in place to make sure that everything is accurate, and verify that what you built is what you want it to build. In some ways, you're making sure, like Henry Ford did, that if these two cars came across each other, you could switch out their pieces. And yeah, I think at a macro level, this is what I really like about NX as well. And so yeah, I have here a dependency graph of an NX workspace. So this kind of folds in with visualizing a workspace the same way we would visualize observables and operators with RxJS. This depth graph is actually generated from source code, so you can tell based on your libraries or your projects which projects depend on each other. Which, when you're structuring an application, that can be very helpful, and it can NX by its tool sets makes things, in my opinion, much easier to structure things in such a way that you can actually test by if your Lego pieces will work in one application or in another application, and you can interuse them equally. And I think there's a lot of power in that and a lot of promise there as well. So to give you some information on NX, if you're not familiar with the topic yet, NX is a sort of a toolbox solution for monorepos or just projects in general. We have support for Angular, plain old JavaScript, React, Node. There's also some community plugins out there for Vue, and even some non-JavaScript language things like Go and Python. But a lot of the power that comes from NX being a toolbox is you can set yourself up immediately configured with TypeScript, with Storybook, with Jest, with Cypress. All these things are supported first party by our toolset. And it makes things really easy to, for example, set up Storybook with a scenario where you're loading one module and then another module, making sure things work still. And there's just a lot of ease that comes with being able to have Cypress automatically configured for you, or just spinning up a workspace and being able to run Jest tests immediately, as we saw in this example previously. So yeah, if the talk about Henry Ford and knit castles and Lego castles is resonating with you, I highly recommend you check out NX as a way of bringing that same kind of interesting stuff we do at a micro level with RxJS to your whole workspace at a macro level with NX. So yeah, and just wanted to give a huge thank you as well to all of the people at RxJS. So Ben, Jan-Niklas, and Nicholas Jameson, and everyone there on the core team who's put a lot of time into this. Personally, I've gotten a lot out of RxJS, and I feel like I don't contribute back enough, but I'm super grateful for all the work and time that y'all have put into this. And it really shows, especially with the upgrades going to 7. So huge props to y'all on that. And thank you so much for the work you do for me and for the entire community. And yeah, that's the talk. First, if you want to follow me, here's my Twitter handle. And if you're interested in NX, based on what we had talked about, you can make sure to check out our NX site, which has our docs and our API, as well as some tutorials and getting started videos on how you can get started in your company or in your projects using NX. And we also do office hours every other week, and you can get all the updates for this and all of our events by following our Twitter here at NXDevTools. So yeah, that's it for my talk, and thanks for coming by, and thanks for supporting RxJS.
Thank you, Zach. That was a great talk. Right. Not sure if there are any questions. I don't see any at the moment. So that's fine. So maybe if you're staying for a bit, just look out for questions on the chat. Yeah, if you can kindly reply to them, that will be wonderful. And thanks again for joining us today as a speaker.
Yeah, thank you so much for having me, and Jen, thank you so much for putting this on. This has been awesome.
Yeah, really cool, hopefully as I was saying earlier to Ben, hopefully we can do this in person soon. Who knows when we're going to be able to do it? We'll see.
That would be awesome.
It would be great to have all of you here in London or in Asia, whenever we can do it. Thanks again, Zach.
Yep, thank you.
Okay, folks. So our next talk is about recreating the Flappy Bird game using RxJS with TypeScript. And it's going to be a talk by Nia and Carlos, who are both from Spain. So let me just bring that up. Hang on a second. Okay.
Welcome to RxJS Live.
Hello. We're so happy to have you all here today and to be able to do this online. So thank you so much, everyone, for attending. You're all amazing. Anyway, today we're going to be talking about and coding the Flappy Bird game in TypeScript, which of course means that there's going to be plenty of RxJS goodness in our code.
But before we get started, I would like to introduce Estefania, who is a full-stack developer.
And I'll introduce Carlos, who has a PhD in computer science and who's an associate professor at UOC College. He is also a Google developer expert in Angular. So we've worked together on several projects, like, for example, Angular Malaga, which is a local Angular community in the south of Spain, to which, of course, you're all invited as soon as this whole COVID situation is over.
We have also got an open source project named Angular Communities, where you can find information about all of the Angular communities around the world. Nia is also co-creator of the npm package npkill, which allows you to easily find and delete Node modules.
Finally, and this is some exciting news, we have just created a new YouTube channel where we're going to be talking about everything tech. So from web technologies like RxJS, JavaScript, Angular, etc., to more advanced software engineering topics. So we'll drop the link at the end of the talk in case anyone wants to check it out.
Now that the introduction are over, let's get started. Our talk is divided in two different sections. The first one is all about the theory behind the application. We will talk about the RxJS operators that will be used in the code.
And in the second section, we'll be looking at the actual code. Not all of it, because we don't have time for that, but we will talk about all the juicy parts which make use of the RxJS operators. So, Carlos, how about showing everyone the app that we're going to be building today?
Of course. Here is the preview of the amazing Flappy game.
I'm going to have to be honest here and confess that I was the one who was playing when that GIF was recorded, but I do promise that I am a better coder than player. So, this said, let's get started.
Since this is an RxJS powered Flappy pair, we need to talk about the true source of RxJS power, the Pipeable operators.
Definitely, because RxJS happens to be so powerful and so amazing that we're going to be able to build a complete video game by only using 10 operators, which is amazing. Before we start talking about the code, we're going to briefly go over all of the operators that we'll use in the code so that we're all on the same page.
So, let's begin with creation. We are going to use three very simple operators. The first one is intervals. Emits an incremental sequence of number every certain amount of time. Timer is like interval, but it allows us to specify an initial delay. Finally, we have from event. It allows us to create an observable from a done event, a Node.js event emitter, etc.
I have to add that it's important to indicate the type of the event that we're turning into an observable to be able to have the specific typings for that event, because if we don't, we're going to run into the classic property X doesn't exist on type event TypeScript error, and we probably don't want this happening. So now that we're done with creation, let's talk about pipeable operators. We'll be using several of the filtering operators, like for example, delay. Now, as its name indicates, delay delays the observable's emissions by a certain timeout. And of course, filter, because filter is probably one of the most used operators out there. So we're going to use it so that our observables only emit the items that satisfy a certain condition.
We will use takeUntil to complete all the observables once the game is over. First, emit only the first value.
Then we have buffer time, which basically collects values for a certain amount of time and then emits them as an array. We also have scan, which is very, very similar to reduce. It accumulates values over time, but unlike reduce, which waits until the observable completes, to emit a single value, scan instead emits each accumulated value on each iteration.
That performs a side effect for every emission on the source observables. Finally, share makes call observables behave like they are hot. Now that we are acquainted with all the operators that we are going to use in the code, it's time to talk about the roadmap.
So, in order to make things easier, we've divided the application into several simple steps. We'll start off slowly by learning how to flap, because there is no Flappy Bird without flapping.
Then we will continue with another crucial part of this and every single video game out there, the game loop.
Once we've got our game loop, we'll need to add the remaining elements, which are basically the skyline and the pipes. And these, of course, need to be updated in order to create the sense of movement.
Then all that's left to do is code the game over logic, so that when we crash into a pipe, we get that lovely game over message that all gamers love so much. Last but not least, we will add the icing of the cake by introducing a little Easter egg into our game. Because, let's be honest, a game isn't a game if it doesn't have secrets.
Okay, theory is fine, but enough talk already because we're here to code. So let's go ahead and do just that. So the first thing we're going to do is take a look at what our project structure looks like. So as you can see, we have a main controller, which is in charge of communicating with the game service that will contain all of our observable logic. And with the models, we have 3 models, the player, skyline, and pipe models. We also have some assets that include the CSS files, the sprites, the backgrounds, etc. We also have some constants, which, as their name indicates, contain all of the constants. Finally, we have a libs directory, which contains a library named bump, which we'll be using for collisions, because collisions are a very nasty part of video games, so we need as much help as we can get. And last but not least, we have our app, which is basically the launcher of our application. So if anyone would like to clone the project and take a look at the full code while we're doing the talk, here you have the link to the repository. I would really recommend that you do clone it because, as we said before, we can't really focus on the entire code, just on the RxJS specific part. So there's parts of the code that we aren't going to be paying much attention to, the ones that deal with Pixie.js and so on. So if you want to take a look at the code, this said, clone the repository and let's move on. Finally, we can start with Kiwi. Kiwi is the name of our bird.
The first thing we are going to do is teach Kiwi how to flap. So, how do we implement this? We will begin by using from event to create the presskit observable, which will emit every time we press a key. We are also going to use the share operator to multicast the presskit observable.
Since we're only interested when certain keys are pressed, the spacebar and the arrow up keys, we're going to filter out the rest of the keys because they're completely irrelevant to our game, and we're going to use the filter operator to do so. Then, in our main controller, we're going to pipe the onFlap observable that we just created and use the tap operator to perform a very important side effect, which is to change Kiwi's sprite so that it appears to be flapping. As you will use the delay operator so that the change between sprites isn't immediate, which makes the animation nicer.
Here is what flapping is going to look like. Each time we press the spacebar or the arrow up key, Kiwi will flap.
So the next thing we have to do is add gravity, which is one of the essential elements of practically every video game out there.
Before we can add gravity, we need to talk about the game loop. This is one of the invisible yet crucial part of our application logic. For those who aren't familiar with the concept, the game loop is the central, most important part of any game's code. It runs continuously during the game and is responsible for processing the user's input, updating the game's state, and rendering the game.
So, just as a fun fact, I'd like to take a couple of minutes to tell you about game loops and video game history. So, early on in the day, video game developers knew exactly what CPU their game was going to run on, so they wrote code that was specific for that CPU. All they had to worry about was how much work was performed in each frame, in each iteration, and the game ran just fine. However, these days, unless you're a AAA developer working for a specific platform, like, I don't know, PS5 or Xbox, then you have absolutely no idea what kind of hardware your game is going to be running on, which is why it's very important that the code that you write can adapt to the different hardware specifications. And this is the other super important responsibility of the game loop, to run the game at a consistent speed, regardless of the hardware that it's running on. So now it's time for us to implement our own game loop. We have a ticker class that Pixie provides us with, which is basically going to run the event loop for us. All that we need to do is attach a handler, which in our case, since we're using RxJS, we're basically going to next the numeric values that are emitted by ticker to the on-frame update subject that we've created in our game service.
It's finally time to actually add gravity. In the main controller, we are going to pipe the on-frame update subject, which emits the value of each animation frame. We will then use this value to calculate gravity and update the player's position accordingly by calling the setGravity function.
So here we go. We now have to flap to avoid a certain death. However, our game looks absolutely flat and boring, so I think that it needs a little bit of movement. So we're going to go ahead and add some.
It's time to add the skyline. So, for the skyline, we are going to create a new observable in the game service, the Skyline Update Observable. We will be using interval to create an observable that emits every second. Once we have done this, we can go to our main controller and pipe our new observable. First, with map, we are making a call to the getLastSkyline function, which returns the last skyline instances in the canvas. Then we use the isNewSkylineNeeded function to filter the string. This function checks to see if it's time to render a new skyline sprite. If it returns true, we call the createSkylinePiece function, which will instantiate a new skyline sprite in the canvas.
So once we've done all that, we can use the on-frame update observable to call the update position function, which, as its name indicates, will update the skyline's position according to the delta value, much like we did earlier to calculate the gravity.
Our game is starting to look a lot better, isn't it? But it's still missing something very important.
It's missing pipes, of course, because what kind of Flappy Bird game doesn't have pipes that you can crash into? So let's go ahead and add them. Allow me to introduce timer. As we mentioned before, it's just like an interval, but it receives a parameter that specifies an initial delay before it starts emitting values. You may be wondering why we need this initial delay. And the answer is very simple. We don't want pipes to start appearing as soon as we start the game because we want to give the player a short time to get adjusted to the feel of the game before the obstacles start appearing, which is why timer is perfect. Once we've created our create obstacles observable in the game service, we can pipe it with the tap operator and call the create pipe set function, which basically creates a new set of pipes. We'll also call the delete old pipes function, which is in charge of deleting the pipe sprites that are no longer visible in our game, but that are still consuming resources.
Just like we did with the skyline, we need to update the pipe's position, which we will do by calling the update position function from the onFrameUpdate string.
Now we're talking. Our game is almost ready. However, Kiwi is passing safely behind the pipes, and despite how much we like him, the game is no fun if he doesn't crash into them. So, it's time to implement the game over logic. However, before we talk about the game over logic, we need to talk about how we're going to handle subscriptions. This may not be a visible part of the game, but it's crucial. Why? Because if we don't handle our subscriptions, we can end up with memory leaks, which is something that we most definitely don't want happening. However, since keeping track of subscriptions and unsubscribing manually isn't a maintainable solution, we're going to make use of a subject and the take-until operator to take care of subscriptions for us. So, how does this work exactly? The first thing we're going to do is create a stop-game subject and a stop-game function. Whenever we call the stop-game function, the stop-game subject will emit. So, where does take-until come into this? As we already know, the take-until operator completes an observable when another observable emits. So, if we pipe an observable with the take-until operator and provide the stop-game subject as a notifier, take-until will make the observable complete whenever the stop-game subject emits. By using this simple technique, we're gracefully handling subscriptions all throughout our application without having to keep track of subscriptions manually. As you can see, we've piped most of the observables in our game service with the take-until logic. The only observables that don't implement this completion logic are pressed key, because we need it to be kept alive in order to restart the game, and restart, because as you will see in the following slide, it's being completed by the first operator.
Now that we have handled our subscription, we can finally implement our game over logic. To do this, we are going to create a game over function, which does the following things. It calls the killKiwi function, rotating the sprite so that it simulates poor Kiwi's death. It calls the magic stop game function, which will cause the stop game subject to emit, thus completing all of the observables. It will render the game over message. And finally, it will call the restart game function. This function calls the destroy and start game function, which restart the game. As you can see, the restart observables only emits one value and then completes. This means that the restart logic is only triggered once. Now we need to decide when our gameover function is going to be called. The player loses the game if one of two conditions is met. First, the player is out of the bounds. Second, the player collides with a pipe. Nia, how do we implement this?
Well, it's really easy actually. The first thing we're going to do is create an addBoundsCheck function in our main controller that, on every frame update, will use the isPlayerOutOfBounds function to filter the stream. Whenever this function returns true, the game over is exactly the same as the one in the previous step. So we are basically done with the game over logic. Carlos, can you show us the result, please?
Of course, here is what our game looks like so far. Oh, we now have the basic elements to our game, but we are still missing a little detail. After all, it's not much fun to fly on without knowing how far you have gotten. For that, we will need to keep score.
Exactly. So, in the original Flappy Bird game, you get a point for every pair of pipes that you pass through. However, to simplify matters, we've decided to award the player a point for every pair of pipes that's created, meaning that you will get a point for every second that you survive without crashing. However, since the pipes start appearing after a while, and we don't want to award the player any free points, we're going to create a new observable that only starts emitting values when Kiwi reaches the first pipe. Then this observable is going to emit values every second. The next thing is to pipe our new score observable with the scan operator, increasing the accumulated value by 1 every time that score emits. Basically, we're adding 1 point to our score every second. Since pipes are also generated every second, it looks like we're gaining points by passing through the pipes. Now, in our main controller, we can call the printScore function every time that the score observable emits. This function basically updates the inner HTML of the scoreboard with a score. It's important to add another call to printScore in the gameover function to restart the score whenever we lose the game. So here is what our game looks like with the score.
Finally, we are going to talk about Easter eggs. And that means talking about Warren Robinett. For those who aren't familiar with his story, Warren Robinett is considered the first person to ever hide an Easter egg in a video game. Here we have a screenshot of the Easter egg that he hid inside the Adventure game, which was played on the Atari console. Basically, you had to find a hidden pixel and take it to a certain room, and the message created by Warren Robinett appeared on the screen. I would love to talk about the reason he had for doing this, but we don't have a lot of time, so let's go ahead and create our own Easter egg.
Our Easter egg is going to be a lot simpler than Warren's. If we press any key more than 6 times in 1 second, a secret message will appear on the screen. The first thing we have to do is create an Easter egg observable by piping the pressed key observable that we created earlier. Then, we'll use the buffer time operator to collect the pressed key events for 1 second. Then, we'll use the filter operator so that the Easter egg observable only emits when the length of the array is larger than 6. If it's larger than 6, it means that we've pressed more than 6 keys in 1 second, and the secret message will be displayed. So, how are we going to display the message? by calling the set Easter egg message function whenever the Easter egg observable emits. We'll delay for about 3 seconds, which is enough time for the player to read the message, and we'll call the function again to remove the message. And here we have our Easter egg. I know that Warren's is a lot cooler, but this one is coded with RxJS, and his isn't, so.
So that's all, folks. Our talk is over. Before we finish, we would like to thank Juan Torres and Tony Villena. They have helped us with the code, and they are awesome people. They basically live in GitHub. So if you are curious, you can look for them in there or on Twitter.
We love you guys. And we've reached the end. Thank you, all of you, for your attention and for being here with us. Also, thank you to the RxJS Live organizers for hosting this event online. Hopefully, we'll be able to have a real on-site event next year if the COVID allows it.
You can scan the QR code if you want to take a look at the repository that has the Flappy code. And once again, thank you very much. Bye.
Bye-bye.
Bye-bye.
So thank you very much to Nia and Carlos for that wonderful talk. I hope you enjoyed that. So we're going to go on a lunch break and we'll be back at 1 p.m. Singapore time. Meanwhile, we're going to be playing a video from one of our sponsors. It's a chat, with their co-founder and CEO. The company is called Adaptive Financial Consulting. So yeah. If you want to grab some food, enjoy the video and enjoy your lunch as well. And we'll see you back at 1 p.m. Singapore time. For attending today's RxJS live conference. So we have one of our sponsors here with us. So I'm just going to quickly ask him to introduce himself. Hi, Matt.
Hi, Jen. How are you?
Good. How are you doing today?
I'm very well, thank you. It's great to be here. So I'm from Adaptive. I'm the CEO and co-founder. We are a financial services technology provider. We build front office trading platforms for banks and hedge funds, exchanges, firms like that in Europe and in North America, as well as in Asia. We've been around for about 8 years, and it is fantastic to be able to support RxJS, Rx, and the approach it takes to the approach it enables to building applications is something that is right in the sweet spot of the sort of systems and platforms we build for our clients. I myself was using Rx back in 2010, 2011. I was just looking through my emails to try and find when I got my job that got me into Rx, which not the conversation for now, but is really the job that changed my life. So I hold Rx very, Rx means a lot to me, and it's fantastic that RxJS is going as strongly as it is with this fantastic conference.
Oh, okay, very interesting. So yeah, talking about Adaptive, I understand that you co-founded this with colleagues of yours. Where were you all before you formed Adaptive?
We were working for another consultancy, working for a French bank in London, and that project is actually the project that we used Rx on. So we picked up the first libraries of Rx that came from Microsoft back in 2010, 2011, I think it was. We were writing a Silverlight app that then migrated with Silverlight app on the front end with .NET on the back end. That is now been rewritten in HTML5, and we were big users of Rx at the time.
Okay, so it's a longer history of Rx then, with the team. So this is great. So can you tell us about why the mission, vision, and values of the companies speak to you personally?
Absolutely. So when I met the people that I started the company with, and indeed that team that worked on the project I just mentioned, we managed to put together a group of individuals who were fantastically great at collaboration and innovation and sharing of knowledge with each other. When we started the company a few years after that, we really wanted to have the same culture, an engineering-led culture where developers and other people involved in the software development lifecycle are collaborative, innovative, open about what they don't know as well as what they do, because we found that when we were in that environment and delivering fairly complicated, large-scale projects using cutting-edge technology, that approach of being able to say, I don't know, meant you learnt 10 times faster than if you pretended you knew, and also meant that the team itself delivered a better job, which was a really enjoyable environment to be working in. And so that we've encoded in our mission and values about being a great place to work that enables innovation and collaboration, exactly that feeling that we had. And I think the fact that we've got Josep speaking at the conference, he has picked up that innovation and collaboration spirit, and is a great example of it.
Yeah, I'm really glad that he reached out to me with regards to speaking at this event, because obviously RxJS is closely tied with the Angular community, and I'm glad to actually have someone speaking about React. Because obviously it's used, with other frameworks as well. So yeah, it's really wonderful that we have this talk today.
Absolutely.
Yeah. Okay. So do you want to talk about like the products that Adaptive has at the moment, and like who are your target customers?
Absolutely. So we like, as I mentioned, we build custom platforms for large investment banks, exchanges, and firms that work on what we call the buy side, so investment managers, asset managers, and hedge funds. And we're involved in a part of their world that is they call the front office, which is around liquidity discovery and liquidity distribution. So that is electronic trading. So those are the screens that you see when a journalist is standing in a trading floor and they've got a computer screen behind them and there's lots of numbers flashing, sending prices, and people entering deals and buying and selling large amounts of FX or equities or corporate bonds, all on screen. So those are the systems we build for our clients. And those things are characterized by streams of information. So a price stream with the price changing every 4 or 5 times a second is just a stream of information. To us, it's an Rx stream, and we model it as exactly that. And we use Rx on the front end in HTML5 applications through RxJS, be it with React or an Angular, as you mentioned, as well as on the back end. So we use Rx libraries like RxJava or Rx Scala on the back end to implement the same sort of composition and control of the streams of information that are flowing around the systems we build. We differentiate ourselves in the market by building platforms for our clients that they then own. So we're a technology provider to some of these very large firms, and we compete with other technology providers, so product firms that you might have heard of, like NASDAQ Technology is a good example of a product firm that sells into the space. What we do is bring technology that accelerates the delivery of projects for our clients, and then we build bespoke on top exactly what our clients need. So the developers and the engineers that work for us are involved in project work, building very complex, fast-moving, great-looking platforms for our clients that are very high profile, that mean a lot to their business. It's really critical for their business that this stuff works. So we put a lot of effort into quality of engineering, quality of testing, quality of design, and quality of requirement specification, because we understand that our clients are spending a significant amount of money with us to build their platforms, and that they run their businesses, which deal with quite a lot of money on a daily basis, and that we need to give them some of the best engineering that they can have, really.
Yeah, I can relate to that because I used to work for Citigroup.
Okay, there we go.
Yes, I'm very familiar with like financial systems and all that. And yeah, definitely, you know, like we I think used to subcontract a lot of the projects, you know, especially with like that project I was involved with, which is currently rolled out in 100 countries. And where Citigroup has a presence. It's a big project, and like internal folks, you know, there's not enough really to build, you know, this massive thing. So we have, you know, a lot of other companies, you know, and independent contractors working for us. And of course, yeah, there's always, you know, that focus on making sure that we get quality, you know, products and results from people that's being paid, you know, to deliver and do the job.
Exactly that. Yeah.
That's good. So speaking of innovation, what are you most excited about in terms of technology? Are there other things? Obviously, you're heavily in RX. Are there other things that you folks are like exploring in terms of like innovation?
In some ways, financial services is very innovative from an engineering perspective, in that it is really focused on very high performance, low latency systems, and demands a lot from engineering teams like ourselves. And in other ways, they can be quite slow moving. So we moved to RX in 2010 and have been using it in all of our projects since then, which I think is quite fast moving, given RX is still being talked about and picked up in the mainstream at the moment. But then in other areas like cloud, financial services is quite slow moving. So one of the areas we see great amount of innovation and excitement is in the ability to bring cloud native application architectures to front office trading platforms. We have built in the last couple of years quite a few platforms that are running on the public cloud. We won an award for that work earlier this year, actually, which was fantastic. And I think that the ability to reduce the amount of money needed to be spent on capital infrastructure, like hardware to put into a data center, and instead all the benefits that everyone at this conference understands from dealing with the cloud, right? The fact that you can just spin up infrastructure very cheaply and deploy and configure really high quality production grade infrastructure that would otherwise cost you significant amount of money and time to deploy physically. You can just click buttons and deploy configuration to get exactly what you need. That is where I see a huge amount of innovation coming from. Anywhere that lowers the cost of anything I should say, that lowers the cost of experimentation and the cost to get going is fantastic. And I think we're going to see a lot of innovation in that space, particularly with the more broader adoption of things like RX, where streaming and the concept of streaming data streams all the way through the UI and from the back end becomes more prevalent, will enable a lot of innovation as well.
Yeah, it's very interesting. You know, this move to cloud, because I remember back when I started a long time ago in Citigroup, like I was deploying like changes to production, and I have to like physically like go to a, you know, like,
pick things up, right? Yeah, like, exactly.
Like with all this, you know, like big machines, and yeah, so it's totally different now, which is really great. You know, I should said it's lower cost and it's much easier, you know, to deploy things. Definitely, like I'm used to like the usual SDLC, you know, model, but now it's all agile, and you can deploy, you know, like daily if you want to, right? So it's totally a different environment, and obviously it's a welcome change, you know, for everyone. So are there new projects that Adaptive is looking into at the moment, or just continually building things for clients?
We're very busy with client work at the moment. On our internal workbench, we have an application called Reactive-Trader, which for those that are going to attend Josep's talk during the conference, we'll see him show. That is where we do all of our sort of research and development, I guess you could say. It's an open source application, so people can take a look at it and understand the how we put together these sort of highly available streaming applications for our clients. As you would know, having worked at Citigroup, most of the things we build are pretty tied up behind NDAs and confidentiality agreements, and they're not particularly retail or consumer facing. These are enterprise applications used by other businesses, which means they're not that visible, unfortunately. And indeed, it's sort of a joke, but really the best time you do see the sort of applications we build is when a journalist shows up in a trading floor and you see it on the screen of someone behind the journalist, right? But the research and development we're doing into Reactive Trade at the moment is fantastic. We've just rewritten the whole app, or Josep has rewritten the whole app to take advantage of RxJS, and we're now rolling out that architectural pattern and style into our projects, hugely improving the performance of the applications we're building for our clients. And after that, there's always change in the ecosystem. So front-end applications in financial services are supported and run within web containers. They don't just run in a normal web browser. So platforms like OpenFin, like Mosaic, like Glue42 are all systems that our clients use to host and run their applications. And that system, that world is always innovative, and we're spending a lot of time keeping up with those features. And the other thing that we're seeing quite a lot of at the moment actually is around something called interoperability. So this is trying to bring the workflow style and feature you have of data interoperability on your mobile phone. So for example, the ability to share an address from one app into Google Maps, for example, and do something with that address onto the desktop. Web applications are fantastic for being able to mash up different data sources on the back end, so having APIs that you can call to bring in applications from different service providers. But there has been relatively less innovation on the client side, enabling me as a user to stitch together different workflows from this web app to another web app running on my desktop, to do this sort of integration myself in real time in response to things that I want to perform. We're seeing a lot of innovation there, and there's an open source consortium called Finos that specializes in financial services, and they have a group called FTC3, which I think is really going to bring a lot of innovation to the space, and we're big believers in that.
Okay. Yeah, I knew Joseph's talk would be very interesting. And initially, we allocated half an hour for his talk, and I was saying to myself, okay, this is probably the first time we're having someone from the working and using React with RxJS. So I said to him, "Do you need more time?" Initially,
and I'm sure he said yes.
Minutes, it's fine. And then we went to 45 minutes, and then eventually we ended up. I think we ended with an hour. So I'm really looking forward to that talk. And we've been highlighting that as well in some of the communication, that we're sending out, because as I said, I'd like other people who are using other frameworks to, check out RxJS and anything Rx really. And we also have Matt Podwysocki, who actually started, RxJS a long time ago. Obviously, Ben Lesh is now, the person who's been working in it in the last few years and have put in definitely a lot of, personal hours, getting it to where it is. And RxJS 7 obviously is getting released, around now.
Yeah.
So yeah, it's
the buzz is great. I remember Matt from the conference circuit a few years ago when I was going to different conferences and talking about the work we did and showing how we used RxJS and the applications we built. It's fantastic, the effort and the energy that he's putting into it. It's really great.
Yeah, definitely, and the same with Ben. I think both of them have contributed a lot. So yes, so yeah, we appreciate all the work that people have been putting in. I mean, these are all obviously open source projects, and no one's getting paid to work on this. So yeah, it's we're really appreciative and thankful of people from any open source project really who are giving their personal time to come up with with better products, and obviously this are being used by a lot of companies. RxJS in particular, I believe, has got, if I'm not mistaken, around 18 million downloads a week. So it's it's pretty massive. So imagine that big project being maintained by a small group of people who are not being paid to do this. So
absolutely, it's fantastic.
I really encourage people from the community to contribute to these projects, and also one thing I'd like to stress is that they have to be patient as well, because there are people who can be demanding even with projects like this, which are like maintained by people who are volunteering their own time. So I think we need to have a bit of patience with regards to people not responding to things, recognizing that this is really not their main job. So have a little bit of patience there and contribute where you can. Basically,
Absolutely.
I think it's a message for open source folks out there. So anything else that you want to highlight, Matt, with regards to adaptive? Or are you like hiring at the moment?
We are indeed hiring. We are indeed hiring. If anyone would like to come and work for us, please get in touch with myself. I'm sure my details will be available by the conference. Absolutely, get in touch with me. Have a look at Josep's talk, the style of application that he's building. Then that is exactly what we work on at Adaptive. It's not pretend. That is the style of work we do in the language and the tooling that we build our applications with. If that sounds exciting and cool to people, then we are definitely hiring all over the world. So please get in touch from wherever you are.
Yeah. So where are you present at the moment? I know you're in Canada and the US. Am I right?
That's right. Canada, the US, Barcelona, and also Spain and England and the United Kingdom as well. So offices particularly in London, Barcelona, New York, and Montreal. But we have people working from us pretty globally. We've got clients in Asia as well as North America and Europe. So just get in touch if you like the style of work.
I was surprised that you're calling in from London, because when I looked at your bio before this call, I saw Auckland. So I said, oh, he's going to be calling in from New Zealand. It's a bit late, over there.
Very late. Yeah, no. I've been in London 15 years now. So London's my home.
Yeah. Good. Okay. So thank you for that, Matt. And we'll obviously encourage more people to watch Joseph's talk. I definitely am, looking forward to that. And yeah, thanks for joining us today. And yeah, we'll share more information about Adaptive in a newsletter that's coming out around the conference. And yeah, so check that out, folks, and check out Adaptive. Thank you very much.
Thanks, Jen. Enjoy the conference, everyone.
Hi everyone. So we're back, and our next speaker is Lamis. She's from Tunisia, and she's going to be giving a talk on 8 healthy recipes for RxJS. So without further ado, let me add her talk to the stream.
And welcome to my talk, 8 healthy recipes using Angular and RxJS. I hope that you're enjoying the conference so far. And before we start, just a little bit about myself. My name is Lamis. I'm from Tunisia. If you don't know Tunisia, it's a small country in North Africa bordering the Mediterranean Sea. And I'm already the founder of Angular Tunisia. I'm a GDE for Angular and recently a Not-Zero ambassador. I've been into Angular for the past few years, and aside, I'm a speaker, mentor, and a content creator. So without further ado, let's jump into our recipes. And a disclaimer again before we start. All food pictures in this presentation are purely made for aesthetic purposes, okay? So don't try to make a link between the RxJS I am trying to point out and the picture in the slide, because there is no relation between them and does not reflect any of the concepts. And those recipes are nothing but like solutions, or to be more accurate, reactive patterns in order to implement a recurrent use case we face like every day as a developers when developing web applications. So every time I'll be presenting to you the use case and then the solution in order to achieve it in a reactive way. And of course, every recipe requires some ingredients, and the ingredients will be like most of the time are some RxJS operators. So let's start with the first recipe for bulk operations. And when we say bulk operations, it's the fact of running parallel network requests in one shot. Okay, you're kind of running more than one request in one shot. And again, here I have to emphasize something. The backend I'm using in all the examples I'll be introducing to you is a RESTful backend. Okay, so I have a RESTful backend, and in my web application, I am using Angular and RxJS. So we said, so bulk operations is the first recipe, running parallel network requests. And here I have my UI, okay, which is built in Angular, and I have the server in my server, the API, the REST API, and when triggering some kind of event, I am going to send more than one request to the server. Okay, so this is what bulk operation is about. And an example of bulk operations is upload files, or let's say massive uploads. Okay, so in today's applications, when we are dealing with some upload scenarios, it's whether you have in your user interface or in your form, in your, let's say, screen in general, form, or any other equivalent, you have a file that you will upload some files to your server. So you can upload one or many, okay? The problem is when you decide to upload or to perform this request, okay? So in order to enhance the user experience, you have to you don't have to block the interface every time you will upload a new file. Okay, so you better upload it in one shot, upload all those files in one shot after an event, for example, submit button or any other like equivalent. Yeah, so this is the use case, massive upload. This is the example for bulk operations, whether you have many files to upload in one component, or you have like many uploaded files in different components. It's the same thing. The result is the same. You like have to perform a bulk operation for whatever reason in order to upload those files. So this is the requirement, this is the use case, and what we need in order to achieve this is the fork join finalized catch error operator, and a custom function. Let's start with the fork join operator and let's explain it. The fork join operator falls under the category of combination operators. Okay, so you want to combine the results of your streams. And I really consider fork join as a severe operator because it emits only one time at the end or at the completion of the observables. Okay, so only one emitted value. So here, for example, we have 3 observables, and the last value of the first one is E, the last value of the first one is G, the last value of the third one is 4, and I am passing the list of those 3 observables to my fork join operator. So what am I going to get is the last value emitted before the completion of each observable, which is E, G, and 4 respectively. Okay, and why this operator is like useful in the case of bulk operation? Because in the bulk operations, I only need the final result. I don't need what's happening. I don't need to know what's happening or going on all along like the streams and the observables. I don't care. I care only about the final result. For the upload, for example, I don't care what's happening along the way. I only care about like the status. Is the file uploaded successfully, or is it uploaded with errors and stuff? I don't need something else. So yeah, so this is like useful, okay, in those cases. And so it emits only one value, which is the last value for each stream, last emitted value for each stream. This is what you need to know. The second thing that you need to know about fork join is that fork join respects the order. Okay, so I have here, like, this is the first observable passed, the second one, third one, even though the third observable completed first. Okay, the last one completed before the others, but still the value is emitted the last one because I passed it the last one to the queue. And this is something important that you have to keep in mind also in order to like notice what's happening for your streams. Well, so now let's see what we can do like into code. So here I have my upload file method, which is available in my upload service, my Angular service dedicated for uploading files. And here the upload file takes as a parameter the file to be uploaded and returns an observable of file status. Okay, the file status will contain the like result, if it's uploaded successfully or not. And if an error happens, then a short description of this error. Why? Well, this is a basic example. And I have here two calls to the upload file. I have the first request and the second request because I have 2 files to upload. Okay, again, this is an example. In real world scenario, you're not going to like call it one by one and assign it as it is the case now. Okay, this is just an example to make you able to like follow and understand how the fork join works. Okay, but in the real world scenario, it will be dynamic. Okay, maybe you will like stock this in array and then map and return an observable at the same time. There are like plenty of solutions, but yeah, so keep in mind that this is like an academic example in order to like explain the concept. Yeah, and now those are the 2 first lines. The third line of code is calling the fork join operator that you can import from the RxJS operators, and I am passing to it an array of observables. Okay, this is the first one, and this is the second one. And the result here, okay, of this fork join is an array of the emitted value of the last emitted value by each observable. Okay, so it's like respectively the last status of the first file and the last status of the second file, as I am returning a file status in my observable every time. Okay, so this is how it works, and this is what it returns. And again, so this is the success callback. In my case, as I said, it's an example, so I am just logging files uploaded successfully, and that's it. If you have like a special treatment to do, you can do it in the success callback. Well, this is fine. So far, so good. We use the fork join, but in this case, we dealt only with the happy case. Okay, there's no errors, there's nothing wrong, no exceptions at all. Okay, everything works fine, and we returned the success callback and we processed it. But in a real world scenario, this is not like, it's not always happy cases. There's not always happy cases. Here, maybe the upload file throws an error. Okay. And this is very common. So what will happen? And this is the third thing you need to know about the fork join. We said that it emits only one time. It respects the order. It emits, of course, the last value of every observable. And the third thing is that when an error happens, it will not emit at all. The stream will be completed, okay? And you will not be able to receive values anymore starting from that point. So you will see nothing emitted there because an error happens, okay? And this is not the desired like behavior in a real world scenario. Again, if we take the upload as an example and we carry on with an example on the upload scenario, which is an example of bulk operations among others, of course. Well, in the upload, for example, the user needs to know what's the error, okay? For example, am I uploading a file that exceeded a limit? I need to know, and you need to handle this in the interface. To handle this error, you need to like display an error message saying that you exceeded the size or the normal size fixed, or the uploaded format is not allowed. Okay, you are not allowed to upload that kind of format. I don't know, there are many like errors related to the upload. Okay, so I need to know it. I need to process the errors and display it to the user. Okay, so what can we do in this case? In this case, we can use the catch error operator, okay, which is like the secret ingredient in every recipes I'm going to show you throughout this presentation. And yeah, so the catch error operator, well, we have to every like observable, in every past observable, we need to pipe it and use the catch error operator and handle the error. Okay, and here I am not handling the error, I'm just returning an observable of this error, kind of telling the stream like, yeah, you need to be alive. Okay, I will just pass to you this stream, this new observable, and carry on your work. Okay, just to enable the fork join to carry on listening to the streams, to the past streams. So here, if we do this, the fork join will emit something currently. Okay, so it will not like complete and nothing will get emitted. So here, all that you have to do is catching the error inside the past observable itself and handle the errors. Okay, so here again, I am just returning an observable of error, but which will contain, like, the error can contain the file status every time, and then I can, like, test on the file status in order to differentiate between the success case and the error case. Okay, so you need, when like wrapping the errors, here I am just wrapping the errors and catching it and wrapping it in another observable. So you need to detail this wrap, okay, in order to, like, make a difference later on between this result and the other kind of result. So here, yeah, so here how I dealt with the error case, and now let's move to the to another case, which is like dealing with side effects with fork join. Okay, so let's suppose that we want to calculate the progress of the files to be uploaded. Okay, so yeah, I want to display to the user the percentage of progress. Yeah, and how can we do this? Okay, the fork join only emit one time. Okay, but I need at some point to intercept the completion of each observable in order to do some treatment. This is the idea. So in order to intercept, like, the completion of each observable, you can use the finalize operator that will get called when the observable completed. And at this point, I can introduce any kind of side effect I want to do. In my case, I want to calculate the progress. And for here, I am using, like, a custom function to track the progress. And yeah, that's all. Okay, so and this, like, this percentage, I will subscribe to this percentage and displaying it to the user in a suitable loading component or any equivalent. But yeah, but the idea is, like, you want to intercept the completion of each observable and do some treatment. Okay, and again, this works alongside with fork join. Okay, you can then call the fork join and pass the observables that you did, like, some manipulations on the stream to handle the errors and to intercept the completions. And, like, with all those details, we dealt with the basic requirement of the bulk operations, which is dealing with the success case, okay, just one time, and dealing and handling errors, second like requirement. The third one is introducing some side effects when the completion of each observable arrives, or when each observable completes simply. Yeah, so those are, like, the requirements, and this is how I dealt with bulk operations in a reactive way in my Angular application. Let's move now to the second recipe, which is caching. Okay, how you can cache HTTP requests. And let's see what's the requirement in this case. So we have many components. Those are my components in the left side. And I have an Angular service, which is my recipe service. And here, my observable of recipes that hold the list of recipes of my application. Okay, so this recipes dollar is an observable, as I said, of recipes, and I collect those recipes from my back end. Okay, I am calling an HTTP, I am performing an HTTP request in order to invoke a RESTful resource, okay, to get those data as JSON. So yeah, this is, like, exactly the case, and I am subscribing to this observable in many components, more than one component. Okay, I am using the service, I am injecting it in my components and subscribing, like, to the recipes dollar every time. So what will happen in this case is that you will see like double calls in your network, double calls every time there is a new subscription. Okay. And we need to optimize this. So what we will need is the share replay operator and the catch error operator. And here, let's see what is going on at the level of this service. Here is my service, head here recipes service. And I have the recipes $, in which I am collecting the recipes as a stream. So as I told you, here the get my get function, and I am just processing the error, and that's it. Okay, and I want like to shed some light about this like pattern in Angular, because when you provide your observable publicly in your service, you can like benefit from the power of streams. You can combine them. You can do many manipulations in the streams. You can, after that, like avoid the ng on init lifecycle loop every time you have to call your service in the ng on init, and this will cause some performance troubles and like some user experience issues if you like open one component and navigate from one component to another in routing, etc. So like this pattern, if you don't use a method that retrieves the recipes every time you like externalize it in one variable publicly to all the external world, to all the external components, then you can benefit like from like the power of streams. And yeah, so this is like a recommended pattern I want to shed light on. And here, in order to share all this, to share this observable with all the subscribers, you need to call the share replay operator in your stream. And the share replay operator falls under the category of multicasting operators. Okay, and here for those who like are not familiar with this word multicasting, multicast is the opposite of unit cast. And when we say unit cast, we mean that every subscriber to the unit casted observable will have its like separate execution. Okay, it's only like unit casted to that subscriber. When we call the multicast when we say multicast operator, the subscription or the data can be shared along all the subscribers, with all the subscribers. The data emitted by the observable can shared between all the subscribers, while with unit cast it's like the opposite. Okay, every subscriber maintains his like separate execution for this observable. So it has its own reference of data, and yeah, and we need like multicasting operators are very useful in those like kind of situations when you want to share this observable with all the subscribers without having like to for example, with HTTP calls, call the same HTTP over and over again every time for all the subscribers. Sometimes also there are some you have some side effects in your subscription, and you have heavy computation, and you are doing some kind of treatments that's expensive, okay, for you. Then you don't want this to get repeated every time a new subscriber arrives. Okay, so you have to like cache it in a way that all the subscribers can use it. Okay, and here is the power of the share replay operator. And yeah, and in this case you can like share this image or the observable with all the subscribers, and you can optimize like your code and the execution and your runtime performance. Yeah, so now let's move to the third recipe, which is combining streams. Okay, so as we said, it's like highly advisable to externalize the streams like publicly and to make them available for the external world and for the components, etc. And yeah, for the reason that we want to do some manipulation. One of those reasons is doing manipulations on the stream. So combining streams is one of those use cases. Okay, and it's like a real world analogy is like data joining in SQL for those familiar with for SQL, and yeah, you want like simply to join the data from different tables in order to execute one query and to deliver a result. It's the same thing. Okay, you have many streams, you want to combine them in order to give the result later in any kind of like display. And here, what we need is three ingredients: combine latest, catch error, and array destructuring technique. And let's start with the combine latest, which falls under the category also of combination operators. Okay. Earlier we saw the fork join, which is like available in the same family of operators. Combine latest has a different behavior, okay, and I will explain it right now. It takes as a parameter a list of observables, okay, in order to combine them, and every time the combine latest, every time one of the observable emit one value, the combine latest will emit in its turn this value, okay, and it will check for the other observable's last emitted value. Okay, let me explain in this marking diagram. So here at this point, the first observable emitted A, the A value, and the second one emitted 1 value. So here we have a 1. Now, at this point, the first observable emitted B. Okay, so the combined latest should emit in its turn. But before emitting, it will like check the other observables' last values. Okay, so here the last emitted value by this, the second observable is 1, so it will emit B2. At this point, there's a new value emitted from the second observable this time. So this should be emitted, okay, to the subscribers of combined latest. Okay, hello, there is a new value, there is an update, there's an update, you should be aware of this update. So the combined latest will not only return 2, but it will check the other observables latest value. Okay, so here the last value of the other observable is B, so it will return B2, and so on and so forth. So every time you have the last emitted value by each of the past observables as a parameter. So a real world example is like my recipes application again. I have an observable containing the recipes dollar containing the recipes, which is called recipes dollar, and I have another observable named reviews dollar, which is containing the reviews of the recipes. Okay, and I want like to combine every time the last recipes with the last reviews, okay, in order to get again every time the updated reviews on each recipe, okay, and this is the point, okay. The recipes and the reviews are like stored in different data structures, and I want like to do but there is a relation between them, so I want to display like this indication to the user, the review of the last reviews of each recipe. Okay, so I will use the combine latest in order to like get the last emitted values of each stream. And here you will have like the object, the array of recipes and reviews, and you can use as you can see here, the array destructuring technique from ES6 in order to extract the result as an object. And here I can do something after both recipes, dollar, and reviews have emitted something, okay, have emitted the value. Okay, I can like do my treatment and do whatever I want in order to process this. Okay, and this is like very useful in this kind of situation when you have many, like when your data is like every time externalized in streams and there is relation between your streams and you need to get updated about the last value of each. So think about the combined latest, maybe it's a candidate in your situation. Now let's move to the fourth recipe, which is avoid memory leaks. Okay, and here it's an important subject, how to manage the unsubscriptions. Okay, so it's very like fun dealing with streams. It's very useful. You have like clean code and a reactive patterns every time implemented, etc. But don't forget to manage the unsubscriptions of your or to your observables every time. Okay, so here because it's a cost and it will harm your performance at runtime. So what we need in order to do this, I have some ingredients: the async pipe, take until, first, take last, and first, and I will explain those ingredients or how to use those ingredients in our recipe. So here, first thing you can do is let Angular manage the subscription for you. Again, I have like an Angular application and I am dealing with observables, so I can like let Angular manage the subscription for me using the famous async pipe operator. Okay, I think that you may all be familiar with the async pipe if you are using Angular. If not, so this pipe, like, first of all, do the subscription for you. You can use it in your template, of course. It like manage the subscription for you, and best of all, manage the unsubscription for you. Okay, so it will here unsubscribes from your observable when the component is destroyed. And again, you can use it in your template, and you have like your observable in your component. And yeah, you don't have to care about the subscription and the unsubscription because it will automatically handled by the async pipe. So this is like very cool, and it will manage the unsubscription for you. But in some cases, you can do this. You don't have the logic inside your templates, but inside your components instead. So in this case, like, you can let RxJS manage the subscription or the unsubscription for you here. And there are some operators that like manage automatically the unsubscription. For instance, take while, take last, first. Let's take the example of take, for example. So here I have the interval 100, and this will emit one value for me every 1 second. And I'm not like interested in all the values. I am only interested in a specific number of values, 5 values, 6 values, whatever. Okay, so you can just use the take operator, pass the values, that the number of values that you are interested in, and this will like complete. As you can see here, I am login completed in the finalize operator, okay, to track the completion of this observable. So it will complete right after delivering or emitting the requested values for you, which are 5 values. Yeah, so this is one of the operators that you can use. There is take while also that you can use in order to take the subscription until another observable like continues to be alive, or yeah, continues to be alive, that's it. And take class is the opposite, and first it takes the first value and then unsubscribe. So those are there are some kind of operators that you can use inside your logic when you're working with RxJS observables. Yeah, so bear in mind that there are some kind of operators that manage this directly for you. So if you can use them, then go for it, because like it's very useful in this kind of situation. You can look further. There are many libraries like RxAngular, Until Destroy, in which like you can let this part of unsubscription and all this stuff get managed in those libraries. So you can use it by implementing state, and which is the reactive component state management of the RxAngular, or use the Until Destroy for to unsubscribe directly from Angular components and all the stuff. Yeah, so there are 2 libraries you can check out. And you can do it yourself, okay, by like every time when you have an observable and you subscribe to this observable directly in this code, you can use the take until operator to take this subscription on until the past observable as a parameter like completed. And this, you can like, now you have more control on this observable path as parameter. You can decide when to complete it. In my case here, it's a subject, okay, and I am using this subject to benefit from the multicast behavior, to just multicast values to this subject. And in the ng on destroy here, in my case, I am using like the regular example. It's very recurrent. It's a very recurrent pattern, and I am like sending a value to in the ng on destroy, and then completing. And complete here is optional, okay. But yeah, I just wanted to highlight how this works. So yeah, so you can do this and you can handle the unsubscription yourself. There are many ways, but just keep in mind that every time you are dealing with observable, especially in your Angular components, consider unsubscribing and managing the unsubscription to avoid memory leaks. Well, so here also there's an example of like merging streams. And then if you have like this kind of operation, which is merging streams or combining streams and all this stuff, you can subscribe on the result, okay? You can like unsubscribe to the result of merge, and this will, like RxJS will handle the unsubscription for you of each past observable, okay? So this will make your code cleaner and more readable. So keep in mind this feature also. Now let's move to the following recipe, which is sharing data, and sharing data between components. And what we need here is the behavior subject, Angular servers, an observable, and the update function. So let's go and see the requirements. So here, as you can see, I have many components, C1, C2, C3, C4, and I have some kind of data that's shared between my components. Okay, so here, and this data is consumed by some components and updated by others, or maybe consumed and updated by the same components, okay? So this data is shared. So how can we deal with this in a reactive way? How we can like share this data somewhere in order to like make every component consume and update this data without like with a little bit of optimization, okay? So here let me just highlight something before I carry on. In this case, maybe your application is subject to state management, and you have like to introduce state and to introduce the Redux pattern. For Angular, for example, you can use the NGRX implementation. There are others implementations, but yeah, maybe your application in this case is subject to state management if you have more than one shared data and you need to like manage the state of your of all your application in one single source of truth. So yeah, in this case, your application is subject to state management. So consider introducing an implementation of Redux in your application. But sometimes you have like you have a small application. It's not like subject to states, but yeah, there is like one or two kinds of data that you need to share between your components in order to optimize and to enhance the user experience, to make your components react instantly to some changes together. Yeah, so in this case, so this is the case I am talking about. And in this case, the behavior subject is your hero. So here you can like the behavior subject is a special kind of subject. Subjects are observable and observers at the same time. Okay, so you can subscribe to in order to get values, and you can also broadcast or multicast values to all your subscribers at the same time. So yeah, they are multicast. And for plain subjects, regular subjects, you will only get data after your subscription. Okay, so before the subscription, you will not get the emitted data by the subject. Okay, so this is the restriction. For the behavior subject, there is a little bit of difference. The behavior subject will emit for you the last, every time the last emitted value. Even if you subscribe late, again, you will be able to get the last value emitted before you subscribe. Okay, so this is the difference number one. The difference number two is that it accepts a default value, and yeah, so you can just put your default value according to the type you are going to handle. Okay, if you're interested in like all the previous values sent or emitted before your subscription, then the replace subject is a candidate for you. But here, let's say that we are only interested in the last version because yeah, it's, don't forget that you want to share that data and you only need the last value of this data. I don't care for the others. Okay, so only the last updated value. This is the last image for me that I want to display or to use for any other treatment. So here what you can do is using the behavior subject in your service and extracting the observable from this behavior subject. As we said, it's an observable and observable at the same time. And in the update recipe here, I have like a method which is update recipe, and this method will always send the most recent value of recipe, of the recipe title, to my subject. Okay, so the idea is like having a behavior subject that will hold also or will emit the last updated updated value for you. You send to this subject the last updated value, the most recent version of the value, and you expose to the external world the observable. Okay, so that other components, Angular components, can subscribe to it. Okay, so here in my case, I am like just here triggering the on-click event in order to call the update service, which will send the most recent data to the behavior subject, and then like when I subscribe to this observable, I will be able to get the most recent value of my recipe. Okay, as simple as that. Like behavior subject, update the value to the behavior subject using the next method. You can like choose in when to update it. In my case, here after the on-click event, and then subscribe to the observable, and you will get automatically the last emitted value or the most recent version of this value. Well, let's move to the following recipe, which is real-time using WebSockets, how to consume real-time data. Again, here we have as ingredients the WebSocket subject and an Angular service. And here, RxJS ships with an interesting kind of subject, which is the WebSocket subject that can consume real-time data coming from WebSockets. And in order to use it, you have to import the factory function available in the RxJS package, which is the WebSocket function. Pass to it your URL endpoint, the WS endpoint, and you can use those properties in order to introduce some customization to the events. Okay, you have to you want to introduce specific behavior in specific moments of the socket lifecycle, like the opening of the connection, the closure, etc. So you have a special kind of object in which you can perform some optimization or customization to be more accurate. And yeah, so this is in a nutshell. If you are interested in this topic, I have in my GitHub repository two projects, NG Real-Time and NG Real-Time Dashboard. One version with NGRX, one version without. You can check it out. I talked about this subject in many talks, and I have many resources and articles in the net about the subject. So if you are interested in it, you can check this out. And the last recipe is to stay healthy, stay up to date, and upgrade to RxJS 7. And there are a lot of amazing features introduced in the last version of RxJS. Lesh will tell you about in the RxJS what's new in RxJS 7. And yeah, so just try to check out the version and start playing around it. Yeah, and that's it. So thank you very much for having me. That's all I have to tell you today. Stay safe, and if you have any question or any feedback, don't hesitate to ping me on Twitter. My DM is always open, and I answer also on LinkedIn, my mail, and I have some articles on Medium, and you can check out my GitHub repository for to get inspired about some projects. That's it. Thank you very much, and stay safe.
Great, that's a wonderful talk from Younes. So thanks for that. So we next have Jan-Niklas, who is a member of the RxJS core team, and I'm just gonna we're a little bit ahead of time, but let me. We're just about right. So let me just add his talk to the stream.
Testing observables. I came up with the idea for this talk just because also in real life project, I stumbled across the fact that testing RxJS is pretty hard and often very intimidating. It feels really like having a big hurdle that you somehow need to overcome, but it's quite challenging to get in the right mindset. What I want for this talk to show you is how to write maintainable tests in a very effective manner. And on top of that, I also want to show you how to do that without marble diagrams. But my opinion on marble diagrams and much more about that later on. Before we dive deep into that, my name is Jan-Niklas Wortmann. I'm a consultant for Evora IT. I'm a member of the RxJS core team and also an Angular GDE. So let's get right into it before we lose some time. Here we have a very easy example for some RxJS code, right? We're using the creation operator of to create an observable that synchronously emits some value, in our case, a Boolean value that is passed to that very function. How would a test for that look like? How would a marble diagram, first of all, look like? Exactly like that. So we have the of operator, and it creates an emission of true that emits synchronously and then completes. The test for that looks quite simple. We are subscribing to the observable, and then we are expecting a certain value to be emitted. So far, so good. Seems to work. Our test is passing. Everything's fine. What I like to do in situations like that is actually to also do the negative test to see that my test is properly working. So for that, we're just replacing our expectation with false here. And now what we would assume is that the test is failing, right? Well, apparently not. And this is when things start to get a little bit crazy with RxJS and testing. So how can that be? The thing with expectations in testing is that if you have an unmatched expectation, it throws an error. And if you have an unhandled error inside an RxJS subscription, it will be thrown on a separate call stack, meaning it is asynchronously thrown. Difficult word. Therefore, what we can do to overcome this hurdle is passing a done callback to the test function. And by calling this test function, we are manually saying when this test is done. And as we now see, when we're having the same pattern as before, but after our expectation of the done method, we are now getting the falsy test, which proves that our test used to work before. If we now replace it back with true, everything's fine and we're good to go. Long story short, use the done callback in any situation when you're testing RxJS. It just makes your test a lot more resilient, and you can guarantee that it's working as you expect. And on top of that, this done callback is supported by a lot of testing frameworks. So you should be pretty good with that testing approach. I can now hear some of you saying like, okay, testing off is quite easy, right? Testing off is quite easy. So what if my observable has multiple emissions, like interval, for example? Interval emits after every X seconds or milliseconds. So how would I test something like that that emits multiple values over a period of time? Well, let's take a look at that. And for demonstration purposes, we're using from with an array, which will then spreads the array synchronously, but spreads it. So in this scenario, we have an observable that emits first 0, 1, 2, and then 3 consecutively. How would a test for that look like? What I like to do in situations like that is creating an array where we store the values, and in the subscribe block, we push the values to our received values, and afterwards we have an expectation. You might have noticed now something that after the subscribe, have the expect block. This just works because from is emitting synchronously. So how would that look in an asynchronous example? How can we handle that? In an asynchronous example like interval, for example, what I would do there is basically applying the same mechanism. So having subscribed to the next channel and pushing the values in the array, but in the complete callback, when we know, okay, all the value emissions are done now, we are doing our expectations and then afterwards call done. Problem with that is that this logic to work properly assumes that a complete signal has happened. And interval, for example, does not complete by default. So how would you handle situations like that where you have an observable that does not complete? My personal recommendation here is use a completion operator. I agree with that. It's not ideal to use another operator for your testing purposes, but it will make your life a lot easier and you focus on the necessary parts for your test. And on the other hand, when we're talking about unit testing, you can assume that the library you're using, RxJS in that scenario, should work as expected. Therefore, you technically can leverage operators from that. This is, from my perspective, a little bit of a gray area, but this is the way I deal with that problem. So I would usually use a completion operator like take until, first, something like that to just mark your observable as completed, and then you can apply the same pattern as shown before. Sorry for that. One thing I want to recommend here is that you check out Observer Spy. It's an amazing library created by Shai Resniak, and it's basically wrapping this pattern and making it a little bit more accessible for you. And it's also tracking errors and complete signal and stuff like that, and makes it a little bit easier to use. So if you're familiar with the basic pattern, check this definitely out. It's a great library. Even though this is a remote talk, I can exactly hear people now saying like, okay, all those patterns were nice and easy, but in real world, that's not that easy, right? Talks are great for showing easy things in an approachable manner, but this is not real world. Fair. I give you that point. So let's talk about a real world example. And this is slightly adapted, but extracted from a code base I'm working on. So what we're having here is an observable that takes care of an authentication mechanism. In our situation, it's opening a pop-up, and we actually had a lot of brittleness there, which means that it sometimes failed and sometimes not for whatever reason. So what we implemented is a retry mechanism where we said like, okay, retry at maximum 2 times for certain errors, and everything else ignore or go ahead, depending on that. On top of that, we're also using share replay to prevent concurrency. So if we would have multiple subscribers to that while a login process is going on, we would have concurrency issues. With share replay, we can mitigate that. How would this authenticate method then look that is used here? So for testing purposes, I mocked this a little bit with having a raise operator and from event, where I'm saying like, okay, when I'm getting a login event, I just map this to true. When I get an error event, I map this to a certain error. So this way I can simulate my API for the purpose of this talk. And the public API for this observable to be accessible, as this was wrapped in a library, I wrapped this in a method just to make it a little bit more accessible. It can also easier restrict it or extend it later on. So what I want to tell you is, even though this example was a lot more complicated already, the test for that looks exactly like the stuff I showed you before. So what do we have here? We create an instance of our authentication class. We're subscribing to the login with pop-up method and doing our expectation with the done callback. The only thing we have to consider here is that we have to dispatch the event to trigger our observable after we subscribe to that. As we are having a cold observable here, this is the only thing you have to keep in mind working with observables and testing. First subscribe, then act, if we're talking about AAA tests, for example. We can even test the negative scenario here, meaning, okay, we're expecting an error. And for that to work, I had to dispatch the error twice, because then with the retry, when first after 2 errors, the error was passed through to the subscriber. Therefore, I'm dispatching the error event twice, and then I'm expecting an error to be emitted on my observable. Works exactly the same. Subscribe to it, done callback, and you're done. So testing seems to work fine. What about mocking? An integral part of testing is also mocking, as you might not necessarily want to test your observable, but it's interacting with your unit that you're testing. So for mocking, I personally always apply a 6-step mocking strategy. So what we have first is, in any situation when I want to mock something, I start with the never constant provided by RxJS. The never constant is an observable that neither emits something nor completes. Having that said, it does not trigger anything in your code. So if you're using never, none of the code that is dependent on this observable will be executed. But on the other hand, you don't run into a problem where you're saying like, okay, something is not initialized, cannot call pipe of undefined, stuff like that is mitigated by just using an empty observable, to call it like that. So this is the first step. If I just want my code to run, but I don't care about the observable. Next step is using off with a single object. With using off, I have a synchronous observable that emits some constant value. Having something like that in place helps me creating expectations and stuff like that. So this is like the most common, most basic usage, how you can mark an observable of an static value. If I want my observable to be asynchronous, I personally apply a pattern where I call off and then delay. Technically, you can also, in this example, I use delay with 1 second. Technically, you can also just use 0. It will also be asynchronous. That's not the point here. The point is the combination of off, or the off operator, with delay makes your single expected value asynchronously emitted to see if your observables and your code works in an asynchronous manner too. After that, when we now have single values and asynchronous value, now we come to synchronous multiple values. What I use for that is from. From with an array will be spreaded, so we will have 3 emissions, an example here, where we would have like first 1 and then 2 and then 3 emitted. The same goes for asynchronous, but what I personally rather do there is using interval. It creates a tick every X second. We already saw the marble diagram. That's usually how I deal with situations like that. You might also want to apply something like map to create it or to map it to a certain object, something like that. But the basic part is creating the observable according to your needs or to your test scenario, whether you want to test multiple, single values, asynchronous values, etc. And we now have 5 steps already. And the last step is, and what I usually do when I want the full flexibility of the code out for my mock object, is I use a subject. And then within my test, I can define the behavior that I want for this observable at what time. And then you can decide whether it emits asynchronous, synchronous, however you want it to work. And technically, you can even leverage the different subject types for that, also depending on the code you're using. But this is a 6-step marking strategy. Start with never, use off with delay, from interval, and then the subject. And those are the patterns that I apply on a daily basis when I work as a consultant. And I didn't have a situation where I couldn't apply one of those strategies. So having that said, we now have testing and marking already covered quite well. We're making good progress here. So let's talk about marble testing. A talk about RxJS testing wouldn't be complete without having talked about marble testing. So marble test is a visual way for us to represent the behavior of an observable. And marble diagrams itself are amazing, right? They're on the docs. Every blog post that is about RxJS usually leverages marble diagrams to some extent. And therefore, the idea a couple of years came up, like, why don't we use marble diagrams for testing purposes? And in our situation, we're actually talking about ASCII marble diagrams. And I'm not talking about this level of ASCII art, but more like how to represent a marble diagram as an ASCII art. So for this, you have to learn a little bit of a new syntax. So let me guide you through this real quick. So you have the normal dash, which represents 1 virtual milliseconds. Virtual means that this is scheduled virtually. You can also combine this with values and milliseconds, seconds, minutes, and stuff like that to make it a little bit more flexible if you have an observable that takes ages. You also have the situation like from, for example, emits all the values synchronously, so you want to group certain values. And you can do this with parentheses. In the ASCII art, you use A, B, C, D to represent value emissions. So you can use any alphanumeric character to represent a certain value, and how this works later on, we will see an example. The hashtag, or however you want to call it,
Hi, Jen. You're muted, by the way.
Okay. Right. Can you hear me now?
I can hear you now. Great. The irony of that talk is that I actually used to write my tests that way, and then it was Jan-Niklas that showed me how to do marble diagrams. It's now going the other way, which is interesting to see. Hi, Jen. You're muted, by the way.
Okay, so can you hear me now, Tane?
I can.
Perfect. All right, let me just...
Right, can you hear me now? I can hear you now. Great.
Seems to be a delay. Hang on a second. Okay. Right, so let me actually pull up your slides. Let me just see. Want to make sure I'm not pulling up Joseph's slides, who is already here as well, which is good. Okay, this is your own slides. It's perfect. How have you been? Interesting. Thank you. I seem to be hearing Tane for some reason. It's your own slides. It's perfect. How have you been?
Oh, can you hear me now? Sorry about that. I had myself on mute. I have been good, thank you. I've been getting everything ready for today. Hopefully we won't get any echo here. I was just getting some echo there, so I've put some headphones on. So hopefully everything goes fine.
Yeah, we both seem to be having problems with the tech at the moment, but that happens in every conference.
It absolutely does. I've seen very professional conferences go very wrong very quickly with technical problems, and this year, so I think everyone's
and also, as our audience can understand, it's early here, in Europe. I'm in London. It's 7 a.m. Yours is a bit better. It's
I'm based near Amsterdam, so I'm 8 a.m. Yeah.
Yeah. Okay, but that's fine. So let me add your slide back again. There you go. All right, I'm not gonna take too much, away from your account, your slot. So let me remove myself from the stream, and I'll be back after you talk. And good luck on your talk.
That's great, Jen. Thank you very much. Hi, everybody. Good afternoon, where you are. Good morning from Amsterdam. I'm here to talk to you today about publishing your own RxJS library and why you would want to do that. So first of all, I'm Tane Piper. I'm a creative technologist and open source maintainer, originally from Scotland, based in Amsterdam now. I've been a 20+ year full stack developer. I'm an active open source maintainer. I have several libraries on my GitHub, and I also contribute to other libraries. And I also do quite a bit of technical writing on my blog, and here today speaking to you. The related kind of open source libraries that you might be interested in, I maintain RxJS Ninja. It actually contains multiple libraries, which are operators and observables for RxJS. And these are mostly for dealing with your data, whereas RxJS operators are quite low level. These are slightly more higher level and allow you to do things with your strings, your numbers, booleans. There's also observables for random values, and there's a few utility operators in there as well. There was going to be some changes, but with RxJS 7 coming out, I held off on those changes. And for example, RxJS now supports readable streams, which was one of the operators that I provided. I also built a library called Formula. It's a reactive forms library for Svelte, and it comes from doing RxJS Ninja and learned a lot about reactivity. And I built this library. It does use Svelte stores to build the reactivity, but in reality, other than the stores, there's nothing really specific to Svelte. So it could even be easily replaced with subjects. So why would you want to publish your own RxJS library when there's already a lot of operators included with RxJS? Well, for one, you can reduce complexity in your code. For example, if you have a complex business logic, like a data transformation, or an application of something like a tax value, or something that's complicated, because operators are just functions, you can encapsulate this into your operator, and you can include that in your library. You can also reduce duplicate code. This is one of the reasons why I built RxJS Ninja. I found myself writing a lot of map or filter functions, especially when dealing with strings or numbers. So here I wrote my own operator library to be able to reduce the amount of time that I would rewrite that code. And also it allows you to create contracts, because most of the time you might be working in TypeScript. You can also easily create observables and operators that are specific to either a data source, like an API, or something like a data emitter, like a readable or writable stream. So today we'll cover what is a custom operator and what is a custom observable. We will touch slightly on marble testing, and also things like documentation and what it takes to get a repository and pipeline in place to publish your library. I do have a starter library here. If you go here, you see that it includes a very basic RxJS library. It has a fizzbuzz operator and a fizzbuzz observable, which isn't very useful, but it kind of shows the basics of how you build a library. The library starter also includes all the bash scripts and YAML files that you would need to get started on GitHub with GitHub Actions to publish your library. And this works for any TypeScript library, so it doesn't just have to be RxJS. If you have your own TypeScript library you want to deploy, the starter library can provide you the template to do that. So what is an operator? An operator, like the word computer, actually comes from originally a human task in the late 19th and early 20th century with telephone technology. An operator was a person who connected the call from one person to another. You may see this in older movies where somebody calls up and the operator is asked to connect to somebody in a local area. So extrapolating that into RxJS, what is an RxJS operator? Well, they are, first of all, higher order functions. What this means is the function that you import itself returns a function. The return value of that function should always be an observable value. And in fact, it should always return the source value that you get from the previous observable value. You should not use operators to create new observable values. So a basic structure of what an operator looks like is this. So here you can see we export a function. The return of that function is an anonymous function that receives a source. And here we pipe the source to other operators. Operators are also chainable, and this is what makes them very powerful. They run in order, and that allows you to do things like modify values, filter, and even query your observable values. Operators can be used to do both synchronous and asynchronous actions. And of course, operators can also be introduce things like side effects. So for example, if you use the tap operator or even the catch error, you can use that to do side effects within your system that are not related to the remaining stream that you're working on. I like to think of combining operators as what I call kind of useful Rube Goldberg devices. If you don't know what a Rube Goldberg device or machine is, it's a silly machine that takes an input and there's an output at the other end. The things that have to happen between the input and output can be synchronous, can be asynchronous, and they might require a certain length of time, or they might be instantaneous. And in this example here we see there's lots of things that for the user to get the napkin to their face, they have to pull the spoon, and then that triggers a lot of actions around it. So that's how I like to think of how operators work. There's two types of operators mainly. There's the monotype operator, which only works with a single type. A basic example of that here is from my own library, the reverse function. As you can see here, we export function reverse which returns a monotype operator function, and the type here will be string. And here you can see what we do is we receive a string value as an observable. We're going to pipe that. In this case, what I'm doing is I'm destructuring it into an array, reversing the array, and rejoining it. So what you get here is a string. And I just have a very basic example to show here. So here is that example. Here you can see in the console, we take the from here, and it's hello RxJS Asia. We're going to pipe it into our reverse, and then we tap it. We have the value here. And just to show you with the monotype operator, if I change to number, you'll see that TypeScript does not like this. So this is a very nice way for you to be able to enforce the types in your system. Just to also show you here that within your operator, you cannot obviously do any type of operation. So here, for example, our monotype operator is a number. Here, when we parse this value, the toFixed on a number actually returns a string. So just to show you this, if I comment this out and try to return the string, again, the monotype operator does not allow you to do that. So it is doing the enforcement here of our type. And finally, just to show you that it's not just synchronous operations, here I've created a very quick example using a public API. So this is an operator that takes a string and returns a string. But inside the operation here, we're going to fetch from an API. We switch map that to a JSON. And then here we're going to map that back to a string. So here in our console, you can see here that we have got the response. And just to show here as well, there's the other previous values here where we have the number from the operator above. The other one is the operator function. This is where really your operator can work with any type of value. So in this case, here's the toHex function. Here we have an operator function that takes a number and is actually going to return a string in this case. So here we pipe our number to string method. We're passing a radix of 16, and this allows us to convert the value to a hex. And again, just very quick example to show this here. If I comment this code here. Here you can see we're going to take these three numbers here. We're going to pipe them to hex. And here we have our string value. Another quick example here is just to show the what you can also do with an operator function is you can actually support multiple types in your operator. So here we have one which can be either a string or a number, but it will always return a number. In here, our logic is a little bit more complicated because we first have to convert our string to number. Then we can do our toFixed and parse that again back to a number. But here we can see that both number and string are converted here to a number format. And of course, there's observables themselves. You can create custom observables from any data source. There's two types of observable. There's the code observable. This is where your data producer is invoked every time there's a new subscription. So every time somebody calls your observable and calls the subscribe method, in this case, we'll always create a new data source. An example from RxJS would be something like the timer. That would always start from 0 in this case. This also means it's a unique instance of the producer. And it does mean that your observable should handle the cleanup of both the emitter and the subscription. So here, just to show you, we have our observable, which returns a subscriber. We create our emitter. And anytime the emit emits a value, we will emit it to our subscriber. Anytime there's an error from our emitter, we're going to pass the error to our subscriber. And on end of the emitter, we're going to complete our subscription. And here in our return function for the observable, which is our teardown logic, we're going to call our emitter end, which will trigger this this subscription complete here. We also have the hot observable. Hot observables are where your data producer lives outside of the instance of your observable value. So for example, if you have a WebSocket connection or some other readable stream. In this case here, we're passing it in as a property to our data source here, but it could well be a global or a singleton that lives elsewhere within your code. There's no guarantee that the producer will be a unique instance in this case. If you call this function several times and pass the same emitter, then it'll always be the same instance, regardless of the subscription that happens later. And in this case, the observable is not expected to close the data producer. So because you're not creating that instance yourself, in this case, we can just complete our subscriber without having to worry about closing our emitter. That logic should happen elsewhere. Some use cases for custom observables: interop between data sources that emit over time. A very good example is the readable stream, for example, or WebSockets, or even custom APIs that you may have that, for example, hardware or other software that you want to turn into a way to work with that in RxJS. It can also be for emitters that follow specific rules. For example, in RxJS Ninja, there's a relatively useless operator, but observable, but it's from Fibonacci, and it only emits Fibonacci numbers starting from 0. It could also be that your observable requires some custom configuration. In the case of from random int, which is in the random package in RxJS Ninja, it only emits a value between a minimum and a maximum. So for example, if you can set the minimum to 0 or 1, or you can set it to from 50 to 100. This allows you to customize the observable that you get. And here, I do apologize, I didn't open this example here. This is, it's a bit more of a complicated example, but obviously you can get the link from the slides. And this is where I built an operator, an observable that works with the dark mode and light mode checking in your browser and operating system. So this returns an observable value that you can listen to when the user changes their system settings. So if I go to my system preferences just very quickly, and I go to changing myself to light mode here, you'll see that the observable emits that I've actually changed to light mode, and you can see here already that the operating system has also picked up the change in dark and light mode preferences. When building a RxJS library, it is very good to have testing. And one of the things mentioned in the previous talk as well is you do have marble testing. This allows you to, I think, test your observables and operators correctly. It's designed to allow you to test data over time. So for example, you don't need to use any fake timers or use things like timeouts or intervals within your test code to mock things. The test scheduler that comes with RxJS already allows this to be generated. The tests are a visual representation of the expected input and output, and that means that by looking at a marble diagram, you can see when data should be emitted and when it should be received. And you can also see when things like subscriptions should be created and disconnected from. And you can use both hot and cold observables, as mentioned before, to create your mock data sources for your testing. And the good news is that there's a lot of support for doing marble testing in most runners. Personally, I use Jest, and I'm also using this library here, which is from Nicholas from the RxJS core team. So this is an example of a marble test. So here, this is testing the toUpperCase operator from RxJS Ninja. And in our case here, we have a a stream of data that's coming in, which is going to emit our values here. And in a case, we're just emitting A, B, and C. And what we're also going to do is we're going to check the output of that it has actually uppercased our letters. We can also here check the subscription. As you can see here, the 2 characters as part of this, this is the start of the subscription, and this is the end of the subscription. And the reason you might want to test this is you might have an observable that, or an operator that when you actually run this, you realize that it, for some reason, isn't disconnecting at the end of your test. And I have seen situations like that before. So this just allows you to make sure that whatever you're writing, it will disconnect from the subscription, and that means that you can avoid memory leaks in your application as well. When building a RxJS library, I think one of the most important things is documentation. As you know, RxJS dev has quite a lot of documentation on how to use RxJS, and also has a lot of information for the operators. For me, there's 2 types of documentation. The first is, in some way, probably the most important one, and that is your automated documentation. So this is created from things like your JS doc tags and from other comments, and also, I forgot to mention here, but from your TypeScript as well. Just to show you here, if this is the reverse method here. So as you can see, the reverse method itself is actually really only these lines of code here. And actually, most of this file is actually taken up by this comment here, which is our documentation. But as you can see here, we mark a category. We can put some remarks against this, and we can also provide our example and our returns. And when we do this, what we get back is the ability with tooling to generate automated HTML documentation. You can also generate documentation in PDF or even in Markdown to include in things like GitHub. When you do automated documentation, that tends to be much more easy to deploy when changes are made, because you can have that as part of your build step. Whenever you make a change to your library, you just need to rebuild your documentation based on the changes in code, and that will deploy to wherever you have your code, be it GitHub Pages or an S3 bucket. The great thing is that when using TypeScript, so either using tools like tooling like VS Code or IntelliJ, you actually, if you include the comments in your compiled code, that provides full IntelliSense, and that is the example here at the bottom. This example actually does come from here in StackBlitz, which uses a bit of VS Code underneath. And as you can see here, by hovering over the reverse method, I already got some information about the fact that it is a monotype operator function, and what it does, along with a very basic example. So this here, this tells your users how to use your library and what your contracts are, what your APIs are. There are several tools to generate docs. In my case, I have used TypeDoc to generate the documentation for RxJS Ninja. But there is also TXDoc, and for Angular applications, there's CompoDoc, which builds a much more visual representation of something like your Angular application. The second type of documentation, of course, is manual or descriptive documentation. This does tend to be much more your handwritten documentation, and it does maybe require some tech writing skills. If you want to improve your tech writing skills, it's always great to look at other open source libraries and see if they need help with their documentation. Of course, descriptive docs, they are a lot more difficult to automate. It tends to mean that you require more of a review step. And I would recommend that both when you do have a review step, that both the source file, so maybe like a Markdown or your source code file, is checked, but also have the output checked as well, just to make sure that there's nothing happening within your code that might be breaking something within the documentation. This type of documentation is really good for your README files. So obviously, think this is the screenshot from the RxJS Ninja string library from npm, and here you can see we have the README. We provide links to the website, the documentation, and the changelog. We also have our badge for our version, and we kind of cover some of the simple parts of what the library does. But here I feel that this kind of documentation is great for telling your users why they should use your library. So you can also do things like blog posts. The tools I've mentioned below, things like Dockersaurus, that has a documentation tooling built in, but you can also have a blog section. Hugo is another static site generator, as well as Gitbook. And with both of those, you can generate much more rich documentation than just the automated documentation can provide. So you want to publish your library? Well, you need to think about your repositories and your pipelines for that. Best thing to do with creating a library like this is there's actually tooling already out there to help you make repository management easier. For my choice, I use NX. That allows you to create a mono repo, which allows you to create your libraries for publication. It also allows you to create applications that you can use for things like end-to-end testing, and also for other sites that you might want to build around your library. There is also Lerna as well, as another tool that you can use to create your repository. Choose a repository host for which comes with potentially CI/CD. In the case of the repository, I provided a link to at the beginning. That is for GitHub and GitHub Actions. But of course, you have GitLab with their own pipelines as well. Bitbucket also provides pipelines. Or if you're looking to maybe do something more internal within your organization, you could look at other providers or even Jenkins. I've written several Jenkins pipelines using very similar code to be able to publish libraries internally at an organization. So with all of these tooling here, you can really work to create that repository which can host your code. And also things for end users within your repository. If it is an open source library, it's great to add things like a contribution guide to help people contribute to your library. You may also want to add a code of conduct, and things like making sure your issues are open. You know, if people are using your library and consuming it, sometimes you find that, you know, if you're writing a library especially for yourself, that actually somebody else might come along and have a good suggestion or find a bug. So having your issues open is always something I would recommend. When you set up your repository, I think there's two main things to consider. The first thing is your pull requests. Things like pull requests really automate as much of the pull request process as possible. You can run things like tooling like prettier checks or ESLint to see that the developer themselves has run those for you, or you can automate those as part of your process. And what I would always recommend is in a pull request situation is enforce a changelog. Make sure that your developers update the package changes that have happened, either through a manual changelog, for example, like keep a changelog, which I prefer, or there's also Commitizin, which is more automated, and for example, Angular use that. If you look at Angular or RxJS, even the notes that get generated come from that automated process. But with that, you have to be much more better at your Git commit messages to make sure that the documentation that's generated is accurate. Obviously, you have your merge to main as well. With merging, I would really suggest automating your version bumping and also updating anything in the changelog. For example, in the code in the repo I've provided, you can put the version you want to release, whether it's a major, a minor, or a patch, in the git commit message. And when the process runs, it will automatically bump the version. It then does a production build with the version bump. And then it will attempt to publish that to npm. What I do is I publish the libraries as ESM and UMD modules. The reason for that is, just to show you here in the library, if you publish a UMD version of the library, then you can allow your users to do this. They don't need to npm install your library. They can actually just include your script on the page. And here you can see that by doing this, we have this global variable which contains our operators. And here we can import them into our script modules. Just to quickly cover here, there is some also important information here when using NX. Personally, I use the node library that they have to generate the library, because it allows you to create a publishable library and fix your import path. But there is a configuration here to then use the web plugin for NX and the package task from that. This allows you to use Babel and also the other asset setup here, which allows you to generate the UMD and the ESM modules. If you use this, then it generates common JS modules, and you can't really use those in the browser. So there is a little bit of work with this to get things running, but this is already set up, and even here you can use this as a template from GitHub, so that you can already get started. And obviously set up things like token-based or multi-factor authentication for NPM. You should never be publishing to NPM without some kind of authentication set up on your pipeline. If you do, then you can have risks of things like you've seen before with Bitcoin miners being put into libraries. I mean, with your library, it might be small and single line, so it's a bit harder to do something like that. But it's just always good to have some kind of process set up where even with automation, you still have a step of either doing the multi-factor authentication, or you provide a token that only has the scope for publishing from GitHub, for example. So now that we've done that, it's time to start promoting your library. I mean, get out on Twitter, write blog posts about it, and you can even do something like this, which you can talk at a conference. So thank you very much for attending the talk, and I hope you've enjoyed the talk so far, and enjoy the rest of your day.
Thank you for that, Tane.
Thank you.
Let's see if there are questions, because we've got a bit of time, around 6 minutes. Let me just check if there are any. Are you also looking at the YouTube Live? Are you seeing any?
No, I've only got the StreamYard and my one open. I don't have the YouTube as well.
Yep, I don't see any. So yeah, thanks for that. What we're gonna do is we're gonna go on a coffee break, and we'll be back at I believe it's 2:15. Let me just check. Yeah, we'll be back at 3:15 Singapore time, 3:15 p.m. And we'll have Joseph's talk after the coffee break. So Joseph will be talking about React-RxJS. He's already in the backstage. Oh, sorry, he's already backstage, so he's ready. But yes, so we're gonna go on a break. And thanks, Tane, for being one of our speakers today.
Thank you very much.
I guess you can get back to sleep now.
I'm going to go walk the dog now, actually. Yeah.
Oh, you're here.
Thank you very much. And yeah, enjoy the rest of the conference.
Take care.
Bye-bye.
Okay, so folks, yeah, we're going to go on a coffee break, and we'll see you back at 3:15 Singapore time. Okay, hi everyone. So we're back, and as I said earlier, our next speaker is Josep Sobrepere, and he'll be talking about React-RxJS. So I'm just going to bring him in now. Hi, Josep. How are you? Oh, I can hear you. You're on mute.
Hi, can you hear me now?
Can you hear?
Can you hear me?
Oh yeah, that's better.
Okay.
Now I can hear you. All right. So let me just change something because we still have that banner. Okay, and your slides are ready, right? Okay, perfect. Yeah.
Yes.
How are you today? It's also
I'm good. I'm good.
Really
Very excited to be here.
Where are you joining us from?
From Barcelona.
Barcelona, correct. Yeah. Okay. How's the weather over there? Is it warmer than here?
I think so. It's been rainy these days, but now the sunshine is coming up now, so it's pretty nice.
Yeah, here as well. Yeah. So we'll probably have a good day today. Yesterday was really good as well. Okay, perfect. So let me then pull up your slides so we can get started with your talk. Okay, perfect. That looks good. So I'm gonna let you get started, and I'll come back after your talk.
For sure. Thanks a lot. Thanks a lot, Jen. Well, welcome to my talk. The name of the talk is React-RxJS, bringing reactivity to React. Well, first off, thanks all for having me at RxJS Live. It really is an honor for me to be speaking in this conference. Since the name of this conference is RxJS Live, I guess that I don't have to convince you about the benefits of using observables and RxJS, right? Also, even if this is not a React conference, I'm going to assume that most of you are somewhat familiar with React. For those of you who are not familiar with React, I have to warn you, this talk is going to be a little bit difficult to follow. But there are some parts that you may find interesting anyway, so if you want to stick around, you're very welcome to do so, of course. So for those of you who have experience with React, have you ever wished that you could use RxJS observables for managing the domain state of your applications? Not as a means to aid a deficient state management library like we often do, but as a fully featured tool for managing our domain state? Well, I certainly did. And in this presentation, I'll be explaining why, thanks to React-RxJS, we'll be able to use RxJS as a very powerful state management library. In this talk, I'll be highlighting 3 benefits of using React-RxJS. The first one is that it allows us to derive our state using streams, which, as we will see, it's something that it has a lot of benefits. One of them is that we won't have to worry about triggering undesired React re-renders. The second one is that these bindings fully leverage React suspense, both for data loading and for code splitting, and how thanks to this, we can greatly improve the loading times of our React applications. And the third benefit is that using streams for handling domain state produces code that it's much easier to navigate, therefore making our solutions easier to maintain. Hi, I'm Josep Maria Sobrepere. I'm the creator of React-RxJS, the co-author actually, together with Victor Oliva. I'm a front-end architect at Adaptive Financial Consulting, the company that I work for. I'm the creator of another library that I no longer use, thankfully, called Redux-Reuse, and I make modest contributions to some open source libraries like RxJS, React Redux, React Router, among others. And if you want to follow me on Twitter, my handle is Josep Tech. If you don't want to follow me, that's okay. You won't be missing much. Anyways, let's get started. The first thing that we're going to do is we're going to build a demo application. Okay. The purpose of this is to highlight why, for certain applications, using React as a state management library is less than ideal. And why, for those kinds of applications, React-RxJS could be a powerful tool for improving both the maintainability and the performance of our React applications. I've brought this demo up from Mitchell's Wetstrait's talk, MobX, or going from mutable to immutable to reactive state management. In his talk, Mitchell solves the same problem using different implementations and then compares the trade-off of each solution. And of course, he shows how solving that problem using MobX has a lot of benefits. I highly recommend you watching his talk, and thank you so much, Mitchell, for allowing me to use this demo in my talk, the demo up in my talk. So in here, we're going to be doing something similar. We'll first solve this problem using React. And by the way, our implementation is going to be quite different from his implementation. And then we'll solve the same problem using React-RxJS so that we can compare the trade-off of each option, okay? One thing before we get started with that, that I want to warn you about is that for the purposes of this demo, I've put all the code in one file, which is something that I will never do in a real project. So please be a little bit indulgent and don't judge me for that, okay? Thank you. So yeah, let's have a look at the app that we're going to be building, okay? Let me walk you through, let me check something. Yeah, let me walk you through this demo app so that you understand how it's going to work. So this application has a section with order lines right here, okay? And a section with exchange rates that apply to these order lines right here, right? The user can edit the price and the currency of each order, and when they do so, the base currency price also updates, okay? The only tricky thing about this is that the base currency price, which is this field here, depends on the currency rate, which is defined here, meaning that these updates are going to update these order lines and so on and so forth, okay? Just one small clarification. I'm going to call this column here, this file, I'm going to name it the base currency price to distinguish it from this price. The base currency price because it's the price in the base currency of the user, which in this case happens to be the pound, okay? Then we also have this add button that will add some random orders that then the user can edit. And then finally we have this total here, which is the sum of all these base currency prices. That's it, okay? So let's start coding it. Let me, 1 second. All right. Let's start coding. Let me first explain the starting point. So our awesome product designer has set this up for us. It's a bunch of presentational components without any state. And our work is to bring this to life, okay? So this is our root component right here. And then we have the orders component, which is this one here. And then the currencies component, which is this one here. Let's see them. Let's see them a little bit closer. The orders component, super straightforward, just a table rendering the different order lines for each order. The order line component receives an order and prints it. One thing to notice, though, is that the base currency price, right, it's not a property of the order because it's derived data that needs to be derived from information of the order and information from the rates. So for now, since we don't have any sort of state, it's being hard-coded to 1000. Then we have the currencies, this section here. And it's pretty much the same thing. It's a table with a bunch of currency rates. And this is the currency rate, okay? Then notice that here, I haven't highlighted it, but here we have some utils that we'll be using with the initial orders, the initial currency rates, the formatting function, and these kind of things. All right, let's start coding this. So the first thing that we've noticed is that the currencies are being used in both components, in the orders and in the exchange rates. So they are the perfect candidate to put them in context. By the way, if you cannot follow this part because you're not very familiar with React or you're not familiar on how React hooks work, don't worry too much about it. what it's important is that you understand the thought process that a React developer goes to when using React as a state management library. All right. So we're going to put the currencies in context, and this is how we do it using React, or one way of doing it using React. We create some context for the initial currencies. We can create an idiomatic hook for accessing those currencies that we have in context, right? And then we can create a provider for the currencies that we'll call it currencies provider. Then we can use this hook in the different components that are using these currencies. Let's do that. So we replace these hard-coded values with these hooks. Same deal here. And then in the root component, we put the provider. So now nothing works. Still nothing works, but at least the currencies are coming from context. All right. Cool. Let's make something work. Let's make the exchange rates work. Okay. So something that is important when working with React is that the general recommendation is that we should keep our state as local as possible until we have to lift it. So let's imagine that we are a developer working in a Scrum team, and we pick up this story that says, as a user, I want the exchange rate. I want to be able to update the currency rates of the different currencies, right? There's no reason for us at this point to lift the state, so we're going to keep it local. And if later we have to lift it, we will lift it, right? That's the philosophy of using React as a state management library. So it's super easy to do that. We come to the currency rate component, this one right here. And instead of using this hard-coded value, we bring the use state from React. We pass the initial value, and then React is going to give us the state that will be changing and the state header. We plug the state and the setter, and now all of a sudden, this should be working. Okay, cool, and it is working. Nothing else works, but this works. Also, notice that we're using the React development tools in order to keep track of which components are being re-rendered. So awesome, this is working, and only the components that are being updated are re-rendering. Perfect. Well, let's do the same thing with the orders. Let's first make these two fields work. Same deal. Let's keep the state local unless we have to lift it. Super quick. We go to the order line component and we apply the same trick. We use the use state hook. We pass it the initial values. We have the setters. We plug the setters in, and now all of a sudden, this is working. Perfect. It kind of looks like we're at least 60% there, right? Like it's like, wow, just we put a couple of hooks and we're almost done, right? You wish, right? Anyways, so now is when we realize, we need to calculate the base currency price. And obviously, in order to calculate the base currency price, we need to access to the price rates that are living in the state of the exchange rates component. So, well, we are React developers. We know the drill. When this happens, what do? We lift the state, right? So it's time to lift the state. Well, let's create another context provider. It's good that we create this currencies provider because now we'll be able to reuse it by adding another provider, as we'll see in a moment. So we create the currency rates context. Now, what this context is going to hold is a record, an object, where the keys of this object are going to be the currencies, and the values are going to be the value of that currency rate, okay? So we can see here, it's string and number. String is the ID of the currency, and the number is their value. Like we did before, we create this idiomatic hook here, use currency rates, and we plug the new provider here. And that's it. We use state, passing the initial currency rate, which is this record, this object that we are going to have in context. And then the only thing that we need to do is come to the currency rate component and replace the use state with our new use currency rates hook. Okay, let's do that. We come here, we replace it, we access our currency, and we update the unchanged so that only our currency gets updated. Perfect. Let's see if this works. And it's working. However, you see, Now every single component is being re-rendered. Well, that makes sense because now every time that we trigger a change, we are triggering an update to each one of these components because now they are all receiving the object that we put in context. So it's okay. We know how to deal with this. Let's avoid these re-renders. It's easy. The only thing that we need to do is we need to spoon feed the currency rate component with every single property that it needs, and we lift this state a little bit higher into the currencies component. So let's do that. We come here and we lift it, right? We access the currency rate from here, and we are going to spoon feed the currency rate with exactly everything that it needs. And we're going to use the memo higher order component to enhance this component so that it doesn't update when its properties haven't changed, right? Okay, let's see. Yeah, okay, that worked. Now, at least the different rows are not being re-rendered. Cool. So we're finally ready to access the currency rates from the order line so that we can calculate the base currency price. Let's do that. We come to the order line. We use our new hook for accessing the currency rates. And with these utils, with this function that comes from the utils, we calculate the base currency price for this order line. Cool. So that works. We can see that it is updating. Perfect. But now let's see what happens. Oops. Now, when we change one currency, every single component updates. Even when we change a currency that is not being used there, every single component updates. Of course, that's happening for the same reason that was happening before. This hook is triggering an update to every single order line. So whatever. I mean, it is what it is. It's triggering updates. There are ways to avoid it. But now, now we realize that, okay, we're going to have to leave this state anyways, because we'll have to add the sum of all the base currency rates from here, right? So, okay, now lifting this state is a little bit more complicated than the other one because we can add orders, we can edit different properties. And when these things happen, we know what to do. We can use a reducer. Then we can use the use reducer hook that will give us a dispatch that we can pass down so that we don't have to create other functions that could be triggering re-renders. So let's do that. We go to the top and where we have all the context. And first thing that we're going to do is we're going to add the reducer here. And then we're going to create its context so that we can access the orders from anywhere. And we're going to put in context the dispatch. And we're going to put in context those orders. Again, what we're going to have in context is a record, an object where the ID of the object is going to be the key, and the order is going to be the value of the object. Okay? Now, we're not going to fall for the same trap that we fell before. We know that in order to avoid unnecessary re-renders, we'll have to spoon feed the order line component with everything that it needs. So let's do that. We go to the orders component. We get everything that we need, and we spoon feed the order line component with exactly every single property that it needs so that in the order line component, we can use memo to avoid re-renders, okay? So now this is finally working without triggering unnecessary re-renders, as we will see in a moment. I mean, some re-renders are happening, but at least now each one of the order lines, the non-affected order lines are not being re-rendered. Perfect. So we're almost done. Sorry, this was a little bit long. Let's wrap it up. Now we want to make the add button work, right? Now we have to be careful because if we access dispatch from this component directly, then we're going to be triggering updates to the whole application anytime that we change an order. And that's because we've put the dispatch in the same context that we put the state for the orders, which is the most common way of doing this. So there are different ways of avoiding this. We could have created a context for dispatch and a context for the orders, but almost no one does that. So another way to avoid triggering re-renders to the whole app is to create a small component just for, oh, sorry, I forgot to put the orders provider here. It's to create a small component just for triggering the add dispatch action. That way, the re-renders will be isolated into this component and not in the whole app. Okay, so that's what most people do. So we put this add order button component, and then this is working perfect. Last, we're going to make the order total work. Okay, so how do we do that? We use all the hooks that we've been creating, and then we recalculate every single base currency price from here. Despite the fact that this has already been calculated in the orders component, we need to recompute it again because this component lives outside, and then we add it and we put it here, and that works. It's a little bit unfortunate that we have to do these things, but there is no easy way with React for creating derived state. So, there are alternatives, but they are not nice. We could have like we could tightly couple the two reducers, and there are other ways of doing this, but I don't think that there are many elegant solutions for solving this problem using React, at least, or using just React as a state management library. So now this works, and it gets updated. But let's see what happens when we update a currency that it's not being used inside the order lines, like the Canadian dollar, right? Well, this component is being re-rendered. And of course, it's being re-rendered because React doesn't know that this currency rate is not being used in any order, so it needs to recalculate to figure it out, right? I mean, such is life, right? But we're done. Thanks for your patience with this, but it was necessary to show you what I'm going to show next. So this is the code that we've generated using React. There is also some code that it's living in some of the presentational components that maybe shouldn't be living there because it's domain code. But anyways, yeah. So I don't know about you, but I find this way of managing state very tedious. Every time that we have to leave the state, then we have to start worrying about avoiding re-renders. We don't have an easy way of defining derived state, so we end up putting business logic inside the components, or tightly coupling reducers that maybe they shouldn't be tightly coupled. And even after having applied all the recommended performance optimizations that we can use with React, we still see components that are being recomputed for state changes that don't affect them at all. So why is that? And I guess that some of you will be thinking like, that is when I say that this is because React is not reactive. Well, it's not that. I mean, sure, React maybe it's not reactive, but we can make it reactive with a reactive state management library. So the real reason why I think that this happens is because we're conflating the view tree with the state graph. What does that even mean, right? Well, if we had to draw a diagram that represents how our components are being composed, that diagram would look more or less like this. Here we have a root component, which is this whole thing, and the root component has these currencies, which is this thing here. For the lack of a better name, we have the summary component, which is the one holding the add button and the totals. And then here we have the orders for the order lines, right? This is this tree represents the way that our components are being composed, right? However, what if we had to draw a diagram that represents how we would like to compose the state? Then at least the diagram that I'll be drawing will look like this. So basically, we are defining each piece of state like if we were defining the cells of a spreadsheet. For instance, the orders total depends on the base currency price of each order. Anytime that one of the currency prices, the base currency prices, updates, the orders total will be recomputed. And if they don't update, it won't recompute, right? We are declaring its dependencies. Similarly, the base currency price of each order depends on the order price that the user set for that order, this one here, and the currency rate of the selected currency. So if the user has selected the US dollar, then it will depend on the currency rate of the US dollar, right? Like here. If the user has selected the Canadian dollar, it will depend on the currency rate of the Canadian dollar, and so on and so forth. With this rate and this price, we can calculate this one, right? So if every time that we define a piece of state, we define it based on its dependencies, then we will be creating a loosely coupled solution. And we'll be creating a solution where we can derive the state. So it's not only that we'll make sure that the React doesn't recompute when it doesn't have to, is that we'll be able to compose this state farther down. The same in a way that it's kind of similar to the way that we compose our components. However, if we use React as our state management library, we won't be able to define our state like this, because React treats our state as a black box. It doesn't understand its hierarchy or its relations. What's even worse is that we'll be using a tree for modeling a graph, because this is not a tree. It kind of looks like a tree, but it's not. It's more like a graph. We can see that some nodes here have more than one edge. And that may be okay if the state of if the state graph of your app completely overlaps with the view tree. But if it doesn't, then I don't think that we should be using React as our state management library. I might rather to use React for modeling the view tree, and then outside of React, use a state management library that allows us to define our state based on their dependencies. In other words, a reactive state management library. Something that looks more or less like this. That's what I would like to have. Okay, so ideally, I would like to be able to compose my components using React here. And I think that RxJS could be a very powerful tool for building this state graph. However, RxJS alone can't do that by default. It needs a little bit of help. The reason being that RxJS observables by default are unicast. And when working with React and for deriving those states farther, we need to work with observables that are multicast and that they are replayable. And we need to do that without creating memory leaks, okay? Which is possible, but it needs some enhancements. Also, we need to have a way that we can connect these little pieces of state directly into React in a way that it's almost transparent to the user. So here's where React-RxJS comes to play. React-RxJS enhances the normal streams that you will produce with RxJS. And it provides, every time that we do that, it provides a hook so that we can use that stream inside React, inside our React components. And it gives us a stream that we can use to keep composing that stream, as we'll see in a moment. So if we keep doing that, then we'll be able to handle our state, to manage our state like this. We'll be able to define our state like the real graph that it is. And what will happen then when the error rate value changes? Like, what will happen if it changes and it's not being used in any other line? Well, this component will update and nothing else, because right now, this will not trigger any other state changes. And what will happen if the Indian rupee updates? Well, the exchange rate for the currency will update. It's being used in one order line, so that one will update, and it's being used in the other total, so the other total will update, and nothing else, right? So it's not only that we'll be defining a state that it's composable, it's that we'll be helping React knowing when each component needs to be updated, right? So let's see how that works. Let's solve the same problem that we solved before using React as a state management library. Now let's solve it using React-RxJS, okay? Sorry. The starting point is the same as before. And the first thing that we did before was we put the currencies in context. I don't know if you remember, but that's the first thing that we did. So let's do the same thing, but using React-RxJS instead, just for fun, okay? So if we want to put the currencies in context, this is one way that we can do that using React-RxJS, okay? So let me explain what's happening here, because this is definitely code that can look a little bit weird at first. So bind is the secret sauce of React-RxJS. Let me explain what bind does. Bind is a function that it takes at least one argument, the observable that will be emitting values that we want to use inside of React. In this case, it's empty. We'll explain why later. The second argument, which is optional, is the default value that we will be using until this observable has emitted. Okay? Then bind returns two different things. A hook, so that we can use those values inside React, and the enhanced version of an improved version of the input observable. Okay? So that it's shared and it's replayable so that we can keep deriving from it. Also, another improvement that this observable has is that if the original observable doesn't emit synchronously and we provide a default value, this observable will emit synchronously that default value. Okay? So this is the observable that we can use later on for keeping deriving for deriving more things from it. Okay? And this is the hook that we can use inside React. Now, maybe using bind here looks like an overkill. But it has two advantages over using React context. Well, the first one is that it is a lot easier to set up. And the second one, which is the most important one, is that if in the future the currencies become a dynamic value, then we can replace this empty observable with the real observable that will represent those dynamic values. And so this empty here is like a placeholder for whenever we need to bring whenever we have to bring this to life in the future. Okay. Moving on, let's make something work like we did before. Oh, hold on a second. Let's use this observable that we created in the components that are using it, and we're done. Now let's make the exchange rates work. Okay. So far, like before, like now nothing is working because we haven't, the only thing that we've done is to put these currencies in context. So now let's make the exchange rates work, okay? This is how we can do it. What's going on here? Let me explain, because this code can be a little bit intimidating at first, but once you get used to our API, it's not that complicated. The first line that's highlighted uses this util called create key signal to create a signal for each currency. In the context of React-RxJS, we use the term signal for referring to external events. Every time that we create a signal, we want to have an observable for listening to those events and an event emitter for emitting those events. Using RxJS terminology, this is like saying that we want to separate the observable from the observer of its underlying subject, okay? But the idea is that a signal is something that we create when we want to listen to external events, okay? Now, sometimes we want to partition these signals so that each instance has their own signal. Like here, right? We want for each currency to have a signal for when the user is editing that currency, okay? For those cases, we use create key signal. We have another util that it's called create signal, but for here, we're going to be using create key signal, okay? Create key signal returns a function for accessing the observable of each instance. This is what we call a factory observable, and it's something very useful in the context of React-RxJS. And then it returns an event emitter. The first argument of this event emitter is going to be the key, and the second argument is going to be the value that will be received inside the observable. Okay? It sounds more complicated than it is, but believe me, it's not that bad. And then here we can see how bind this time is not taking an observable; it's taking this factory observable, right? Let me explain what this means. This is very similar to using defer, if you are familiar with the defer operator of RxJS. From here, we can decide for each key the observable that we should be using, okay? We could have used rate change directly because it has the same signature, but I added the full function so that it's clear what we're doing here. And similarly, like we did before, here we can provide the default value, okay? So this is going to give us a hook, just like before, and a factory observable so that we can keep deriving from it. As we'll see later, this is going to be very useful. Okay, so let's plug this in. We just come here. Notice that this is kind of similar to useState, but outside of React, right? Kind of similar. And then here we access the rate for this currency. This is going to give us the rate values. And here we plug the event emitter. We pass the key and we pass the value. Okay, now this should be working, and it is working. Perfect. Let's do the same thing for the order lines. Okay, so for the order lines, the first thing that we want to do is we want to have a hook that gives us the IDs of the orders. Why? Because the orders component, the only thing that it's going to be responsible of doing is instantiating the different order lines and giving them their own ID. Then the order line component will be responsible of handling the order. Okay, so for now, like we did before, we're going to use this empty observable as a placeholder. Later on, we're going to replace this empty observable with the actual observable once we plug the add button. For now, let's use it as a placeholder. Later, we'll make it work for real. Okay. Then we use the user order IDs inside the orders component, and that's it. We pass the IDs, and we let the order line component handle the order line for themselves. We don't need to spoon feed it anything. All right. Now, excuse me. Now let's make the hook for the order line. Similarly to what we did before, we're going to create two key signals. One for listening to the price changes of each order line, and another one for listening to the currency changes of each order line. And these are their event emitters, of course. Okay. And here, this is the interesting bit. We're using the factory. We're using the bind factory overload to create an observable for each one of these orders. So we access to the initial order, and then we create an observable for the price. This is the same as doing price change pipe start with. I like concat better than start with for some reason. This is a pet peeve of mine. Sorry, it's just because it reads on this in the actual sequential order, and sometimes I find a start with a little bit confusing because you have at the end what it starts with. Anyways, forgive me. So here we have a stream for that will emit anytime that the price of the order changes. Here we have a stream that will emit anytime that the currency changes. For that order. Now with these two streams, we can just use combine latest. Isn't it nice that with RxJS 7 we can use combine latest with an object? Anyway, so we can use combine latest, and every time that there is an update, we're going to spread the initial order with the update so that this emits an update for the order that has been updated. Then we can use this hook inside the order line. We pass it the ID, and we plug the event emitters, and that's it. And this should be working. Perfect. It is working. Awesome. So now it comes that moment where we have to make the base currency price work. I don't know if you remember this, but when we were implementing this using React as a state management library, this was the moment that we had to start lifting state, worrying about re-renders, refactoring the exchange rates component and whatnot. Now here, since we're able to define each piece of state as a derivation of their dependencies, we could create a stream here for the rate of this currency, and then we could combine that rate stream with the price stream and recalculate the base currency price whenever one of those two changes, right? And then we could add the property here, and we'll be done. Then each order factory observable will have the base currency price like any other property that it's derived. So instead of deriving it from external inputs, we're deriving it from other streams. That's it. So let's do that. Here, we want to make sure that anytime that the currency changes, we switch map to the currency rate that we created before. Remember, we said that we will be able to keep deriving from it. So that's the moment to do that. So anytime that the currency changes, we want to switch map to the currency rate stream of that currency. And this is going to give us a stream for the rates of this order. Then for calculating the base currency price, we just need to combine the latest values of the price stream that we already had before and the new rate stream. And anytime that one of these two changes, we recalculate the get base currency price for that order. We add this property here, and we're done. The only thing that we need to do that now is we go to the presentational component and we use the new property of order. That's it. Let's see if that works. It better work. Yeah, it is working. Awesome. And then one cool thing about this is that if we change the euro, only the order lines that are using the euro are being updated. What happens if we change the Canadian dollar, which is not being used anywhere? Well, nothing updates, nothing re-renders outside of this component. And without using any performance optimization, just by using a reactive state management library, right? It's pretty cool. Yeah, so there's that. Now let's make the add button work. We said before that we are going to be using this empty observable as a placeholder. Now let's bring it to life. This time we're going to be creating a signal, not a key signal because we only have one add button. We're going to be creating a signal for getting the events of when the user clicks the add button. So let's do that. We create this signal, and then we want to make sure that every time that the user clicks on this button, we create a new ID, and that we scan this ID, and that we scan this to produce an array where we put the new ID at the end. Okay, and the initial seed for this scan is going to be the initial order IDs, of course. So we were already using this hook, so we don't need to change anything there. The only thing that we are left to do is we need to plug the onAddOrder event emitter. So let's plug it in. We come here, and I don't know if you remember, but before when we were using React, we had to create a new button component to avoid re-renders, or we were put in that situation where what should we do so that nothing re-renders? Now, nothing like that. We just put here the event emitter, and we don't have to worry about anything. This should be it. Let's see if it works. It is working. Awesome. Now, the last thing, I'll be done with this. This is the trickiest part. You may be wondering, okay, so in React-RxJS, they have this concept of factory observables. Looks very cool because it's kind of weird, right? Like these functions that they receive a key and they give you an observable for that key, and they say that they can do that without triggering memory leaks. Believe me, like we could make a talk just to talk about that, but that's what happens. So how can we now access the properties of these factory observables to compute this value here, right? Because basically what we would like to do is for each one of the IDs that we have in this stream, we want to access this property of the order factory observable so that we can add those ones together, right? So don't worry, we got you covered. We have this util operator that's very useful for us that we call combine keys. So combine keys, it's an operator, a creator operator, that takes a stream of IDs as the first argument and a factory of streams as the second argument. And then it returns a stream that emits a map of values every time that one of the values of the map changes or any time that the IDs change, right? So yeah, we use combine keys, and then we grab the values, we map them, we reduce them, we put them all together, and that's it. And then we have a hook and a stream that we can keep driving from if we want to. Let's see if that works. Okay, it is working. Let's see what happens when we update a currency that it's not being used anywhere. Nothing is being updated. No React re-renders are happening anywhere. In fact, something that is kind of interesting is that if two currencies have the exact same price and we change this one to this one, this is not being re-rendered because its value didn't change, right? Like because the exchange rate of that order line keeps being the same, so we didn't trigger a re-render here, which is pretty interesting. So using a reactive state management library has a lot of benefits. One of them is that we can avoid this. We don't have to constantly be worrying about whether we're going to be triggering unnecessary re-renders. or stressing React with unnecessary revendors. Oh, I forgot to plug here the use total hook before. Sorry about that. Now let's have a look at the code that we have produced. So this code can look maybe a little bit intimidating when you're not familiar with observables and with the mental models that we're trying to propose with React-RxJS, but this code has some nice advantages. The first one is that it reads from top to bottom, right? Like very similar to that graph, where at the top of it, we have those entities that don't depend on any other entity. And then we start deriving more complex pieces of state later, right? Anyways, so this is all the code that we've needed for doing the state management. We can isolate it, we can collocate it with a component, and we can keep our presentational components a lot cleaner because they just receive hooks that will let them know when they need to get updated. All right, so at this point, perhaps you are thinking, sure, okay, this is a contrived example. Does this actually scale in a real application? Okay, so yes, it does. Oh, I'm running out of time, so I'm going to have to speed up. Let me present you Reactive-Trader. So Reactive-Trader, this is our super cool open source showcase trading platform that we've built at Adaptive. The code is fully open source and available. You can access it. It's under the Adaptive Consulting organization, and the repo is called Reactive-Trader Cloud. So hold on, I need to speed up. So Reactive-Trader is a key project for us for two different reasons. The first one is that most of our clients are financial institutions that don't want for their competitors to know that we're working for them. That's why it's important for us to have a showcase application so that we can demo our potential clients what we're capable of. The second reason is that Adaptive will foster innovation, and Reactive-Trader is a tool that allows us to experiment better ways of doing things and to share that knowledge, both internally and externally. So this Reactive-Trader, I'm not going to enter into the details of everything that's going on here. There is a lot going on, as you can see. There's a lot of different moving pieces, prices that are being, whoa, what happened here? Prices that are being updated when from a WebSocket API. Lots of derived state, of course. Now, Reactive-Trader is a project that got started many years ago, and it has gone through a number of refactors. The latest refactor started a few months ago when we decided to fully re-architect it using React-RxJS. So in the previous section, we saw how thanks to React-RxJS, we can improve the performance of our React apps by not over-stressing React with unnecessary revendors. However, when it comes to web performance, the most important metric is those ones that have to do with loading times. And probably Lighthouse is the best tool for analyzing those metrics. So was React good for us for improving the loading times of our app? Let's see. These are the performance metrics of the classic version, the one that we had before we did the refactor. And there was a lot of room for improvement, that's for sure. And these are the metrics after the refactor. So the most impressive thing, in my opinion, or what has allowed us to greatly improve the loading times, is the fact that we have been able to remove the unused amount of JavaScript that was penalizing us with 2.18 seconds to an amount of unused JavaScript that it's penalizing us with 0.15 seconds. So, well, that on mobile, because on desktop, I think that we are clear. So yeah, React-RxJS definitely helped us improve the loading times. So how did we do that? Well, by improving the code splitting. Let me explain a little bit how code splitting works for those ones who are not familiar. I'm going to go fast. This is what happens when a web page loads, right? The browser makes a GET request, and then the server returns an HTML file. In this example, it takes about 130 milliseconds from the moment that the request is made until this comes. Then the browser passes the file, and the browser starts making a series of requests. One of these requests is going to be our main JavaScript asset. Then the main JavaScript asset, in this example, it takes about 1 second to get downloaded and uncompressed, and that's fine because that happens outside of the main thread. However, once it's been downloaded and uncompressed, then it takes about 1.4 seconds to be fully parsed compiled and evaluated. And this is something that happens in the main thread. Therefore, it's a blocking task. So we should be careful with this, and we should make sure that we don't block the browser for too long. Once the main JavaScript asset has finished loading, if we are not doing any sort of code splitting in an application like this one, we'll start loading the data for the live rate section, this data here. We'll start loading the data for the analytics section, this section here, and we'll start loading the data for this section here, right? It's only until all this data is available that the app is going to be fully responsive, interactive. Now, what happens is that if we don't do any sort of code splitting, we're going to be shipping all this unused code that is eating up all this time, that it's slowing down the loading of this data, right? So ideally, we wanted to remove this code from the initial render, from the shell component, from the main JavaScript asset. We want to get it out so we can start this request earlier, right? So this is what most people do when they code split. If you have a state management library that allows to self-contain all the logic for these sections in its chunk, then your main JavaScript asset is going to become a lot smaller, and then you will be able to have each chunk handle their own logic. The only problem is that when that happens, another thing that usually happens is that because the logic is self-contained here, this request will only start after this asset has finished, has been completely downloaded and parsed, okay? And what happens if we use a state management library that's based on a central store, or if we use too much React state at the root component? Well, what's going to happen is that the main chunk is going to be a lot larger, and these small chunks are going to be smaller because a lot of the logic of these chunks got pulled into the main asset, okay? So ideally, we want to have something like this, but we want to go one step farther. In an ideal world, we want to be able to start this request as soon as the main asset starts, while also separating all the logic for these chunks, okay? And in a super ideal world, we want to be able to preload these chunks on the index.html by using the module preload link, so that whenever this is ready, the application will be fully interactive. So using React-RxJS, it's trivial to get this level of code splitting with just a few small modifications. Let me show you how we did that, okay? We did that by fully leveraging React Suspense. So this is our root component for this. And we can see here how we have the live rates component, which is this section here, and the traits component, which is this section here, and the analytics component, which is this section here, okay? Then we have a resizer here so that we can resize this. Okay, cool. Now, we are going to start zooming into the components so that we understand how we are using the state in each one of them. We're going to put the zoom into the analytics component. So let's put the zoom into this analytics component, which is this section here, and we'll see that it has 3 different sections: the profits and loss, the positions, and P&L. This one here, and this one here. Let's put the zoom into this one. And then let's put the zoom into, so here we have the line chart. This is very complicated. We're not going to get there. Let's put the zoom into this one, which is very simple. It's the component that's rendering the latest position of the analytics. Let's see how that one works. So speeding up, we can see that here we have this hook that uses the history. And now notice that bind, we have not provided the default value to bind this time, okay? So what's going to happen when the history stream has not emitted any values, or what happens if it emits a value and it happens to be empty? The history is empty. Well, then this stream is not going to be emitting any values. So what is this component going to render in that case? With error? Kind of. So the thing is that React-RxJS fully supports React Suspense. So React-RxJS is going to let React know that this component is not ready to be rendered. And then React is going to know that it needs to put some sort of placeholder. So React is going to ask its parent, do you have a placeholder for me? Because one of your children cannot be re-rendered. And then the parent will be like, no, I don't have anything for you. And then React will go like, okay, let me ask your parent. And here we'll find this suspense boundary, which lets React know, okay, since one of the children here is not ready to be loaded, please put this loader while the data is coming. When the data comes, React-RxJS will let React know that the data is ready. And then once all these components inside are ready to be loaded, it will replace the loader with the actual data. The very nice thing about this is that React won't stop the rendering process of all the inner components while there are components that are in suspense. Everything will keep working behind the scenes. So that's pretty cool. So this is nice because now we can use suspense for data fetching, and now we don't have to start constantly worrying about, is this loading, is it not? We can just let the parent component handle it, and the parent component doesn't have to know about the internals of each component. Therefore, in each component, we can collocate the logic that has to do with the state management of that part in that component and derive from it. So we could go one step farther, and we could say, hey, I want to code split these components. So how do we do that? Super easy. We create a core analytics component, and we lazy import it with React Lazy, and we put it here. Now, the same suspense boundary that we were using before for data fetching, we can use it now for code splitting, which is super interesting. And just like that, we're halfway there. But there's one last thing that we would like to do. We like to start the request as soon as possible. So that's super easy. We just go to the analytics service and we start the subscription. So as soon as the core, as soon as the shell component gets rendered, which is the main asset, as soon as it gets evaluated, actually, the main subscription will start. But this subscription doesn't know anything about the logic of these components. It only knows, because we are deriving the streams, it only knows how to get the data, nothing else. So we can isolate all the logic for these components, and we can collocate it there. And just like that, we have completely code split our application. And without compromising the way that we write our code, which I think is super cool. One last thing that I'm going to be talking about, I'm just going to make it just in time, code navigability. So one big advantage of using streams is that we can easily code navigate our code base. The reason being that since we have this orthogonal graph that we are putting together with the tree view, whenever we want to understand when a value comes from, for instance, let's imagine that we want to know where this default value comes here. Let's say this is the default notional value. We want to know, like, where is this coming from, right? So naturally, we'll go to the notional input component, which is this one, and then we'll see here that there's a default notional that comes from this use default notional, right? So if we go to the use default notional, we can see that it comes from this hook, and then this hook, we can see that it comes from the currency pairs. Okay, and then, okay, this comes from the services. Let's code navigate to it. Now we have code navigate to the services, and we see that it comes from these currency pair updates. Then if we don't know where this comes from, we just need to code navigate. So we can keep code navigating without using grep or using find all references, which makes the maintainability of the project a lot easier, at least in our opinion. So here we have code navigated from a leaf component all the way up to the client of the projects, right? So it's pretty cool. And we can keep going, right? We can go to the get stream and we can keep code navigating. So there are no layers of indirection, making the maintainability of the project a lot better. Okay. Yeah, that's it. One last thing, the trade-offs I want to mention really quickly. All things come with their trade-off, of course. We've seen that there are lots of benefits with React-RxJS, but there's also a steep learning curve. People have to be familiar with observables, with RxJS, and with the RxJS mental models that we try to propose. And there's a steep learning curve for this. I think it really pays off. I think the return of investment is great. But yeah, it's something to be considered. Server-side rendering. I'm not saying that it's not possible. I have not investigated where it's possible or not. I've investigated very little, but it's not a need that we've had. So I'm not sure if the library is well suited for doing server-side rendering. And another trade-off is that the documentation, at least for now, has some room for improvement. Lots of thanks to Victor Oliva, the co-creator, the co-author of the library. He should have been co-presented with me, but I took the bullet for that one. He's the real genius under React-RxJS. Thanks out to him. Thanks out to Adaptive, the company that I work for. They have been super supportive. They have been believing this idea since day one. This library has grown organically a lot inside Adaptive. So thanks out to everyone at Adaptive that has been supporting me on this. A lot of thanks to the RxJS core team, especially to Nicholas Jameson and Ben Lesh for their patience with my contributions to the library and for fostering a community that is so welcoming. Thanks out to Cos. He's the author of this of Rex, a really cool project. I find his ideas like truly inspiring. Some of his ideas, I was like, wait, what is this? But I really appreciate the fact that he is able to think out of the box and come out with a super creative and super creative stuff. And I think that we need more of that. And last but not least, thanks out to Daisy Kato. He's the author of a lot of state management libraries that are super inspiring. Jota, Valtio, React-Tract. He also put a project to check if things will work with concurrent mode, and I just made it in time. It's been an hour. Thank you all for listening, and thanks Jen for having me. Of course, that's it. Thank you.
Thank you, Joseph. That was a very good talk. Okay, yeah, you're right on time. It's perfect timing. Thanks for being one of our speakers again. But I'm gonna have to bring the next speaker. And yeah, we'll catch up, Joseph. Thank you. Thank you very much. Right. So our next speaker is Younes. I hope I'm pronouncing his name right, but we'll ask him. Let me bring him in. Did I pronounce your name right?
Hey, yes, perfect. That's exact right pronunciation. Good.
Good. Okay. So your slides are ready. I can see. Hang on a second. No, it's not your slides.
No, it's not. I didn't share them yet. I'm gonna share my whole screen.
Okay.
Okay. And yeah.
Okay.
And this is it.
Okay, that looks good. All right. Well, I'd let you get on with your talk. Okay, when you're ready.
Okay, I'm ready.
Okay. All right. So we're starting with that blank slide.
Yeah, because if I turn on my screen, because if I stop my slides, I can't see you anymore. So I can talk with you.
Oh.
But I.
Okay.
So
all right. So I'll let you get on with your talk. Hang on a second. All right. Good luck on your talk.
Okay, cool. Thank you. Just had to find my clicker. Let's go. Thank you for having me. Okay. So I'm going to just start immediately right now with a question. And so that's why I'm here. So why do you ever have to implement like a live search application, like you have a form with a live search and you have to show the results instantly? You can answer on YouTube. I'm watching the chat. Might take some delay, but it's right. So I'll check the answers later. So it can be tricky, but RxJS makes it a little bit easier, so we'll check that out. But it can be really, really hard. So with RxJS. So suppose you have this search input that allows you to live search something. And the thing is, every time you type any key on your keyboard, it will make a call on the API on your old grumpy server, and which will call a database, for example, or another service or whatever. So, okay, it's all right. So for every key strike, I'm going to send a request to the server, and I'm going to get a response and display it. But the problem starts when we have fast typing users. And while they are typing, we send in lots of requests to the server. And so at every strike, we're going to call the server, which is going to trigger like some code on our old grumpy server. And then the problem is we might have like lots of useless calls that are handled by the server and triggering some chaos on the back end, like lots of CPU, memory usage, and database usage and stuff like that. Okay, that's where you're gonna tell me that you don't care that much because you're serverless or your infrastructure is completely scalable. But okay, if you don't care about that performance problem, you might care about your budget. And so that's what we're trying to focus on here. We just want to make our servers run less code or do less useless stuff. Okay, so what's the first thing that you can think about to reduce this problem? I know you can answer and share your answers. And so I think the common answer, I can see yours because it takes some time, so I just assume that you answered this, but that's the common answer we get. The common answer is to add some delay on the application. So every time the user types, we're going to wait a little bit before sending the request, just in case the user is still typing. We're going to wait for him or her or there to stop typing. And that's when we're going to make the request. So the common way of doing this is using some debounce strategy. This is possible with RxJS, but we can do it even without RxJS, but it can be tricky without RxJS. So the idea of the debounce is that here we can see the streams on the first line of what the user is typing, and on the second line, we're constructing the whole input. And as you can see, we're going to wait for the user to stop typing, and that's when we get some delay. That's the debounce delay that we're going to wait for before sending the request to the API. So as you can see here, we're going to send 2 requests instead of, I can't count, 9, I guess. Okay, so we're reducing the amount of calls to the backend. So the common way of doing this with RxJS is, suppose you're using you're having already an observable you're containing the keywords. Usually, like for example, if you're using Angular, it's going to be like form control, the value changes observable, and you're going to do you're going to add some operators on top of that to get your data. And data is what we finally want. It's the data that the API will send us, and that will console log or do whatever we want to do with it. And so that's where we're going to add the debounce time operator, which is an RxJS operator that allows us to add this famous delay that we've been talking about just before. So here, what we're seeing here is that I don't care about keywords until the user stops typing for 100 milliseconds, and then I'm going to grab the last value that was typed. So that's the only thing we have to do, and then we can do our usual logic. So here we're using the switch map flattening strategy to go search for the data on the API. So every time we have new keywords, we cancel the previous requests automatically and grab and send a new one. That's why I'm using the search switch map here, because I don't care about the previous results. I'm just thinking about a current result, new one. But the problem with this approach is that we kind of solved the issue because we reduced the amount of calls a little bit. But the problem with this is artificial latency, and I don't like artificial latency. I mean, like the web have been moving for dozens of years to improve the performance. We've been like improving the internet connections, and we're just adding like crazy frameworks, crazy technology there to get faster and to be faster and faster, and then we just add 100 milliseconds delay there. So I don't like this. So I'm not going to use the debounce time. So I'm going to just hit my table. Well, we're not going to use the debounce time. So what we're going to do if we don't use the debounce time is that we'll still have the problem of the calls being sent to the server. But let's say we don't care that much. So we have the initial problem we've been talking about, the server running a lot of calls. But the cool thing with switch map, at least, is that every time we send a new request, the switch map will unsubscribe from the previous observable. And if your HTTP request you're sending is using something which is using an observable that has a tear down logic that unsubscribes automatically, it will cut the connection with the server, which is perfect. So it will cancel the HTTP request. So each time we're communicating, thanks to the switch map, each time we're communicating with the server, the request is the previous request is canceled with the server. So we only have one live request that we're waiting for a response for on our application. But the problem is, what's happening on the back end? Did we solve the issue, or did we just trigger some chaos? Is the server still trying to build a response for our initial request or not? And that's the main problem here. And what if our server is also calling like another server, like another microservice or external service or anything? Did we just solve our issue because every time we cancel previous requests, well, everything is cleaned on the back end, or did we just run a lot of trouble there? So that's what brings us to this talk and discoveries I want to share with you. So we'll cover the problem of what happens when you cancel an HTTP request, because every time we're using RxJS, and I assume you're all RxJS users or future RxJS users, and one of the interesting things is canceling HTTP requests and stuff like that. But what happens on the back end is a real other issue, and that we have to dive in to see what we can do and what we can improve there. Okay, so now I can present myself. So my name is Younes Jaaidi, and I live in Lyon, in France. I'm the founder of Marmicode, where I share content, and we help our clients cook better apps through workshops and coaching, and also some online courses that I'm currently building. So stay tuned on Marmicode. There's a newsletter, or just follow me on Twitter or whatever. I'll let you know when it's ready, when it's there. And I'm also a Google developer expert for Angular and web technologies. So that's why I use a lot of RxJS, mainly through Angular. That's how I discovered RxJS, by the way. And that's it about me. So let's get back to our problem, and let's stop that fire running on our server. So now we talked a little bit about the front end, but now I'm going to focus on the back end. Let's assume that we're using a JavaScript backend here. This way it's easier to say the topic. And let's use Nest.js. I don't know if you've heard about it or if you use it, but Nest.js is a JavaScript framework for implementing HTTP servers mainly. And it can run over, it has adapters, so it can run using Express.js or any other lower level HTTP server, JavaScript HTTP server. But it provides a couple of features and building blocks to structure your code. And if you're an Angular user, for example, you can reuse lots of concepts that Nest.js is inspired from Angular, a lot of Angular patterns. So you have dependency injection, you got TypeScript and stuff like that. So it has lots of interesting things, decorators and things like that. So if you're familiar with Angular, Nest.js bridges the gap between Angular and the backend. And instead of like diving into the features, because I'm not going to focus on Nest.js, and just using Nest.js as an example, I'm not going to focus on it. Instead of explaining how Nest.js works, let's just see how the code looks like. So as you can see here, that's a basic controller for a route on our backend. This is the equivalent of an express router.get, and then you give the path and then you get a function. But here it's a class with methods and stuff like that. So you have a decorator, a controller decorator that says, okay, this class is a controller for the /files route. Then you have a class with a constructor, and we use it for dependency injection. So file search is a service, just like Angular. So you have a server, you can inject a service that we can use in the methods below. Then you can declare a couple of methods with the get or posts or any HTTP method annotation, or even other kind of annotations which are not related to HTTP. And so this function will be called every time you have a GET request on /files, and you can inject through the query decorator the parameters from the query string. So here I'm grabbing the Q parameter from the URL to grab the keywords that the front end is sending me. Remember, the switch map thing is sending an HTTP request, and that will be the query every time I'm typing something. This is the keywords that are sent to the server will call this function. And then you call whatever you want, and you return the data you want, and you do your work. But the thing is, it's quite probable that you'll have to run some asynchronous code. So you're not going to return some synchronous data you already have in memory, or I don't know. So, and you don't want to run like synchronous database queries and stuff like that. So it's going to be asynchronous. Nest.js has different ways of doing it. You can return a promise, or you can use async await, of course, and you can use observables. And that's one of the fantastic things about Nest.js. So when you use Nest.js, you can return, so I'm going to use my service, like my file search service, and it's going to return an observable, and I can do whatever I want. I can use all the RxJS operators I want and stuff like that. And I will return the observable, and Nest.js will use that observable to build to render the HTTP response to the client. But why? Why would I mean, like as mentioned before, like in different talks, RxJS has a steep learning curve, so we really have to use the benefits of RxJS to change the balance on the trade-off of the steep learning curve. So why would we add RxJS to something to the backend? Well, especially that the response, it's an HTTP response. It's a basic HTTP response. We're not talking about WebSockets or HTTP2 or anything. It's a basic HTTP response. So it's not a stream. I'm just sending just a JSON. So why would I need that? Well, we need that because observables have a tear down logic. Okay, so the tear down logic is very important. We're gonna see this right now. It's what happens when you unsubscribe from an observable. Okay, it's something that will stop the work which is happening under the hood, and that's exactly why Angular is using observables in the HTTP client of Angular. That's one of the reasons. There are other reasons, so that's one of the main reasons. So it's a common question that keeps coming. Why are we using observables in Angular? Why not just do to promise, or with the first value from, or with last value? So tear down logic works like this. So here, what I'm going to do is I'm building recreating the interval function that just pops up values like every X milliseconds, or every period of milliseconds. And I'm building the observable from scratch here. That's exactly how you should not do it, because interval has a lot of other things that are way more important. You shouldn't, we'll not use it like this, because there's a couple of additional stuff to add to this to make it safer, and so we can hook it on different schedulers and stuff like that. So interval here is creating an observable, and so I'm instantiating a new. I'm instantiating new observable, And as you can see, I have an observer, just calling the basic set interval function. And every time I get new value, I'm calling observer.next. And the tier down logic is the logic that I will add to this observable to tell the observable that, hey, when you subscribe from this, don't forget to stop this interval because it will keep running under the hood. And then we get memory leaks and stuff like that. So every time you use set interval or anything similar, the set interval always returns like a handler that allows you to stop it later. So here I'm calling set interval. I'm getting a timer as a return value, and that timer is the timer I'm going to use to stop the interval. So in order to do so, I'm going to return a tier down function. So that's how the observable works. So it's quite similar to how effects work in React hooks. It's quite similar of what you have in the Vue 3 composition API. It's common logic that every time you in the functional approach that you return in some stuff like this, you return a function that will be called when the observable is destroyed or when you unsubscribe from it. So here I'm just saying, okay, start the interval, and when I return the observable, and when you unsubscribe from this observable, don't forget to clear the interval and stop the logic that's happening under the hood. Okay, so let's cook and let's try this. Right now, I'm going to just put my coding apron in case things get messy. Yeah. Okay. Okay, good. I'm gonna stop the slides and let's get coding. So the source code I have here is the app controller that we've seen in the code that I showed just before. I'm calling a file search service here, and this builds. So this is the Angular app that I built on the front end, which is using RxJS to make HTTP requests. And actually, I'm using a HTTP client to make a request to the server. And but the API is not implemented yet. So every time I'm sending something, I'm just getting an empty response, as you can see here, because the file search is just returning an empty array. I didn't implement it yet. And as you can see here, every time I'm typing something, A, B, C, D, if I type fast, every request, last request is canceling the previous one. That's thanks to the switch map that I've implemented on the front end. So on the front end, everything is all right. Now I have to implement the back end. So the thing is, I've implemented the live monitoring application here that monitors the CPU and the memory of the API. And I was looking for something really slow, but I couldn't manage to make it slow enough. So I started with a big file, like gigabytes of data, and live searching line by line, and still it was too fast. And then I started looking around. I was like, what could I do? What would be the right way of making it slow? Maybe a big file is not slow enough, but maybe if I have lots of small files, that's really bad for performance. And where can I find those? And I was like, I opened my idea and I was like, oh, node modules, that's awesome. Okay, so that's when I started implementing this. So the idea is I'm building an observable here that will crawl the node modules directory. I'm just filtering the definition types because otherwise I have too many files. And what I'm going to do is I will return. So, okay. This files. And for every file, I'm going to use merge map. So this is the file. I'm going to read the lines. This is a function I've built. So For every file, I'm going to read the lines of the file, and I'm going to merge all the results because I don't care about the order here. I'm just looking for the files for my line in all files. And then for every line, because here I'm reading the line, read lines will pop a stream, will return a stream of lines. And for every line, I'm going to just grab the line. So the line is an object that has the line, the file name, and the line number, and the contents. And I'm going to just make sure that the line contains the keywords I have here. So now I have a stream of the matching lines, and I just want to turn it into an array. So I can use different operators for that. I can use scan, and I can use reduce and stuff like that. But I want to time it. So what I'm going to do, there are different approaches, and the one I'm going to use here is buffer time. So I'm going to use. I'm going to tell it. I'm going to add. It will buffer all the lines in an array until it's complete, or until the timeout here happens, like after 5 seconds, because it can be really slow. So I'm gonna ask the server to just return whatever it has after 5 seconds. And so I get the lines, buffer time, and I just want one array. I don't want all arrays. I'm gonna just take one. I can use first. Well, anyway, and first can be it's for now. And now I have the array, but the search results. So these are my lines, but the search results needs an object containing the items property. So okay, in terms of typing, I'm all right. So I think it's good. So as you can see, so just to recap, I'm crawling my node modules, picking all the files, reading the lines of every file. I'm mixing all the lines, and I'm filtering the lines line one by one, looking for my keywords, and I'm making a buffer that full of all these lines until the timeout of 5 seconds happens, and I took just the first buffer. This is one way of doing it. There's different ways of doing it, and I transform this to the right format, and let's see what happens. So now, as you can see, if I start typing Angular, for example, okay, you can see that using more and more CPU, and then I get my results, and I've sent 7 requests. Now I'm going to type something really longer. Look at this. Okay, 44 requests, 54, 58, 80 requests, 100 requests, because it's a 100-character line here. And now I get the results. But as you can see, it's using a lot of CPU and lots of memory. And if I start my query and then I just stop, I can't stop, will cancel the last request. My browser here is not waiting for any response, but the CPU, the server is still working for nothing, okay? Let's try it again. As you can see here, okay, sending lots of requests, and I'm gonna stop. I'm gonna cancel all the requests. As you can see, all the requests are canceled, and the server is still trying to respond for all of these. So, it's not working. Okay, so let's get back to our slides. So it didn't work. It didn't work. As you can see, it didn't work because when I stop, my server is still working. I don't want my server to keep working. And as you can see, I'm just a lone user in front of this app. Now imagine millions and billions of people connected at the same time on that same app and making useless requests. You can see how it can amplify and how bad it is for our backend and for the planet and stuff like that. So why isn't it working? So in order to know why it's not working, you have to dive a little bit in Nest.js code, which is really surprisingly readable and clean and easy to understand. And usually, by the way, if you want to read some open source code, check out the unit tests source code to help you understand what's happening and what happens under the hood. So what happens in Nest.js is that it will return, every time we return an observable, it will convert all a transform to results function that will transform our observable to a promise. Okay, because Express.js works like this. You need to return, you have to call rest.send to send response. And so at some point, Nest.js has to pick the response at one, and so it's using to promise to grab our observable and get the data. But the problem with this approach is that when you use to promise, there's nothing that will unsubscribe. Nothing will, Nest.js will not decide to unsubscribe when the client cancels the request. So we have to do something about it. So the solution is to intercept the request, every request, and we can do this using interceptors. In Nest.js, you can implement interceptors. Interceptors work like Angular HTTP interceptors. You can intercept each request, and every time you get a request, you can do whatever you want to it. You can do whatever you want to the response. And as you can see, the interceptor can work on observables. So when I call next.handle, which calls our controller, what I decide to do here is I will grab my request and get the response. But what I'm adding here is that I will watch the socket close event. This event will be triggered by Express or Nest.js, and we will watch it to know that the client canceled the request. Then at that time exactly, we know that the client canceled the request, and we can use this by simply using the take until operator that will intercept, that will unsubscribe from the response when the connection is closed. So let's try again. Okay, let's try that. So I'm going to do in app module. This is my APIs module, the Nest.js app module. I can add an interceptor here, like this. This can remind you a little bit of how Angular works. So I'm just adding my interceptor, which is the exact code I showed you, almost the exact code I showed you in the slides just before, and this will intercept every request that happens here. Okay, and as you can see, let's try it out. I'm going to send lots of requests. So it's canceling requests. It's using lots of CPU and memory, of course, but in the last response, get the results. Okay, and then I get a result and it's finished. Now let's start again, and I'm going to stop at some point. And now look, instantly when I stop, the server stops processing whatever it's doing because there's no more requests running. Let's try again. Okay. Okay, and now let's try it. A last thing is, instead of using my file search here, oops. Search Mongo. If I can use the MongoDB here, and I can even do it with the Mongo. Cancel my request on the MongoDB server there. And what I did here is something that you should never do, because MongoDB is also very quick. So in order to slow it down, I had to use where operator to filter my query using the function, which makes the backend very slow. And in order to make this work, I had to do a little trick, and you can try it out if you want. I don't recommend it, but try it. So I'm returning an observable, and I added a tear down logic that kills the session I'm having with Mongo when I'm querying, and this will stop the query on MongoDB immediately, instantly. Sorry, I'm running out of time, so I'm not going to be able to show you the demonstration of the CPU and memory leak here on MongoDB, but you can try it out, or I can share you some links of demo for this. And it works exactly the same, so I can cancel my request on the database. Okay, so I'm going to just finish here, just show you my last slides. And so the whole idea here is that whatever you're having on the behind your server, you can propagate the cancellation thanks to the tear down logic. So you can cancel a request on the database or while calling another microservice or stuff like that. But you can do this only if you have like the right APIs to cancel this, because can you cancel an SQL request if you're using an ORM or stuff like that? That will depend on the tooling you're using. So try to use libraries and frameworks that allow you, or tools that allow you to cancel what you're doing underneath. So the key takeaways is to think reactive. Well, if you're here, you're probably already doing that. And choose observables, even if you have like a single value stream. Single value stream might sound like an oxymoron, but you can, if you have an observable that pops only one value, still use observables because you have the tear down logic there, which is very important. And do not ignore the tear down logic if you implement your own observable manually. Think about returning a function that will tear down your observable. And you can use RxJS everywhere, and that makes it really cool. So the front end can cancel a request and propagate the cancellation to the server, which use RxJS to call the database and cancel the query on the database, and that's really awesome. And anyway, we can stay in touch. You can follow me on Twitter. You can check some content on Marmicode. There's a blog post about this. And you can find on Marmicode my upcoming workshops and courses. And if you need any coaching, just can get in touch. Here are my links. You can find the slides on the link below. And this is a promotion code. If you buy a workshop on my website or anything, you can use this, and so we'll give you a discount. Well, anyway, if you have any questions, just let's get in touch on Twitter or anything, or email me or whatever. Well, sorry for taking a little bit more of your time, and thank you for watching, for having me here. It's my first time actually it's live, and I'm very excited to be here, and it's really cool. Thank you, Jen, thank Ben, thank you all for having me here. And giving back the mic.
Thanks a lot for that talk. Yeah, that's very interesting. Yeah, we were running a little bit over time, so I'm gonna bring in the community partners who helped us with with spreading the word for this event. And yeah, thanks, Younes, and we'll catch up.
Thank you. Bye. Sorry.
All right, so I'm gonna bring in. Let me see who's here. Alex is here. Suhas is here. Santosh. Alexi, am I pronouncing that correctly?
Yes, pretty much correct.
Good.
89% of correctness.
89%. So what's 100%?
100% is Alexei.
Isn't that what I said?
It's very close.
Okay, so we don't have Alex and Suhas, well, at least not on camera. We have them here. So thank you everyone for joining us. As I said, these are some of the communicators who helped us spread the word for RxJS Live. A lot of people actually registered. Like there's 700 plus registered, but I think most of them will be watching, the recording instead. Because obviously this is in the middle of working days, so that's probably why they're not here. But it's a good thing that it's recorded. But yeah, I just wanted to really chat with you just to know a little bit about the communities that you're running. So maybe we can start with you, Alex.
Alex, you muted.
Yeah, I was doing that earlier.
And
that's like the phrase of the day. Okay, he points as well. Alex, are you back with us? All right, no. Okay. Oh, hi, Alex. You're on mute. Hang on.
Still on mute.
What about now?
There you go. That's better.
Oh my God, that took a little bit. Yeah, but I'm Alex Brakovic, and I'm a front-end lead at Vanguard Australia. I'm also running the Angular Australia community, which is one of the largest JavaScript communities here in Australia. And Components Conf, which is an annual JavaScript conference with exclusive focus on front-end frameworks and libraries. So yeah, that's me.
How many like NG groups do you run? I know Alexi also runs like 2, if I'm not mistaken. So you run what, Melbourne and?
So I run Angular communities in Melbourne, Brisbane, and Canberra.
Okay.
Yeah. So I think there are large that
Okay, he's breaking up, so I'm not getting the last part. Yeah. Okay, but yeah, I know you run several communities. Okay. We'll move on to Suhas for now, and then maybe we'll come back to Alex because there's a bit of a delay and he's breaking up. Suhas, do you want to just quickly introduce yourself and the community you look after?
Yeah, sure, Jen. Hi, guys. I'm Suhas. So I'm currently working as a senior software engineer in in South India, and myself and Sundaram, we both run a community called NG Kerala. It's a kind of, we started during this pandemic situation, and we conduct events mostly on Angular and Angular topics and RxJS, and yeah, and also we had a South India's largest Angular conference in January 2021. We had our first edition with awesome line of speakers, and we have planned to conduct this event every year once, and to grow the community. Yeah, so that's about myself.
So the group is very new. You said it was formed during lockdowns, is that correct?
Yeah, yes, Jen. We started this during March 2020.
Okay, so around the very start of lockdown. Okay. Well, yeah. Thanks for for helping us for this conference and spreading the word. Moving on to Alexei.
Hey everyone, thanks for inviting to this discussion here and organizing this awesome conference. I see it's already running more than 8 hours, which is quite a long time. So yeah, my name is Alexei. I'm involved into Angular community and a Google developer expert based in Sydney. So meetups which I'm involved, front-end tech, that's meetup group all about front-end frameworks and web technologies, PWAs, which stands for progressive web applications, and JavaScript, anything basically web platform related. And the other meetup I'm involved in called Angular Sydney, everything about Angular, any topic. We're running on monthly schedule, so next week we're gonna have another meetup about Angular material. And also I'm a host at Angular Rocks, which is podcast, which is all things Angular podcast. So it's very Angular specific podcast about different aspects of Angular and very beginners friendly. So if there's any beginners out there want to learn Angular, check out Angular Rocks podcast. Thank you.
Yeah, there are a lot of good podcasts, right? And yeah, there's a lot of Angular. The next person actually, I think, does a podcast as well in Angular, if I'm not mistaken, Santosh, correct?
It's not Angular specific, but yeah, I cover everything.
So you cover Angular as well.
Yeah, that's what actually it's a live stream which I'm doing, so it's separate from the podcast thing. So
okay. Great. And do you like to run like a specific meetup group here, or you're focusing on your podcasts?
Actually, in 2019, I had started the meetup group. So it was called Pune Tech Meetup, just to actually promote Angular. But of course, meanwhile, 2020 came, everything was shut down. So I decided to actually start a new initiative. So that's how actually Tech Talks with Santosh came in. So I started that in July 2020, and I think I'll just complete a year now in a few months. So where actually I actually invite the speakers from different technologies. It's not Angular specific, but yes, there are a lot of Angular talks as well, especially the one very big discussion which we had on Angular testing. So it was with Lars, another amazing community member. So yeah, that's been going on. And apart from that, I'm actually running a free workshop on which is like live streaming every weekend, 6 to 8 p.m. IST, Indian Standard Time. So in case anyone wants to join, they can join there. I also have a Discord channel where we discuss about the things which we are working on, or anyone who needs help on open source or anything related to the errors they are getting, right? So we can discuss about it. So that's what I'm doing right now.
Okay. So I mean, you four are like just part of the pool of people and community leads who actually helped us. There are, for example, groups in Thailand, in Japan, in Malaysia, who have helped as well, and other groups as well. Whether they're Facebook or Meetup, some of them have also helped spread the word. That's why we reached 700 plus. And there are several from India who are not here with us, like Podcast is supposed to be here, and NG India is not able to join us. Who else is from India? I think there are other groups. Hopefully, I haven't gotten one. But yeah, so thank you very much again for your help, because obviously that's how we are able to spread the word to people like yourselves. Okay, Alex is back, so I'm going to add him. And yeah, so hopefully we'll be able to continue the relationship that we've started. I know some of you actually wanted a longer Q&A. Hopefully Ben would be able to make it. We'd let him know. Obviously right now it's like 4 a.m. in Austin, so hopefully he's sleeping. And yeah, I'll find out if he's happy to do that. I think Alexi, you're the first person who mentioned it to me, whether someone from the core team can be present at one of your events. But I'm thinking, if we're doing that, maybe we can invite the other groups as well from other countries. If that's okay with you, I think that would be great. Just going back to Alex, actually, because he was breaking up earlier, so we didn't really manage to catch everything that he was saying. Alex, back to you.
Oh, back to me. So I'm not sure what they actually heard and what not.
Okay. I think
Yeah,
Alex.
looks like technology is breaking down. It's
Yeah, don't worry. I had the same problems earlier, and I'm using 2 laptops. Like one breaks, and then I'll move on to the other one. So yeah, don't worry about that. But yeah,
don't use Australian internet during streams. Tips
Here you go. That's like the best tip.
Anything particular with Australian internet? Okay. Well, I
So yeah, as a number of people mentioned, like the COVID and all last year kind of really put a break on pretty much every kind of event. But in Australia, we're actually opening up now. So yeah, probably basically face-to-face meetups are restarting. And so yeah, we are planning the next meetup basically in about 4 to 5 weeks time. So that's very exciting to actually go out and meet people again.
Yeah, I know. Yeah, I'm actually looking forward to having in-person events, again. But obviously, New Zealand and Australia, you're way ahead of us. And of course, we know the situation in India, and hopefully, I know people I know some people in the tech community who's been driving fundraising, efforts for India. We actually did a shout out earlier. Ben and I mentioned Sunil Pai. So he's based in London. I believe he was part of the React team before. So yeah, he's doing a lot of effort fundraising wise. So if anyone you would like to kind of support what he's doing to help India, I think that would be very, very, very much appreciated. And thank you again to the 4 of you and everyone else, from other communities who helped us, as I said, promote this event. We will obviously be sharing, the recordings with you, and then you can share it, with your network as well, so they can learn from the talks, that we've had here today. Okay, I think I'm gonna like end this session and then bring in our next speaker, Matt Podwysocki. Let me just do that. Thank you very much for joining us.
Thank you. Bye.
Thanks, Jen.
Bye.
Thank you.
Thank
Thanks,
you.
Jen.
Okay, so I know Matt is actually present. We recorded his talk, but he's present and he's. I know he's interacting on the chat. So if you've got any questions about his talk, he would be able to answer them via chat. And I'm just gonna get started with sharing his talk now.
Welcome everyone to RxJS Live Asia. I hope everyone's been having an amazing time so far learning all things about RxJS from the people who write it and the people out in the community that have been doing some really, really amazing things with it. I am the last speaker here of the day, so I just wanted to give you all a little bit of a perspective of where RxJS came from, as well as some ideas for the future. It's still hard for me to believe that it's 11 years ago that RxJS really first came to be, and even reactive extensions well before that, maybe 14 years ago, and yet here we are at a conference dedicated to RxJS. And it's really amazing to me how it's evolved over time from something that was kind of written by hand and then later constructed with tools like Grunt and Gulp and so forth to what it is today is really mind-blowing and awesome. So today we're just going to talk about how we go above and beyond what we already know with the observables. So who am I? Who the heck am I? Well, I'm unoriginally on the internet. I am Matt Podwysocki, aka Lambda Calrissian. And I'm also on GitHub as well. And occasionally, just occasionally, I'm on Twitch when I do various live streaming and code and so forth. And yes, I still do wear the hats, although it's kind of hard to wear it and wear these headphones at the same time. But I hope coming soon to a theater or venue near you that I can wear this again. But yeah, do check out that out, and I hope at some point in the near future that I'll get back to streaming again. So I work at this place where we've created some really breakthrough technologies such as Clippy and Comic Sans. It's a small company out of the Seattle area called Microsoft. And in that, I've been there for a good number of years now, where I first started working on the reactive extensions back in 2009, 2010 timeframe. To where we are today, where I'm working on other projects. So currently, I'm working on a team called the Azure Notification Hubs. So if you think about push and push collections, you're exactly right. I'm kind of in my alley here, where we're talking about push notifications at scale, pushing millions upon millions of push notifications to your phones, computers, watches, etc., on a daily basis. So like I said, is I'm really kind of into this whole push notification, push and reactive and so forth kind of model. But I first want to put it out to everyone that async coordination really is kind of awful. The way that we've had to do a lot of this in the past has been far from optimal, where we've had to adopt so many different languages and tools just to try and make our lives a little bit easier. But ultimately, it has its own problems in that a lot of the things that we try are non-compositional or hard to reason about, or you have one library that differs from another. And so all of these sorts of things make it really hard to compose things together in a single coherent story. And wouldn't it be nice if we had something that did allow for something to combine it all together? Because let's face it, that it really is awful. So what we've always been talking about with callback hell is still very true to this day, although it's gotten a lot less worse with time as Node has adopted promises and many other libraries have adopted promises. But it's still very much with us in a lot of the APIs that we use, that callbacks are fundamentally one of the core building blocks. And that's great and everything in that it allows us to build on top of them with promises, observables, and so forth. But by and large, they're very hard to reason about because it's not like I can easily compose these things. These callbacks are, or continuation passing style is where kind of everything happens at the end. So it keeps on building over and over and over and over. And the error handling mechanisms aren't automatic, so they had to become more idiomatic, such as with the callbacks returning error as the first argument and the results, if anything, as the second argument. But ultimately, it's really, really hard to reason about, which is why you had libraries such as async and so forth come out with ways of dealing with that. But even still, the idea of events still to this day are non-compositional just because of their nature, in that it's basically the subject observer pattern, the subject being a DOM element, for example. Then we have the observers, which are basically the event listeners that we add onto our particular pieces, such as mouse up, mouse down, and mouse move, etc. So, for example, if we wanted to draw something, we would have to say mouse down, control whether mouse down and mouse up is happening, and if so, draw or do something, otherwise reset the state, kind of thing. So it's really non-compositional in the fact that you have to have these three different listeners doing three different things and not as part of one chain or anything like that. And yes, we do have a lot of things like promises, but for the longest time, we had promises that weren't quite complete. They had their own set of problems, as it were, because it had a number of issues. The first one was that you couldn't really cancel a promise once it went out the door. It was in a microtask, and it would finish when it finished, and it goes to the then or to the catch, depending on whether it succeeded or failed. But there was nothing fundamental in the promise itself to say like promise abort or anything like that. But we did have libraries such as Bluebird and others that physically added the abort syntax to the promise, but that ultimately was not accepted as a thing necessarily for promises. So instead, what we got was this. So a lot of people instead stuck with the old XHR or XML HTTP request, because you had the abort semantics. But just as well, we didn't have any way to deterministically say something was finally going to happen either. You just had a cavalcade or a cascade of thens and catches, and so forth. But there was really nothing to say do something at the end. It did finally make its way through, but there is a kind of a standing joke here of how many engineers does it really take to cancel a promise? And by the number of comments there, you can kind of do the math yourself of 240. So sure, certainly it became a thing eventually, which is great, because now what we have is we have the ability to use the .then syntax and so forth to get our response and turn it into JSON and then log it out, but also to catch, for example, anything being aborted. So we can say that we can create something through the abort controller, and the abort controller was first standardized through the DOM and has now been making its way through to Node as well as a standard way of doing cancellation. And now when we go to async await, we have this very deterministic way of starting, like for example, starting a spinner, doing a fetch, getting the response back. But if it's an abort, show don't do anything. But if it's something other than an abort error, show the error message, and then finally stop spinning. That in itself is really, really powerful in that we now have this mechanism, which is actually external to promises that people can start to use in a number of other things. But the fundamental question is can we do better? And if you're like me, I'm in that situation where I was dealing with callbacks and promises and everything else, and we all these disjointed APIs, and asking myself, really, could we do better? And the answer is of course we can do a lot better things if we think about the past, go back to the past, and think about some of those things that we've learned in the past. So let's go back to the days pre Windows XP, and let's think big. I don't know how many people actually remember those days pre Windows XP, but we'll just go with it and dream big about what we can do to make asynchronous programming less awful. So in 1973, we had the actor model. And the actor model was inspired more by physics and so forth, and languages such as Lisp and Smalltalk and Simula, where you could have a number of these independent agents or actors, and the only way that they communicated with each other is through is directly from one actor to the other. So we can have ping and we can have pong, for example, where they can send messages back and forth. And this is just using a third-party library in JavaScript, but it's a fairly decent way of doing concurrent programming. If you think about if you think about things like Erlang is really good at doing everything's an actor and everything's separated, isolated memory, and let it crash, etc. In JavaScript, maybe it's interesting, but it is definitely something to think about, where it's really got these core pieces where they can send a number of messages to another, and then designate the behavior of what it does when it receives a message is really kind of interesting. So it's how it's isolated itself from another, and how it isolates state and so forth. Another way we could think about it is this notion of CSP, or communicating sequential processes. Now, this differs from the way that we were talking about actors previously, is that instead we have these independent channels, for example, channel A and channel B here, that are independent of one another. And the way that those two processes, process A and process B, can communicate is through channels. So I can say, put something onto channel B, and someone else can put something on channel A, and so forth. And this was created back in 1978 for a way of talking about concurrent systems back in 1978 by Tony Hoare. And it's been kind of the default way of thinking about asynchronicity in such languages as Go and, of course, Clojure, but hasn't really caught on as well in the JavaScript world. just like the actor model, it's fairly, you have to wire up a lot of things yourself, and there's no, for example, common way of handling errors and so on. So you've got kind of these channels, but up to you in terms of how you want to do any error handling or any number of those things. So really, are there any other options? So going to 1994, the Gang of Four book came out, and it really describes a good number of patterns that we use in a lot of today's languages, such as the iterator pattern, such as iterating over an array. And then they also had such things as the subject observer pattern, which was also kind of cool in that you had this idea that you have this subject and it could push values to you over time. And whereas the iterator, you pull values from it. So there was this duality of push to pull that, although they never formalized that directly in the book itself, when creating the reactive extensions, we actually did kind of say, well, really, it's kind of a flip of one to the other, where one is a distinct pull and one is a distinct push. Now, I always like to be a little controversial and talk a little bit about functional reactive animation and FRP, in that when I describe reactive extensions and so forth, I don't ever say it's FRP. And the reason is because that was really defined as something else. And it was defined back in '97 with functional reactive animation, or FRAN. And it's differentiated really between Rx, especially when there was a distinction of behaviors or events. So you had up top, you have this notion of a behavior which always has a value regardless over time, versus below, where you had discrete events happening, such as mouse clicks. Whereas behavior could be, for example, a mouse movement. You could always have a client X and a client Y. So that really kind of did influence, of course, some of our lines of thinking, that you could use maps, filters, flat maps, etc. over these kinds of things. And yes, we could always talk about monads, and what talk isn't complete without them, but I'll leave it up to the late great Joe Armstrong to really tell you what a monad is. It's a thingy, is the best way that I'm going to describe it. But really, Rx that came out of a design where we could, where you see the logo and you're like, wait a second, that's the RxJS logo or Reactive Extensions logo. Well, kind of. It came from the Live Labs Volta project, in which the idea was that you could write an application in C# and you can compile it down to JavaScript if you want to, or a desktop app and so forth, and have the ability to tier split and run part of it on the server and part of it on the client. But the real challenge is how do you marshal over an event, which is this thingy, over to the client and back and forth. And that's what really led to the design of the observable, just as well as this whole notion of language integrated query, or LINQ, in which we are talking about how we can use our mouse as a database. So your mouse is something that you can query. You can query its mouse coordinates, its mouse clicks, every kind of thing that you can get out of it is something that's queryable. So a mouse should be no different than a database that you can query it. The only difference was over time, and that really led to this whole reactive extensions that you see today, where you can literally write it in the language of your choice. And there are so many other languages, and depending on their popularity and so forth, that they continue to this day. So when we talk about where the observable belongs, we're really talking about asynchronous over time, and multiple values, just as we can do with iterable, where we can do maps and filters with arrays. We can do the same with observables. The duality being the push versus pull, just as the object of assigning and the promise of the value being pushed back to you. But during a push-pull model, there are a number of problems that can ultimately happen. And quite honestly, it's things can overload. There are many problems with that observable design in that everything is largely based upon a pure push model. The pure push model meaning that if the producer is sending so many things that the consumer cannot keep up with, then the consumer ultimately dies or does something here, or ultimately shoves chocolate in their mouth. You couldn't imagine reading a 2 gig file or things like that directly and having the system throwing all those bytes at you as fast as it can, regardless of how fast you can process it. So that's the real issue. And how do you solve that? Well, observables obviously can get you part of the way there, in that we have a number of things where we can kind of crimp the hose or kink the hose so that we aren't always going to send you or blast all of the data out at you at one time. It can be lossless in such a way that we can buffer or window it so that we're talking about giving you glimpses into your data over time. Or we can say there's lossy pieces where we don't care if we drop a byte, or we don't care if we drop a mouse event. We don't care if we drop the keyboard event, just because we are more interested in the aggregate and the whole. So it's really kind of a something that you can decide to do. But ultimately, it could also lead you down to the path where you have the observable hammer and everything looks like a nail, where although the observables are really good at what they do, maybe it wasn't the best choice for you at that particular point. For example, I use observables in a lot of the code that I write, but at the same point, there are places that I would never put it. And it really gives you a pull versus push kind of conflict that we have here versus pull push or push pull. Now, what I mean by pull push and push pull is they're kind of hybrid in the way that I can tell the system, hey, I want another value, and it will push it to me, versus the producer will push a value at me, and at my leisure I can pull it then into the system. So it's really kind of a hybrid of how to get there. And so when we talk about other data patterns, that's exactly what we're going to be talking about, is pull push and push pull. So with the recent versions of JavaScript, we've gotten this notion of an async iterable. And all you really have to do to implement this is implement the symbol.async-iterator symbol method, where you can yield pretty much anything, whether it's a string or a promise, and then you can for a weight of going over all of the values in there, which is kind of cool in the fact that now you've got this way of building up an asynchronous stream using yields and so forth. That's really kind of neat. And just as well, so instead of having a lot of the stream callbacks and event emitters that that Node has, you can use that as a general of reading through a file stream. So you can do try, catch, and so forth over these streams. So that brings us to the first thing, which is the IXJS async iterable. So IX is kind of the opposite of RX. So IX has the pull collections and the pull push collections, such as the async iterable. So if you know RX, chances are you'll know IX pretty well, because it follows the same kinds of principles. It's got the same style of operators. It's got the same style of imports and everything else, and largely with the same core team members as well, as trying to explore other avenues of querying collections over time with this pull push model. So we can do maps and we can do filters and so forth, and use the try, for, await, and try. And just as well, the built-in abort controller does not actually support abort syntax or the abort controller. So what we do with IX is we actually have a way to go in there and add in the abort controller that we've seen before and inject a signal in, so we can decide if at any point we need to stop hit the brakes, as it were, on the particular thing. So it's really kind of cool that we can plumb it all the way through. But to do that, I have to kind of go against the way that it's currently doing, because currently the symbol async iterator doesn't take any arguments. But if I really want this to go through, I have to kind of plumb it myself to do so. And then when we can implement an operator ourselves, such as map, we can implement it so we can for, await, and wrap this abort controller for us, passing in the signal, and then we can perform the map and yield the results through it. So that's really kind of neat, in that we can now pull over these things. And as you can see through transform data and filter data, is the fact that they all get the abort signal passed into them, so that at any point, if you need to send it to another operator or whatever, that it can propagate the the cancellation or abort semantics for you. And just as well, we have this notion of an async observable. So as we said, there are some issues with the observable itself. Why could we not just asyncify everything on the observable itself? And we do have an ongoing pull request on this to add in the ability to do maps and filters and so forth, and have concrete ways of creating an observable asynchronously, but also to tear down asynchronously. And that's something that currently Rx does, observables as was written, originally written, did not support. But not only that, but it didn't support the throughput of the abort signal as well, all the way through. So for this, it's more of a working to create this kind of fusion where we can deal with, say, network traffic in more advanced scenarios, where we're dealing with network traffic or other things where we're dealing with asynchronous closure and an opening of pieces, as well as awaiting data as well. So why do we have yet another library that we would even consider more than observables? And for the async iterable, for example, you put the consumer in charge of the data flow. First and foremost. So it's not like the observable where it's continuously throwing pieces of data at you. You actually have control. And not only that, but it has then deep integration with the node and DOM streams themselves. So DOM streams being things that are built into the browser, and then node streams or Deno streams built into those systems. And we can enable async projections all the way through with map, filter, flat map, and so forth, that each of those can be asynchronous projections as well. And with the async observable, it's kind of the same thing of putting the producer in charge where the consumer can pull as needed, but it also allows for those async projections, as well as the async creation and deterministic teardown, as well as adding in abort controller APIs as well. So really, when we're talking about this entire thing, we're talking about observable, async iterable, and async observable. But where will we go next? What is largely going to happen next? And there's a real interesting thing to that is that we can now start to think about this as being part of the browser or part of the runtime itself. So an iterator helpers is a proposal currently in stage 2 that was looking to add in things like map, filter, and so forth to directly to the array methods or iterables, and using IX as obviously as one of the inspirations for that. And I would certainly love to never have to write another library like this and have it directly built into the runtime itself. So following along this is pretty exciting. But now that I realize we are out of time, I want you to leave you with this, is that although we know the observable is amazing and awesome, there's a lot more that we can do when we start to think about other problems that we can solve with the same kind of techniques that we've learned using RxJS, but also using, for example, IXJS when you need it. So with that, I want to thank you very much for your time. This has been an amazing event in that it really gets to bring the RxJS community together and discuss ideas. It's really, really amazing, and it blows my mind every single time that I see anyone doing something with RxJS that I would never have conceived of years ago. So thank you very much, and bye.
Thank you for that, Matt. I know you're on the chat, so if anyone has questions, as I mentioned earlier, just type that in, and he'll be happy to help you with your questions. So what we're gonna do now is there's a little bit of networking at the end. I'm gonna just display the information that you need to join that if you want to. Let me just find that. So if you follow that bit.ly, you can network with other attendees as well. I don't know if some of our speakers are still here, aside from Matt. Hopefully, we'll see when we get there. But do join us using this link. I'm gonna leave this on so that you have the information. I think it's better if you leave it like that. Okay. Right, so hopefully we'll see you there. Thank you very much.